right after that.
Hey, welcome to APEC. We're starting the live chat here on the Alien Scientist channel so that we can get some people joining. We've already got a couple people in the live chat, I see. Some regulars, some new people. Cool stuff. Thank you for joining. And the show will be, the conference will be underway very shortly. So we're just all hanging out here behind the scenes while we get things set up.
Wonderful. And I think we're just about there. So thank you for the intro, Jeremy. Let me do this. I'm going to mute everybody out. Hopefully I will not blow my intro. And I'll do the intro and then we'll hand it over to Mark. So in 3, 2, 1. Welcome to APEC. It's September 25th, and I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Mark Fiorentino will discuss his model of super relativity. David Perez will join us from QED R&D to discuss the variable electromagnetic drive. Todd Desiato will be talking about spin-stabilized magnetic levitation. And Mark Sokol joins us live from the Interstellar Conference in Tucson with spot interviews for this year's conference presentations and exhibitors. So let me start out with a couple of quick reminders. I want to begin with a giant thank you to Chris Plain from the Debrief for writing Inside the World's Most Exclusive and Strange Anti-Gravity Club. And I'd also like to thank Futurism.com. And I know a couple of other venues have mentioned his article in the conference as well. So Chris, thank you, sir. That was wonderful. And in fact, we're going to try and get Chris on to talk about that article in the near future. Because of that article, we're anticipating a lot of new attendees today, and we've increased our Zoom capacity to squeeze everybody in. You can view conference replays, details, and speaker info on our website at www.altpropulsion.com. So I should mention, please save your questions for the Q&A session after each presenter finishes. You can raise your hand in Zoom using Option +Y on Mac or Alt +Y on Windows. You can also type those questions into chat, and we will go through them after each presenter finishes. So let me introduce you to our first guest. Mark Fiorentino is a self-taught metaphysician who worked as an accomplished troubleshooter for tech companies like IBM and Harris Government Systems. He worked as a computer and electronics technician and developed many award-winning state-of-the-art software programs that solve problems concerning failure analysis for electronic assemblies and computer systems. Today, he's going to be discussing a model that he has been developing for a very long time called super relativity, which is also the basis for his slip wave bias drive propulsion technology. So without any further ado, let's welcome Mark to today's event, and I will hand things over to him to get started.
Okay. Trying to share my screen. Share. Okay. Can you hear me all right?
Yeah, you sound wonderful. Yeah, thank you again for joining us. And yeah, go ahead at any time, sir.
Okay, well, I'm going to talk today about the origin of mass, gravity, and inertia. Basically, they're all the same thing. There's little bits of tricks involved in getting one or the other to show up, but it's the same process, mechanically speaking. Let's go on to the next slide, which is a basic introduction to my book that describes the theory of super relativity and more. Hopefully we'll get some video action here.
I didn't know what to expect when we started this interview, but I got to tell you, Mark, you're one of the best guests I've ever had the pleasure of having on. You've
Oh, thank you.
provided me some incredible, and my viewers, some incredible information here.
Okay, so without any further delay, let's get into the main show. I'm going to read most of this stuff because these are the words I've chosen and I want to present, and I might interject a little extra at the bottom. The overall strategy concerning the theory of super relativity is very sensible. I must complete Einstein's dream of a unified field theory. To accomplish this is a very challenging task. I use the evidence found in nature along with the correct interpretations, let's get that out of the way, given to us by the greatest physicists of all time. I use the same philosophy as Einstein. I followed his path. The Einstein approach, in which the geometrization of philosophy plays the main role in constructing the field equations of the theory. One of the principles of this philosophy is that laws of nature are just differential identities in the appropriate geometry. The theory of super relativity provides a mechanical explanation for how our physical universe works. We have been searching for the theory of everything for over 400 years. Our physical reality. There's only one thing that physically exists. That thing is the ether. The ether is a quasi-elastic solid. It is the fundamental field. All things that we observe are simply different manifestations of this real physical object. All forces, energies, and particles are consubstantial with the ether. This means they are part of and the same within the ether. It is from this framework that I discovered the mechanical model that I call the theory of super relativity. I searched for and found the origin of mass, inertia, and gravity. Once I came to understand how the gravitational field is created, the discovery of the antigravity field rapidly followed. If we want to understand how antigravity works, we first have to understand how gravity works. By going through this process, many other scientific breakthroughs were discovered. So I started with Einstein's unified field theory, which basically is this. Electromagnetism and gravity emerge as aspects of a single fundamental field. The super relativity version deconstructs the Einstein version of the unified field theory into three separate types, aspects that are unified via motion within space. The primary field of force is the electrostatic field, or the Coulomb force. This is how the universe is created from this basic torsion field, the Coulomb force. The secondary field of force is the magnetic field. This is happens whenever a motion of charge causes magnetism. You never get magnetism unless a charge moves. The other secondary field of force is the gravitational field. This is caused by the accelerated motion of particles. When that happens, the accelerated particles cause a contraction in and around the particle. I'll get into all of those things in more detail later on. But I just wanted to gear your thinking a little bit there, steer it into the right direction so you can imagine the things I'm going to say. The evidence for the existence of the ether is on the next slide, so let's just go to that. Okay, so I got a for and against column here. Let's go through these. The light is a transverse wave. Transverse waves only occur in solids. This is known by many physicists. Einstein was one of the first to bring this up. That's a clear indicator, since particles are transverse waves and they're all throughout space everywhere, we can pretty much say that that is a strong indicator that space is a solid. The speed of light is a finite velocity. If space were truly empty and made of nothing, the speed of light would be infinitely fast, and we never see this. The distance equals rate times formula. If you convert it algebraically and you try to solve, if If space were made of nothing, you would wind up going infinitely fast, and that never happens. There's always a time interval involved because there's something out there. There's something real. There has to be in order to traverse that distance. If there was nothing there, it would take zero time. The ether has special properties of permittivity and permeability. Something that does not exist cannot have measurable properties. This has been a confirmed fact and measured that the space does have these properties. Therefore, there's something there. General relativity holds that gravity is a geometry. The spatial properties of permittivity and permeability determine the maximum velocity of light, which was discovered by James Clerk Maxwell, in which C equals 1 over the square root of permittivity times permeability. That is a vitally important equation, and it's going to come in play later on in this discussion. Gravity, mass, and inertia are all caused by a contraction of space. You can't bend something that does not exist. The forces of electrostatic charge and magnetism are also deformations of the ether plenum. They are different aspects of the fundamental field. Particles are persistent. This is only possible if the ether is a solid. And I offer this evidence from authoritative proof from Albert Einstein. According to the general theory of relativity, space without ether is unthinkable. For in such space, there not only would be no propagation of light, but also no possibility of existence for standards of space and time, measuring rods and clocks, nor therefore any space-time intervals in the physical sense. The one and only thing that was used to disregard and discard the ether was the Michelson-Morley experiment, which failed to detect the ether wind. I thought about this for years to explain it, and then I suddenly realized the explanation was so simple. Super relativity explanation. The speed of light is constant relative to all other motion frames of reference. This happens because light speed is self-caused. This is what they did not know in the time when they did this experiment. They thought it would vary as the Earth moved through the ether. There would be an ether wind detectable. It's self-caused, which means its speed is dependent upon the internal structure and has nothing to do with the emitting source of inertial frame of reference. Light speed is determined by its internal pressure gradient field. Therefore, the speed of light is independent from the velocity of the source and the observer. To give you an example, if you're standing in a train in use, it's going 100 miles an hour and you shoot a beam of light toward the wall in the same direction as the train is moving, the speed of light will not be 100 miles an hour plus the speed of light. It will be the speed of light. And if you turn around and go the other direction, it will not be 100 miles per hour minus, it will be the speed of light. And this is a known fact, and this is why the Michelson-Morley experiment failed to detect the ether wind. They did not know that light particles always travel at this speed. So it was a problem in the design of the experiment, and unfortunately, it was misinterpreted to mean that the ether did not exist. These are the primary men that I used to guide me in my theory. Newton for his mechanics, Faraday's for his laws of induction, James Clerk Maxwell for the understanding of the ether and his electromagnetic theory, Hendrik Antoon Lorentz for his ether model, the quasi-elastic solid, and Albert Einstein for his work in special relativity and general relativity. Super relativity, definition of force. Force, or action at a distance, is caused by deformations within the ether medium. Stresses and tensions within the ether are the real and physical fields of force that we observe. These different types of deformations of space comprise the various aspects of the fundamental field. Basically, what I'm saying here is that magnetism, for example, is a specific bending of a continuous solid medium. And then when I mean solid medium, I mean something which is continuous. The possible deformation types of the three-dimensional continuous medium. Negative charge is a clockwise rotation of space. Negative charge has lines of force moving inward toward the core of the charge. These things were determined as far back as Faraday. Positive charge is counterclockwise rotation of space. Positive charges have lines of force that move outward from the core of the charge. Then there's the stretching of space, that would be antigravity, and the contraction of space, and that, of course, would be gravity. These are the only real ways you can deform a three-dimensional object. And we know it's three-dimensional because of the inverse square law. If it were four-dimensional, it would be the inverse cubed law, but that's not what we see. It's definitely a three-dimensional space. Super relativity and the primary forces. Now we're going to get into more detail about the electrostatic charge, the magnetic field, gravitational and anti-gravitational field. I'm going to characterize and I'm going to categorize things. Torsion field is the electrostatic part. It is a twist of space. The vortex structure of charges is the cause of autonomous particle velocity. The vortex particle structure creates a gradient pressure wave within all particles. That is the slip wave. It is the primary field. This field is indestructible and persistent. It's persistent because space is a solid. If it were a liquid or a gas, we would not be able to maintain particle structure. To give you an example, space is really a finite and unbounded. So if you have a rubber band, which is a finite unbounded system, and you wanted to put a particle in it, a twist of space, you could cut that rubber band, twist it, bond it back together, and you would have a particle that exists within that universe and is impossible to get rid of. You cannot unwind it because it's in an unbounded space. And that's the same thing that's happening in our realm. If there was an edge to space, if there was a finite property there, it would be possible to destroy particles and the universe would die. The magnetic field of force. It's a torsional reaction to moving charge. Space rotates within and around the moving charge as the charge moves. Space stretches because of the rotation. Spatial density and pressure decreases when this happens. Permittivity and permeability will also decrease. It's a secondary emergent force. That is the magnetic field. The gravitational field is a hyperbolic field. Space contracts as the result of an accelerated motion of unbalanced charges. It's a founding fundamental principle of the theory of super relativity. It's a secondary emergent force. It requires motion of particles. Anti-gravitational field of force is the inverse hyperbolic field. Space expands as a result of linear motion of balanced or unbalanced charges. It is a secondary emergent force. Okay. All right. Energy in motion equals mass. Energy is defined as the ability to do work. Work is done whenever a force is exerted over a distance. Force in any interaction that results in a change of motion of an object. A force has a magnitude and a direction which makes it a vector quantity. Newton's second law is a critically important clue. Einstein's E = mc squared in special relativity. Mass and energy are equivalent. In both formulas, mass is associated with a moving force or energy. There is a pattern to be recognized. This equation here, then this equation here. In each case, something is moving in order to create the mass, a force or an energy. The linking mechanism to mass generation is the motion of energy within space. The motion of a magnetic force field will cause small electrostatic fields to move. This is a law of induction from Faraday. Super relativity, law of gravitation. The accelerated, this is very important. Whenever I say this, I think there should be a thunderclap happening somewhere. The accelerated motion of fundamental unbalanced electromagnetic charges will cause gravity, mass, to emerge as a field of force. It manifests as a gradient field of contraction. Space is made to contract in and around the particle according to the Ehrenfest paradox mechanism. I will explain that later on. Mechanical cause of mass, gravity, inertia. In each case, the causal nexus of the phenomena listed above is the same. The key linking factors come from the three of Einstein's discoveries, the equivalence principle. Somehow, gravity and accelerations are equivalent. Special relativity contraction of length as a result of increase in velocity relative to the ether. Special relativity's increase of mass as a result of increase in velocity relative to the ether. The rest mass of particles comes about as a result of uniform circular motion, which is the angular momentum. Whenever an unbalanced fundamental charge accelerates relative to the ether, the space in and around the particle continuously contracts. That's rest mass. The spherical contraction of the particles that have a so-called rest mass is the cause of the gravitational field. Inertia. This is one that really stymied everybody in physics for many, many years, including myself, but I finally was able to work it out. Inertia comes about because of a linear, uniform acceleration of motion. When a massive object is forced to accelerate, an inertial mass increase is caused by the act of the contraction of space in and around the accelerating object in the direction of motion. All of the object's particles contract in the direction of the accelerated motion, and their mass increases as a result of this additional contraction. This comes from special relativity. The electrostatic field of force. This is the path to the unification of the primary forces of nature. The electrostatic charge field is the autonomous particle motion is caused by a torsional field structure. All particles are vortex field structures. The electrostatic charge is a continuous vortex field. It exists within the ether and is consubstantial with the ether. Particles such as the electron cause within themselves a pressure wave gradient. This is the slip wave. The slip wave is the cause of perpetual motion of all particles. And what I will eventually do is reuse this design, this intelligent design, to create the slip wave spatial bias drive, so we can apply that technology of the particle to creating a warp drive. The magnetic field, once an electrostatic charge moves within the ether, the space in and around that particle is caused to rotate in response to the moving charge. The magnetic field is a torsional reaction to moving charge. Space simply rotates around the particle as the particle moves within space. Gravitational field, unbalanced fundamental charges such as the quarks move in a highly accelerated trefoil knot pattern. This trefoil knot is also rotating and forms into a dynamical geometry equivalent to 3 spinning disks. These spinning disks are rotating, and this spinning geometry can then be approximated into a rapidly precessing spinning sphere. Here's a little video that shows you how I see the electron, how it should really look like, if you could see inside of one. The white dot here in the center is the front or the beginning of the rotation. So you can see as it proceeds toward the back, space separates and becomes wider, less dense, and that's basically how it looks if you could see inside of an electron or any particle. Now here we get into things that really are interesting. We get into the particle motion, which breathes life into the universe. The concept of kinematics is the greatest weakness in all of physics. Kinematics is the branch of mechanics concerned with the motion of objects without reference to the forces which cause the motion. This is a catastrophic weakness. And because we haven't studied the cause of particle motion, we really haven't advanced in physics. It's critical to know why particles move. And you can see here, this drawing is a drawing of an electron. And basically, I'm showing you how space is rotating more and more, and the external pressure increases. As we move toward the back end of the photon, you can see the arrows of pressure coming from outside are pushing this electron in this direction. As the degree of rotation increases, the spatial density decreases inside along this axis. So energy particles are energetic because they have an autonomous motion. Autonomous motion comes about as a result of particle structure. Force, action at a distance, comes about as a result of a particle to space interaction, and is not because of a particle to particle interaction. And to prove that, to back up how important this concept is, I get a quote from Einstein's unified field theory in 1930. In the last few sentences of that paper, he says this: I was able to show that the field equations yield equations in the first order approximation that correspond to the Newton-Poisson theory of gravitation and to Maxwell's theory of electromagnetic field. Nevertheless, I'm still far away from claiming the physical validity of the equations I derived. The reason for that is that I did not succeed in deriving equations of motion for particles yet. So he knew that it was important to figure out why and how particles move. Path toward unification, torsion field theory, the Coulomb force is the primary field. The motion of charges causes magnetism, as I have already gone over. The accelerated motion of unbalanced fundamental charges causes gravity. The pattern to be recognized. I remember the day I saw this after staring at this standard model here for every day and asking myself questions about, I wish you could see that better, but questions about why some particles have mass and others don't. All electromagnetic particles have mass except photons. This is my happiest thought. The fundamental balanced charges always move in a non-accelerated linear motion. Because of this special type of motion, they do not generate mass. Photons are the primary example. So from that idea, I built the theory of super relativity because I realized that all other particles move because they have angular momentum and they are accelerating. And when they do that, they develop mass. The photon, the only one, is a balanced charge that moves in a straight line at a constant rate of speed. It's not accelerating, no mass. It's the equivalence principle come to life. The reason behind it, why gravity is the same as acceleration. All right, the pattern of clues that led to the discovery of the central cause of mass. I detected a pattern embedded in the standard model of fundamental particles and interactions. The clues that were linked together finally reveal the truth. Newton's second law, mass equals force divided by acceleration, Einstein's equation, mass equals speed of electrostatic charge there, and the speed of light. Lorentz's mass increase formula for special relativity also has a velocity of a charge at the speed of light, or a mass. According to the theory of relativity, gravitational mass is always the same as an inertial mass. However, when we speak of an object's mass increasing due to acceleration, we are really talking about its internal mass increase. The equivalency principle, a gravitational field is somehow equivalent to an accelerated frame of reference. Super relativity's mass is created by the accelerated motion of unbalanced fundamental charges. When charges accelerate, they cause a space in and around the particle to contract. That contraction is what forms the gradient field of force that we call gravity. So now I've just explained why the equivalency principle is what it is. It requires accelerated motion, matching the acceleration listed in the equivalency principle to the gravitational field. When a particle accelerates, it creates the gravitational field, and now we have an explanation for the equivalence principle. This is of a monumental importance. Now I get to the final solution, a modified version of the moment of inertia. I use this in my paper that I'll put a link to at the end of this discussion that you could read. It's about a 50-page long thing with about 45 pages of explanation to the math that I used to solve for the mass of the neutrino. This was required in order to prove the unification of force from electromagnetism to gravity. And I do that with this formula and a system of equations in which I successfully calculate the mass of a neutron, and it can be done with a proton or electron or anything else. The solutions vary a little, technically speaking, but it can all be done. It works very well. And where did I get the idea for this equation, which is a rank 2 tensor, which, by the way, Einstein predicted would be the type of formula that would solve the problem. He was right again. I got this idea to use this formula and this method from Einstein, who actually got it from Paul Ehrenfest, the Ehrenfest paradox that I spoke about earlier. And here it is. Einstein followed a line of reasoning that began with his happiest thought of his life. Still at the Swiss Patent Office, he conducted one of his famous thought experiments. Einstein imagined a circle spinning in space. The center of the circle did not move, but its circumference was moving quickly in a circular direction. Einstein compared what happens in several reference frames, a standard tool he had used in developing the special relativity theory. He concluded, using his special relativity, that the boundary of the disk contracted as it spun. There was a force acting on the circle at the boundary, the centrifugal force, and its action was analogous to that of the gravitational force. The same contraction that affected the outer circle left the diameter unchanged. Thus, Einstein concluded in a way that surprised even him. The ratio of the circle to the diameter was no longer pi. He deduced, in the presence of a gravitational force or field, the geometry of space was non-Euclidean. It was no longer flat, it was bent, it was bending. And from this idea, he built the theory of general relativity, all upon this. And he kind of kept this to himself a lot, although he did write some papers on it. He realized that this was important, that this was the actual mechanism for particles to create mass and gravity. He worked this out. He just didn't know about the quarks inside of the neutron and proton. If he did, he would have solved it in that time. He died 10 years before the discovery of the quarks. He was just born too soon to solve the problem. Now I'm going to show you something vitally important. What actually is going on inside of the neutron and the proton. These are the things that I worked out in my mind many sleepless nights, trying to see inside of them using my intuition and imagination, and then finally discovering the signature of God, which is the trefoil knot pattern that I'm going to show you here. These are the quarks moving about inside of the neutron and proton. This geometry supports both its binding mechanism and the force and generating the force of gravity. It's a perfect system. It does everything necessary to hold protons together for the entire life of the universe. They eventually spin so fast, they form, I've calculated this in another paper, at approximately 99% the speed of light. Now here again, I show it with the added dimension of motion of the rotation of the entire trefoil knot, because it's moving like this as well. Not only is it moving like this, but it's spinning and rolling. The end result will be a spherical rotation at near the speed of light. This spherical rotation is what I'm talking about in the Ehrenfest paradox. This is what's necessary to cause a contraction in this area all around the particle. So that's why the gravitational field is non-polarized. This mechanism accomplishes that. The neutron and proton are rapidly spinning spheres. We just saw it. There is a contraction of space that occurs at the perimeter of the rapidly rotating and processing neutron and proton spheres. The gravitational field is non-polarized. This is exactly matches what we see in nature. Neutrons and protons would have poles if they were not rolling and spinning at the same time. The key to understanding anti-gravity is first to understand gravity. I mean, that's what we're really here for. But I built all of this up so you can understand that gravity is nothing more than a contraction of space. So now that we know that, then we know that anti-gravity must be an expansion of space. The trick is, how do we get it to do that? Since we now know how to use motion for electromagnetic field to create a gravitational field, we must now figure out a way to reverse the process and cause an expansion of space by using the motion of the electromagnetic field. The mechanics of anti-gravity revealed. The electromechanical device that can be used to create an anti-gravity field is the electron. The key to getting the electron to make an anti-gravity field is to get it to move in a non-accelerated way. Normally, when an electron moves in an orbital, it has an angular momentum and therefore it is accelerating the entire time it moves within the orbital. In this case, the electron generates a small gravitational field. In order to make an electron generate an anti-gravity field, we must make the electron move in a linear, non-accelerated motion. This can easily be done by creating a current flow of electrons in a conductor. When a current flows within a conductor, the electrons follow the electrostatic lines of force created by the establishing a voltage. When the electrons move in this way, they only create a magnetic field. Michael Faraday established the laws of induction. Magnetism causes space to stretch. All that is needed to create an anti-gravity field is an intense magnetic field. A magnetic field occurs as a result of moving charge. A magnetic field is a torsional reaction to moving charge. There is a direct correspondence between the magnetic field and the anti-gravity. The stronger the magnetic field, the stronger the anti-gravity field becomes. Space is made to bend in the opposite direction. The anti-gravity field is an inverse hyperbolic field. When the magnetic field is put into motion or made to rotate, the anti-gravity effect is amplified. This is important. This is going to come into play in the experiment that I propose. The magnetic force in motion causes a very strong expansion of space. And that's just what we need to get our spaceships into other places and star systems. Additional benefits coming from the magnetic field. The magnetic field creates the anti-gravity field. The inverse hyperbolic field can be used to shield from the effects of gravity to build hovercrafts. A gradient magnetic field forms a gradient anti-gravity field, and this is what I call the slip wave. The slip wave is a pressure gradient field and can be used for propulsion. I believe it is the most common mode of propulsion used by UFOs. The intense magnetic field causes space to stretch, which causes a drop in spatial density. If you can imagine, since space is, I'm saying that magnetic field is a rotation of space. If you were to just put a piece of silly putty down onto a comic strip, a book, and then lift it up and look at the image, twist that silly putty, you will see that this quasi-elastic solid stretches when you twist it. And I'm just saying the same thing is happening in this real thing called space, the ether. The drop in spatial density causes a corresponding drop in the permittivity and permeability of space. This is crucial. This is how we're going to break the light speed barrier. This allows a space vessel, which is inside of the slip wave, to travel beyond the speed of light by Maxwell's equation. It says that, it screams it. Now, I'm giving you the way to make it happen. The inverse hyperbolic field also cancels inertial effects. The people inside the slip wave bubble will float and be weightless, even when the spacecraft performs very high accelerations and direction changes. All of the Lorentz transformation effects are canceled. Time passes slightly faster inside of the slip wave. Now I'm going to give you a little, this is not a perfect example, but it's something that people are talking about, and I will correct the errors in this video.
And here's why. This short equation may turn out to be a most extraordinary discovery. It might be our passport to the universe. And this is the sci-fi fan who came up with the idea when he was a college student.
I was watching Star Trek one evening, and I was on my PhD.
Trekkie, huh?
Yeah, exactly. And in Star Trek, they always talk about warping space and relativity, and I thought maybe there should be a way in which we can do this consistently within relativity and not just talk about it. So I went back to the office, and then I spent all Saturday in the office doing calculations, and I did come up with a model, with an idea in which you can do a warping of space-time that allows you to travel faster than light without violating any of the principles of relativity.
Alcubierre's college professor was so impressed, he advised him to publish it.
I've never published a paper before in my life, and they actually had to help me to write the paper and to know through the process of how you actually submit it to a journal, and it was published.
Alcubierre's equation shows it's possible to warp space and time and leap across the universe in moments. Here at the Multiverse exhibition in Washington, D.C., this travelator helps us understand how warping space-time can get us across the universe without accelerating.
The empty space behind your starship expands rapidly, pushing you in the forward direction. In the same way for this walkway, new space constantly emerges, which moves you along in that direction.
At the other end of the travelator, we get a sense of what's happening in front of my starship.
Space is compressed. In the same way in this walkway, space is being compressed, which moves you along. So you have the illusion that you're moving. Actually, it's space which is pushing and pulling you along.
To turn Alcubierre's equation into reality, I would need huge amounts of energy that would create a kind of bubble capable of warping space-time. At the front of the bubble, the space-time between me and my destination is compressed, pulling us together.
The front, that's wrong. That'll be a bad thing. You want what's back here in this section right here, the back end where it's expanded.
At the same time, space-time behind the bubble is expanded, pushing me forwards. And all this happens in an instant, many times faster than the speed of light. So I could fire up my warp drive and head off to anywhere I liked in the universe.
Okay, so this is the experiment that I propose. Please forgive me for the crude drawing. This spinning disc here of magnets is supposed to be flat underneath. Very similar to what Mark Sokol attempted a few weeks ago. And then you will see as the disc spins around and around, the motion of the magnetic field below the object with mass will cause a slight decrease in the gravitational pull below the object under question, under test. So what I propose now really is to, instead of using magnets in a spinning wheel, we use electromagnets permanently placed at each position, and turn them on and off rapidly in a very rapid succession. So you have this kind of rotating movement of the magnetic field within this circular framework. And so, there's 3 different configurations: an all North Pole, all South Pole, and all and varying north and south. Which I think maybe the varying of north and south will give the strongest magnetic flux, the greatest amount. So I would try that first, and then you would turn them on together in pairs, 1, 1, 2, 3, all the way around, continuously as fast as you can. The faster you go, the more powerful the anti-gravity field will be. Now, I'm going to show you something that looks a little similar to Jack Safari's, I can't say his name, spacecraft, which is the cigar-shaped or the needle-shaped or whatever. And I wondered for years why they use this shape. And after going through the whole idea of using magnetism and realizing that you needed to put room temperature superconducting coils at these locations to create an ever stronger magnetic field, until you get to the last one, you got the strongest field. So you've got a direction of motion going like this. Here's the front of the ship, here's the back. It's literally slips through space, catapulted by the immense force of the magnetic field, which is causing space to expand at the back of the ship. And it's expanding here too, but not as much. There is no need to collapse space in front. This would be catastrophic if they actually did that. You won't see that. In every instance that I've read about UFOs, I've always searched for any reference to magnetism, and I found it many, many times where people from the Air Force would go to landing sites and bring a magnometer. Well, why were they bringing a magnometer? Because they were going to look for magnetic fields. They knew something already. If they knew to bring that to a UFO landing site, they knew that UFOs generate very strong magnetic fields. And in some cases, they were able to take samples of grass where the UFO had landed and measured it and saw that the grass itself was magnetized. This is clear indication that they're using intense magnetic fields. In other circumstances, physicists were known to have observed a UFO and had a polarized lens. He looked at it and he saw that the light coming off of the UFO was polarized. And this is a typical case of when light passes through a magnetic field. Faraday discovered this centuries ago. Time and time again, you find instances and examples of people who, in many cases, physicists, who have indeed discovered that magnetism, high, intense magnetic fields are associated with UFOs. Now, metamaterials keeps coming up along with UFOs too, and I've explained why they would like to use and need to use metamaterials in the craft outer exterior. Basically, it's because in metamaterials, you can drop the permittivity and permeability within the material. This means that this thing will slide through space with almost no inertial resistance. And that's to the big advantage of a spacecraft. They have developed a material that has a refractive index of 0. The phase velocity has been declared as infinitely fast. This backs up what I'm saying. If you drop permittivity and permeability, you can go any speed you want. You can go at the speed of a god if you need to. All you have to do is control space, bias it by reducing permittivity and permeability. Some physicists have described this effect as an optical effect due to the geometry of the structure within the metamaterial. Permittivity and permeability have been reduced to 0. So this means that there is no impedance to motion of a photon within the metamaterial. Clearly, Maxwell's formula says that if you reduce permittivity and permeability to 0, light will move infinitely fast. And that is what I believe they have done concerning metamaterials. According to the theory of super relativity, space can be biased in such a way so that permeability can be reduced to whatever value desired. It's a metaphysical theory I have. The theory of super relativity is a philosophy of existence that relies upon intelligent design theory. Metaphysics is a branch of philosophy that deals with the first principles of things, including abstract concepts such as being, knowing, substance, cause, identity, time, and space. I am concerned with the fundamental nature of reality and being, which includes ontology, cosmology, and epistemology. Super relativity bridges the gap between objective reality and what we would call things that are abstract. So this means that our objective reality is manifest as a result of the act of creation coming from the Creator or God. All of this three-dimensional world is within God. There is nothing outside of God. Everything within this physical universe has to correspond to laws, and God set those laws. They are immutable as God is immutable. None of this, what we see and experience, is an accident. It is all intentioned by God. I believe that people who research things at the foundation of reality, which are things like gravity and antigravity, are on more than a scientific quest for truth. It's a spiritual quest. Einstein once said, "I want to know how God created this world. I'm not interested in this or that phenomena, in the spectrum of this or that element. I want to know his thoughts. The rest are just details." What I have discovered is the details are God's thoughts. The ultimate goal of modern day physics should be to develop a perfect understanding of the laws of nature. When we achieve this, we will have arrived at the theory of everything. Science without religion is lame. Religion without science is blind. Albert Einstein. And now we're ready for questions.
Okay. Sorry about that, Mark.
I gotta figure out how to cancel this. Okay.
Yeah, well, so let me do this. I want to remove the spotlight there. And actually, I can stop your screen share.
Okay, good.
Yeah, I'll stop your screen share. And so without any further ado here, before we move on to the Q&A session, I want everyone to put their hands together and give Mark Fiorentino an enormous applause. Mark, that was a truly great presentation. I really love that. You know, and especially the videos and the way you described everything, it just really flowed well, and it was incredibly explanatory. So thank you, sir. Okay, so let's move on to Q&A session. And I'm going to allow participants to unmute themselves. And let me see, looks like Wayne raised his hand first. So Wayne, go for it, sir.
Hey, that was awesome. Really appreciate that. Really appreciate that presentation. The way you broke it all down and made it quite understandable and tied together a lot of dots, connected a lot of dots that I have personally been considering myself for quite some time, and it's just great to hear you say it so succinctly and clearly, those things that I've suspected, and I'm sure others have as well, regarding the acceleration of charges and how those have produced seemingly, in different experiments, produced seemingly these forces and impulses, in particular the Podkleinoff, the high energy discharges that he worked with that produced that gravitational beam, allegedly. So yeah, I just uploaded a video about rotating permanent magnets, and I had it on a digital scale, and I was seeing some changes on the scale, and it's always hard to know whether it's, you know, just an artifact of the induction and the electronics or whatever, but there was some changes there. And also Mark was seeing some with his that rotating disc he made. So that's really neat.
That's the experiment we got to keep doing. We got to increase the sensitivity and increase the magnetic field strength, that's going to lead to the breakthrough. I am absolutely positive of that. That's why I wanted to bring up that experiment and add one more, which is kind of an Indiana Jones kind of idea. But we've noticed, many people notice that UFOs have a hum a lot of the time. And I believe that's because they're, especially in spherical shaped ones, they're doing just what I described in that experiment. They're turning magnets on and off rapidly and at really super high intensity, many Teslas, I'm sure, of flux is coming out of these things. Now, what we need to do is get somebody near a UFO with a portable oscilloscope and a coil of wire that's hooked like they used in the old AM radios, coil of wire hooked to an operational amplifier, and that's will be wired to maximum sensitivity. What we want to do is read for the rate of the magnetic pulses, how fast they're doing them, so we can reverse engineer this thing and get a jump start. If anybody lives near some place where UFOs exist and show up on frequent occasions, take this system out there with this sensor that I'm describing and try to get underneath it or as close as you can. Even a few thousand feet might do the trick. We want to see what type of wave. I suspect it's going to be a sawtooth, and what the frequency is. This is going to give us a good idea of what we should be doing when we build the experiment. It would be helpful to have. It's not absolutely necessary. I mean, we can do the experiment without knowing this, but I would like the confirmation that very strong pulsing magnetic fields are being used when they hover. So go on with your question.
So it sounds to me like we're going to be needing to be using superconducting coils to get the strong enough, flux densities that might make a.
It would be helpful. It doesn't have to be, but it would be helpful. I mean, we could still make some pretty strong magnets without that, or, it gets very expensive if you have to super cool the cable to get it down to superconductive level. I realize that. But, apparently our friends in outer space there have accomplished this. And I suspect strongly that the United States has already achieved room temperature superconducting wire and immediately classified it as top secret. So getting a hold of that stuff, it's going to be difficult, if not impossible. But I would recommend people go out and search for patents for superconductivity. There may be something out there that somebody overlooked. But it would be helpful if we had a room temperature superconducting magnets. But we got to do with what we got. And, the strongest magnets we can build, and we build a very sensitive measuring mechanism. We have to try to use objects that are not magnetically, ferrous materials for the weight, obviously would be a bad idea. You got to use something that's non-ferrous. You gotta even put shields around it, because the anti-gravity field cannot be shielded, just like a gravitational field. So you can rip along underneath it with an immense magnetic field. And if you want to be sure that you're not influencing the weighted object above, shield that, because the magnetic field underneath is going to do the work of shielding the gravity coming from beneath. So what we want to look for is a drop in the weight of the device above this apparatus.
Awesome.
Just one more comment, if that's okay. What you said about the constant current, flowing in a wire, making a magnetic field. If you're familiar with the work of William Hooper, in his paper, in a patent of his, he made a coil with the wires going kind of back and forth, and he made a big bunch of it, a bunch of these windings, and so the magnetic fields would cancel out. But he talks about the V cross B field being something like an electric field that causes like a gravitational gradient due to the converging of the lines of flux. But he measured with an electroscope. He measured that slight potential that formed when these currents would flow in this coil, which is basically just copper wire, like a huge bunch of it, bundled together, kind of like a beer keg geometry, you know, like thousands of these turns. So all of this,
Right.
so he talked
More
about
the better.
the electron drift velocity, you know, like these electrons moving with a certain constant velocity, and that would, you know, be your B field, and then the velocity, so V cross B, would cause this type of electric field which would extend outward into space. So it's very interesting. It kind of relates a lot to what you were saying there.
That's the kind of the Byfield Brown technique. You can also create a propulsion using electrostatic fields alone, because they're twist to space. And if you can bunch them up, you can create a pressure, you know, and they use capacitors, I believe, and you can get a propulsion using. You can't really use it for an anti-gravity shield. It does provide propulsion and an anti-gravity effect because you create lift with it. But that's also something that can be done with an electrostatic field. But that method will never work for interstellar travel. The best speed you'll ever get is light speed with that. And it will be fatal trying to bring your ship up to that speed using that technique without a slipwave bubble to be protected from the Lorentz transformation problems. That will occur as you accelerate toward the speed of light. You must be inside the slipwave or you will perish.
Okay. Well, so let me move along then, because we have several hands raised. But Wayne, thank you very much, sir. And
Thank you.
let me go to Michael Boyd next. Sir, go for it.
Hey, Mark.
Hey, Michael.
I got a question about super relativity theory. How would the theory explain things like black holes and black hole jets or neutron stars? You know, basically where you have basically my understanding of black holes is they're protons, and then neutron stars are a little different. But how would the super relativity explain those kind of star phenomena?
Before I answer, I'm going to ask you quick. Did you read the 3 chapters on cosmology in my book yet, or you didn't get the book yet, right? Okay, so you really want to know how that works in super relativity.
Right.
I explain that in great detail in super relativity. Neutron stars are like the foundation of the universe. The neutron itself is such a great example of intelligent design. It behaves, as you know, it behaves differently under this different circumstances. What's really handy for neutrons is their neutral charge. That means you can really pack them together very densely, and the stronger you pack them, the stronger the gravitational field is. So what is a black hole? It's a neutron star. It's a very dense, very large neutron star. And so as the neutron stars get to be a certain size, it gets denser and denser, bigger and bigger, and then it overcomes the ability, the event horizon comes into play, and light can no longer be reflected from it. So black holes, according to the theory of super relativity, are caused by neutron stars.
So are you saying then that there's electrons in a black hole?
No, just neutrons. It's neutronium.
But
All you got, you see what you got. You remember where I showed you?
I'm confused because, as you're aware, there are no free neutrons. They decay into a proton, an electron, and some neutrinos. So they're not stable by themselves.
They're not free.
They're not. A proton can be, you can have a free proton.
They're not free inside of neutronium. They're very closely associated. And in that instance, and in that circumstance, they last as long as the universe. If you were to take a single neutron, like you say, I agree with you what you're saying there, and you throw it out on its own in deep space. Within 15 minutes, it'll break down into a proton, an electron, and a couple of neutrinos. Isn't that kind of perfect? If you get hydrogen, and isn't that exactly what you need to build the universe? So odds are, what I'm saying is, in the beginning, the Big Bang, the cosmic egg was pure neutronium. And when it let go of not only a huge amount of neutron plasma, which, as you would say, in this particular state, it's isolated. All those neutrons within 15 minutes turns into hydrogen. That's perfect. That's just what we need to build a universe. And along with that comes multiple size neutronium spheres, the elements, the seeds necessary to begin the creation of the universe. Because as they come out, they pull the neutron plasma with them, which converts to hydrogen. And now you're building stars, because in my theory, the cosmology theory, star formation is caused by neutronium spheres rapidly spinning. They gather the hydrogen gas. They are the cause, the central cause of the formation of all stars. And if you look inside of the sun, as we have done in NASA with a particular experiment, which I always struggle to think of the name, it's a graph that they're determining the spin rate of the gases around the sun. And at the exterior, it's slow, but it's revolving. And as you get closer and closer to the middle, the gases start to become one, as if it were a solid. And then when you get really penetrate deep, it's spinning faster than the outer atmosphere. And that thing, whatever it is rock solid. Tackle line measurements, look it up from NASA. The evidence is there. It just has not been properly interpreted. They refuse to accept that there needs to be a cause for gravitational attraction of the hydrogen atoms, the proton. Protons, we know for sure, have an electromagnetic repulsive force orders of magnitudes greater than the gravity they put out. There is no way hydrogen clouds on their own are going to condense. You have to have a gravitational source. This is common sense. This should have been figured out decades ago. And yet here we are still trying to figure out how stars are formed. That's the theory of super relativity.
Thank you for your answer. I have one final question, which is, do you think our universe is an open universe that goes on forever, or do you think it's a closed universe? In other words, does it have an inner and outer event horizon, or is it just forever and ever? Thank you.
Good question. Very nice. You know, I've used techniques that physicists would never use to determine things like that. That's a very deep question. So I've used experiencers, near-death experiencers, who have claimed to travel beyond. Once you have passed away, you have powers, unlimited powers. And one person in particular said he wanted to see outside of the universe. So he did, and in an instant, you can travel anywhere by the speed of thought. And then he was looking at our universe, just this beautiful glowing orb with all the stars in it. And then he looked around and he could see other ones in like a grid work, but they were immensely far apart. So space itself is infinite. And the universes are being created, according to near-death people. Multiple people have confirmed this. They're being created by God. And in cases, he has shown them doing it. It's unbelievable to try to comprehend this stuff, because now you've asked a question that's beyond science. You're going to the core of reality itself, of who made it and how it's made. And that is something that you're going to deal with infinity and eternal. And it's a deep subject. It's a philosophic subject.
Exactly.
Thank you.
Yeah.
Philosophy and physics mix. Thank you again, too.
Well, Michael, thank you, sir. Thank you. Let me go to Harold next. Harold, go for it, sir.
Thank you for your presentation. That was excellent. My question is, it's a two-part question. I mean, granted that the Maxwell equation for the speed of light, basically one can derive that by reducing the permeability and the permittivity of a space, you can go faster than the speed of light. Now, my first question is, how does your super gravity theory, super relativity, addresses for the engineering principle to achieve a reduction of the permeability and permittivity of free space when there's so many particles like hydrogen and other particles in the space?
Well, setting aside the particles there, but you just want to bias the spatial field, the ether, this thing, which is a quasi-elastic solid. So what you want to do is cause that solid to expand using the magnetic field. And so when you do that, see, there's a metric that's happening here. You're affecting the metric of space, the actual distance of things. So under flat space, a Euclidean geometry flat space, it's at a specific number determined by permittivity and permeability. When you use the magnetic field to pull it apart, you're going to reduce those numbers because you're reducing the amount of space in a given area. If you took a meter stick out into outer space and held it there, and you hit it with this big magnetic field around it, the speed of light would actually go faster across that meter because of the magnetic field. And because of that thought, because of what you're asking, I went and searched for something. I went and searched for an experiment that they shoot a light beam across the magnetic field. And I found one. It's called birefringence experiment. Mm-hmm. And sure enough, over the past, I don't know, 60, 70 years, the quantum mechanics predicts that the birefringence means it splits into two. You know, it refracts. There's double refraction. Mm-hmm. And when it's expected that there will be a positive number for the birefringence measurement. And that's what quantum mechanics predicts, but super relativity predicts a negative number. The speed of light should increase. In other words, the ordinary wave, which is normally the fastest of the two, the extraordinary wave will be faster, even though it's got a longer distance to travel because it's in a magnetic field. And everywhere I looked, they keep trying this experiment and they cannot confirm quantum mechanics prediction. And that's all they will say. I even wrote them. I said, did you notice that there's going to be an increase? And then they got very defensive and didn't want to talk much anymore. There was a group that got a negative number for the birefringence measurement. And they retracted their paper. They were afraid of what was going to happen to them by saying one of the pillars of relativity, the speed of light is constant, is not really constant. And they did not want to go there. People get fired for claiming that. Look at what happened at the neutrino, the faster than light neutrino debacle. And so that experiment continues not to be confirmed. They just keep tearing it down when they don't get the expected result and retry it again. Something's up there.
Oh, no, thank you for the explanation. And the other question is, slide 23, you recommend an experiment. I believe that should work because I have done similar experiment with my propulsion system that I've been investigating using magnetic field. And I posted 3 videos in internet that show exam magnetic field producing a propulsion force, including wave reduction. I interpret it as thrust being produced by the arrangement of 2 orthogonal magnetic field, a rotor, one magnetic field spinning, like in slide 23, the other one is stationary, and it will produce a reduction in force. That I have confirmed my own experiment, which I will be posting video very soon on that particular subject. But my question is, I've interpreted as a thrust being produced, and that's why it looks like it is losing weight. But you do the other part that says anti-gravity, there will be an anti-gravity effect. So how can basically distinguish between the two on the anti-gravity according to your relativity theory?
You're talking gravity shielding.
Right.
But it's the same. If you create a gravity shielding, you're in the process of using and making an anti-gravity field. What you're doing is reversing the density of the metric of space using the magnetic field. So you're pulling it apart. And so that field, which is a contraction field, a gradient field, can't, penetrate through the magnetic field that's pulling space apart. So you're doing, basically, you're creating a gravity shield. So you'll notice the thing above you weighs less. What you guys all got to do is get together and combine your results and your experiments. Keep doing the good work that you've been doing. You're on the right path. And if we just can't count on the government, they're never going to admit to this. And like Potlikoff and Ling Ni and all these people, they're just going to write them off and say, they'll say they did the experiment and it didn't verify. It's this technology is top secret. It's the best, most important secret in the history of man. They want to keep it private. So we, the people, this show, what we're doing here is vitally important. And I commend everybody that put this together. I commend you all, Mark and Tim and Jeremiah and Jeremy, all you guys. You're doing the right thing and you're making history. Someday they're going to look back on this and say, these were the heroes, the ones that made the breakthrough, that proved it beyond a shadow of a doubt. And this world will be a better place for it. I'm talking a utopian dream. And I support this. I support this wholeheartedly, what we're doing here. And I've tried to do my part. But in the end, we all got to work together. I'm not a great experimentalist. I got, a little thing I've tried in my past, but I'm gonna, let you guys take it from here. You're on the right track. As long as you're using magnetism, you're going to make discoveries.
Well, thank you. You look like you're a great theoretician and keep on working. You're doing the right thing. Thank you for the encouragement.
Wonderful. Harold, thank you, sir. Okay, let me go to Thomas Anderson next. Sir, go for it.
There we go. Can you guys hear me?
Yeah, you're a little faint, but I can hear you.
A little faint. Okay. Maybe I can help that a little bit. Just that help a little bit.
Yeah.
Okay. I just had a comment, actually, more than a question about or a suggestion when he mentioned the difficulty of getting a hold of room temperature semiconductor technology because of it, being hidden and whatnot. Something I kind of thought of a while back. If you look at the chart of elements and their conductivity, the highest conductivity you can get in any element that's out there is silver, and it's actually a really super weak superconductor because it's 7% over that 100%, unlike copper that's just barely missing the mark at 99%. And somebody else had mentioned a couple of years ago that they're expecting silver to go massively up in price because they're going to find some sort of use. And he's using bot scrapers and whatnot, looking at languages coming from all these websites, from government websites to Twitter to anywhere else. And his supposition that he was getting is that it has something to do with the fact that the silver has a lot of radioactive, or I should say isotope states that have very long stabilities, so it would make them useful, and that would end up basically driving the difficulty to get your hands on it due to this. If they start finding a really good use for it, because one of those isotopes, they found a use for it. And it dawned on me, I don't remember when, but I remember hearing somewhere that to increase the conductivity of something, just add something radioactive to it. When it's an unstable material that's been added to a normal conductive material, it raises the conductivity drastically. So maybe enriching some silver and seeing if we can find one of those isotopes that would give us the room temperature superconductivity, even if it's only 200 or 300%. I imagine it would still give us the ability to do the other thing I was thinking of doing, which is to run an extremely high frequency EM field on your superconductors in order to get rid of the Brownian motion that's going on in the material that's all stuck together, so that it's all oscillating at the same time. That way all the electrons can be moved across each other with next to no effort through the system.
I see your idea. The key here, you want to build a superconductor, you need to make ion channels inside of that device. That's the key, so that the electrons can move rapidly, smoothly through the device without any resistance. And the first person that figures that out, my idea was to basically try different chemicals and materials and let the device cool while under a strong magnetic field, so that it would cool and crystallize in such a manner.
Oh, that way when you heat it back up, you can continue using it.
Yeah, it would, yes,
like
when it dries, it says, hey, I consolidated under a magnetic field, and because of that, I built ion channels. That's an idea that I think that they should try.
Yeah, I thought some time ago, like I've been experimenting with bismuth and iron and a couple other elements with bismuth, about like trying to use tinning of just one portion of the copper wire when you build your coils and whatnot, that bismuth is layered in there all the same direction. That way you could basically maybe increase the ability to basically to transfer the energy, so you get closer to that 100% of transference of energy with less losses and whatnot. And I have made just as an experiment to see if it would work, I used acid rosin flux like they use in normal soldering for electronics, to see if I could solder onto a piece of steel with the bismuth, and because it melts at such a low temperature, and it worked with no problem. I ended up with one of the shims that I did this testing on was a triangular piece, so I had a real slim triangular like sharp point on one end that I could hold down with my fingernail. And I found that when I approached the side with the bismuth facing up with a magnet, I could get 4 times closer to that thing before it deflected and started trying to stick to the attract to the magnet than I could when it was flipped over with the iron side facing. And my thought, because it was like 1,000th of an inch of bismuth on a 3,000th of an inch thick shim, is that maybe the bismuth, until you get close enough that the bismuth effect on the steel, in order to enhance the bismuth effect, because bismuth creates a mirror effect, whereas magnetically, whereas the iron mimics it. So it'd be like, looking at a mirror that you see the back of your head for iron. Whereas when you look at a normal mirror where you see your reflection, your two faces are facing each other with the bismuth, if you could get that iron to mimic the bismuth, you now have a really strong magnetic repulsion that's repelling those magnetic fields from the magnet until it breaks through to overcome the bismuth effect on it that's directly bonded to the material. And that's the only reason I could think that you could get 4 times closer from the bismuth side when there's literally 1,000th of an inch. It's like 25 microns of bismuth interfering with that magnetic field on that side, versus the other side, it's behind it. It's on the.
Are you a material scientist?
It's I guess you call there's a demand for that in what I'm working on, and I've been working on this since I was a kid. I've just had a lot more
You sound like an alchemist.
Advancement now than before, because of all the ability to obtain knowledge and whatnot, to build replicator level upgrades for 3D printing. Because once we have the replicator, whether it's just taking atoms and putting them together to get whatever it is you're trying to make, or you're using energy to matter conversion and whatnot, all of the other things that we've been talking about doing will be a snap, because you can assemble anything at home on a desktop. No one can stop you, and you become completely disconnected from the rest of the system. So there is no control mechanism where they can centrally like lock you down. Kind of like right now, if they want to stop you from having money, everybody uses banks. So they can go to that central location where your money keeps flowing through and interfere with that in order to interfere with whatever it is that they're trying to, affect on your life by using money to do that. You have a replicator. All you need are raw materials. They can be gotten anywhere. You don't have to go out and buy like this machine or that machine where you have to go to a specific company that makes those to get it where they can then interfere and get between you, kind of the way Apple does with chips to keep independent repairmen from repairing the Apple devices. If you can print those, Apple can't do anything. All you need is the information on what the thing is made, how it's made, and then you can mass produce them and even upgrade the design. Once you have that information, then you can look at it and say, well, okay, this is a little thin, so that's why it's cutting out whenever you barely hit like 5 milliamps at 5 volts. Let's make it a little thicker so it can handle that, or use a different material, can handle higher temperature, and cut out the corner cutting that was done for the part before.
Yeah.
Same thing can be applied to everything else that we're trying to do. So.
Well, Thomas, let me, and I sincerely appreciate it.
I should say one more thing.
Okay.
The reason I went through all that is because he asked if I was a material scientist. It's required for me to do what I'm doing. So that was just the explanation of why I have this kind of I guess more in-depth information on some of these oddball things that seem all disconnected. And,
oh no, well, yeah, no, and I appreciate your comment, and yeah, I mean you've had you've revealed amazing stuff, and you and Jeremiah have talked for hours on it too. But let me go to Mark Sokol next, and again, Thomas, thank you, sir. Mark, go for it.
Oh, to answer Mark Fiorentino's question to Thomas, yes, he is a material scientist.
Oh, that makes
yes,
sense.
He's like the garage tinker material scientist of our group, and we planned on having him on APEC. We're actually in talks with Tim, having Thomas on. He's putting a presentation together, and he has a wealth of knowledge on all different topics. This guy's freaking brilliant. So my question was about your the experiment that you showed, which is actually something we were already thinking of. We already are purchasing parts for it. We got the coils. There's a different design of a linear function as well, meaning that the magnetic coils are one on top of another. They're like pancaked. So you could do it like in a linear fashion, and basically a linear motor. Question is if you thought of any driver system to spin it, and at what RPM are we going to be spinning or turning them on and off?
I was thinking that you could use those high-powered silicon control rectifiers. You're familiar with that is what I would use. They're a little noise sensitive, but you can handle that.
Would putting a little bit of iron in, making them into a solenoid, would that help, or would that decrease the effect?
Well, any kind of a solenoid, it's got a reliability problem, but they have limits to the current they can handle, and that when you're clamping that thing down and that spark, and you're pushing big currents, right? As big as you can get, it's going to tend to burn those solenoids out rapidly. So I'm trying to think, you get the heavy grade military silicon controlled rectifiers and turn them babies on and off, and they can pump out some power.
And any specific RPM benchmark we should be looking for?
Well, that's why I proposed the other experiment. The one where somebody gets underneath or near a UFO with this sensing device and reads the frequency that they're using. See?
Oh, okay. So
I answered your question. You didn't even know. But I would recommend starting at 100 hertz at least.
Okay, fair enough. Thank you very much.
According to the theory of super relativity, the faster you go, the more amplified the anti-gravity, because you're causing that space to move. It's an elastic kind of thing it's mechanical. This is all mechanical. So you're causing it to move faster, and that faster motion causes a greater expansion rate, and you get an amplified anti-gravity or a shielding effect.
Right.
It's all about motion and force and motion.
Right. Later on, I hope to be able to present this. I have a spinning disc version of that with 6 neodymium magnets on it. And we're going to be throwing in also a high voltage potential across 2 plates. that see what kind of effects we can get. We had a couple problems when I was testing this in the lab the other night, so I brought it with me, and I'm currently working on a solder point that broke.
I love that you guys are doing this stuff. It's really critically important. Nothing happens unless you guys do this. I mean, we won't advance. We can't count on regular physicists. You know, they're stuck in the quantum paradigm, and we can't count on the government. It's up to humanity to do this on their own. That's
100% right. I was at the conference earlier, and Mark Millis, who's gave his last presentation of his career, he's retiring right now, and the presentation was supposed to be about alternative propulsion concepts, and it turns out that it was all theoretical assumptions that were, and then he had assumptions based on assumptions that will lead to a theory, and he was compiling them all in a database, and then that database is inaccessible. So he made an inaccessible database about assumptions on assumptions on assumptions of how we can get, and then I put in a question on the Q&A, has any hardware been developed? Short answer, no.
Well, and it's inaccessible for a reason. They don't want you to see how it's built on piles of.
I think another thing that they do is the tinfoil hat conspiracy joke that they push you off. Oh, he's just a tinfoil hat conspiracy nut. Where'd that come from? I think if you're on the right track, a tinfoil hat becomes your PPE, becomes your personal protective gear if you're on the right track for anti-gravity. So
when they use name calling, that proves they're threatened. Or they wouldn't do that.
Yep, when they use name calling, it means you're on the right track. So if you get name called, continue. If you don't get name called, then you should stop and reevaluate.
Yeah. That one I don't care about. You call me any name you want. Just try the experiments. Just try this. I'm just the information giver. You're the man of action. You are the guys of action that are eventually going to make
not just me. There's a lot of people in here.
Yes.
There's a lot of people in here that are
Jeremy, all
Mike
of you.
Gamble.
Yeah, the other guy.
Ron Kita.
There's a bunch of you, and the more the better.
Yeah, I mean, I would be here. I would be stuck here all day if I had to mention every single person that's actually getting involved. But putting your pedal to the metal, actual experiments is where it's at. That's what's important. And, we don't see enough of that.
Yeah, let me move along because I've got Will next, and Mark, thank you. I've got Will, and then this hands up thing. Actually, we're doing that again. That's I believe it's Option Y on a Mac or Alt Y on PC, and that gets the questions in order, which is really cool. It makes it easier to go through them. So, Will, go for it, sir.
I actually have two questions. On slide 24, I wonder, is your steering coils, are they stationary or moving?
Stationary.
You mentioned that you're pulsing from the front to the back. Are those like on-off coils? Or, they're pulsed on and off, or are they continuously pulsed at the same time?
I think it could work either way. But I imagine since so many abductees claim they hear a hum, that's a sign they're turning them on and off. So I'm going to go with the on and off based on that evidence from so many people. They all can't be wrong. There's something going on. You get a hum because usually there's a high intensity magnetic field somewhere banging away and causing things to move. Materials in the ship or whatever are being affected by that. So I'm going to say that's on and off. It's like a rowboat kind of going through.
And then you have the magnetic shielding coil on that. How is that rotating, stationary? Because you only have one coil.
I'm not sure which coil. Did you say magnetic shielding coil? No.
Yeah, you have the big oval coil.
Now, yeah, there's a shielding. I recommend two types, the reflective shielding and the ferrous type, where you concentrate the lines of magnetic flux, and the other one where you reflect them. You want to use every kind of shielding you can, because it's very unhealthy for people in the ship to be exposed to extreme magnetic field strengths.
Okay, so I guess my question is that the yellow one, does that rotate, or do you have many different yellow ones around the hull?
I'm not looking at the drawing anymore, but the coils, none of the coils are moving physically. No coils move anywhere. The shielding, the room temperature coils, they're all stationary. This is all done electronically. This is the beauty of the thing. Electronically, it's much faster, more reliable. You really don't want to use spinning discs, because the rate of motion, that they're going to have to be thousands upon thousands of hertz to get the same effect. And you better have a very well balanced system if you're going to do that, because the rigidity factor is going to come into play, and the balance factor is going to come into play, and you're going to have one wobbly flying apart spaceship. This is all electronic. No moving parts are needed. You turn coils on and off. You get the motion from moving the field back and forth. It's very efficient,
So then
much simpler to control.
my last question, I noticed you use the standard electron model. What role does Cooper pairs play in your model?
What, I'm sorry, I couldn't make out what you said.
Cooper pairs. What role does that play in the model? You mentioned that you wanted to have superconducting materials, which obviously use Cooper pairs in order to create superconductivity. So how does that, what role does the Cooper pairs play in your model, if any?
Well, I'm not a real expert on material science or Cooper pairs, but all I know is you need to make a very powerful ion channel in the superconductor so that the flow of current goes unimpeded. And if Cooper pairs helps that happen, great. If not, I don't know. I'm not into the real deep material scientist kind of guys. I highly respect what they do. And I think when superconductivity gets discovered, it'll be a material scientist, no doubt, that discovers it. Whether they'll be allowed to announce it is another story.
Okay, sorry, I said that was the last one, but I really do have one last one.
Okay.
The magnetic fields that you're proposing, how many Tesla? And if it's a large magnetic, if it's a very high Tesla, it also means that you're projecting your magnetic fields up to several kilometers from your ship. How do you keep the magnetic field more constrained so that you're not actually affecting everything around you?
Well, that's a good question. I suspect it's going to be over 100 Teslas, maybe more.
Well, then you're looking at a field that can go out several miles.
Well, not with any great
because we see that with the NASA test rig, which they put out into the desert, that was somewhere around 100 Tesla, and it was at least 3 to 5 miles around the perimeter of their test rig.
Well, we're going to have to see by experiment how much is needed. That's why we need to do these experiments. I'm just making a guess there. I don't have any mathematics to predict the anti-gravity effect. That's a whole torsion field theory. Once we establish magnetism is going to affect gravity and be used for gravity shielding, people are going to get on this question that you have. And because we want to know, we don't want to have to make it any larger. It may not be 100 Teslas. It may only be 1 Tesla. I'm just taking an educated guess. We need to do the experiments to determine that number and work with that number. That's why I also suggest you got to move this thing. You will need less Gauss or Tesla if you move the field rapidly. The faster you move it, the less magnetic force you're going to need. So that may be around your problem of worrying about extending it too far out. Maybe the deal is you really need to rotate these fields rapidly so that you can use less magnetic field strength.
So I guess in that sense, if we consider what you just said, then you could say that perhaps using the magnetic field in conjunction with the Earth's magnetic field may actually help the device.
From what I understand, all the planets, the Earth, everybody has very far extending magnetic fields. And according to abductees, again, they use these magnetic fields not so much for helping them fly or anything of that nature, for navigation. That's where those kinds of fields are going to come into play. They supposedly ride these interconnecting magnetic fields across space.
Well, let me jump in now, Will, and thank you, Will. Thank you for the question, sir. Let me jump in, and Lulu, let me ask you to go next. Welcome back, ma'am. Oh, there we go.
Hi, how's everyone?
Welcome back.
Hi, thank you. I have a few questions for Mr. Fiorentino.
That's good.
Yes. Earlier in what you were talking about, I kind of wrote notes. So, I wanted to go with, you said about particles, like we don't know which way they're going to go and why. And, you were describing when like particles are, we just don't know. But I believe like particles kind of want to fill their valence shells. So they get attracted to something that, can share that. So, we could have a possible reason if it's not just random, like there is a particular pattern of and then fusion and then bonds, where particles become much heavier. So there are different factors in that, like that's very kind of important to like understand how like when hydrogen becomes to helium and then lithium and so forth, the process, well, that's gaining atomic weight, mass, like it's growing. So different departicalization and then reconfiguration into the new particle. I mean, that's like fusion. So that's one thing, and it's always attracted to the stability point. And that's where it becomes ejected, let's say from the sun, this is happening. And then, it gets ejected, as a combined particles. We'll never know what they are, but we just know they're really, really fast and, it creates like the solar winds and, stuff like that. So, this is one thing. The second thing, you were talking about, let's go back to the spirituality part where at the end you were discussing that. Humans naturally emit something called biophotons, and it has an energy level, that could override, our observable universe. And, we dictate our observable universe. If we, I mean, the good saying says, you smile to the world smiles back. Well, yeah, I mean, really, it works that way. So, we do have a power, and that energy goes through the electromagnetic field and it cycles. So the universe, reconstructs it back to you because quantum entanglement. So it's going to come back no matter what. Like you emitted it as a a complex biological being. It's quantumly entangled to you because it's a natural emission from humans. So that also is one thing. And quantum mechanics, the spin, like when the particle starts breaking down into different, the smaller parts until, wherever, well, those will always forever be entangled. So the spins will always be in unison, because it's still part of one. So, it's going to be very difficult to measure because you have to track so many, but the principles are there, that's how the universe is, works. So, all right. Now the pion. Nobody likes to talk about the pion. That's like, and like the pion is the, I searched it and has a something called MVE +1. So its charge is a positive charge. It it's infinite. It could have tunneling capabilities. It could go, from one pole to the other. It doesn't abide by nothing. So, and that's something that has a continuous, propulsion. If we're talking about anti-gravity, well, that could be a core thing that we could start this. And when you guys were talking about governments and how they, hide stuff, really, yeah, they do. But if you understand systems and you understand, let's say even electricity is a current, alternating current, zeros and ones. If you know how to binary code, how to, you can know what was transmitted, just reverse engineer it just from the electricity. You don't even have to have an actual wireless network or nothing. Just, somebody that understands. I know a bit, but not like, I read to understand where I've come up with this knowledge. DNA structures. Our nucleic acid is a, something in their space, or our core is a hydrogen core. I mean, they only say DNA. It's actually DNA and RNA. It's they don't talk about the other side, but that bond, that's a gap space. So, that's another one. Now, you want to talk about why the governments don't want to adapt the, all the new research and the findings and the results. Well, it has to do with the Planck's constant, and it has to do with, financial terminals. Because if you update the science of this, it ripple effects to, when you run like a card or in any form of transaction that has an equation, and it divides by the constant Planck, of the different metrics and measurements and how it gets broken down to, they give it like now in cryptocurrency, they have figured out this way. So they're riding on that energy residual of transmission. So,
I know a lot about cryptocurrency.
I would love to learn more, because I already earned, went to $112 and I a zero from my pocket. I just learned about whatever they're offering, and I took the lessons and I started just playing with it. $0 out of my pocket, and and it just goes up and down. And I was able to convert one to like a US dollar one that's I included $1.09 for the tax. Just so they don't tell me when I tell them I want that paper and I want that sequence, that code from the Treasury Department, where I want to see that, transaction from this port to this port. How did this happen? How did you come up with that?
I got a question for you.
Yes.
Who's the biggest counterfeiter in the world?
Us. I don't know.
United States government.
Us. Yes.
And that takes us off topic a little bit.
Yes.
Actually, there is a really good. You might have to Google it, but there is a really good series that I saw called The Crash Course. And I'll try and put the link in chat. It has like a tree, and it's like a 14-part series. It would take you an entire weekend to watch it. It came out after the 2008 crash, and so that's the one that I kind of recommend to people. He just kind of walks you through the entire money system, but some of the things that Mark is alluding to there. The crash course really goes through that, and it wasn't based on crypto so much as it was based on the 2008 crash and a lot of the games that kind of came to light after that happened. So, but yeah, I'll paste that in chat. But Lulu, I'm sorry for interrupting you. Did you have a question for Mark?
I mean, I wanted to tell him all the stuff to take into account. Like, this is how the system, like our system of way of life is structured. I mean, down to the last bit, so don't be surprised when, the brightest minds come up with and they're not credited to this. It's because then they have to, appease all other governments, all financial institutions, and that's just too much work for them to update things. And so, we have, many discoveries and many new things that are not applied because, they don't want to do the work. They don't want to update all this. It costs a lot. When you already have your port set and your transmission lines and, your grandfathered economic system that's like, it's been going on for eons. Yeah, that's like, and everybody is, born with with a golden spoon in their mouth. And I bet you none of you even know how to like really fix it. And that's one of the lacks on it. Like
I'm not going to try to fix anything. I'm just going to get information out here, and I'm not going to worry about who gets credit or whatever.
No, I really believe, like, we have, I don't know, 48, 50 people, average, in that range. If we truly do combine, like for example, I have over 72,000 documents of scientific information that combines, archaeology and geology, symbolism, and it breaks. But I have to put it somewhere, and I keep. I have to put it somewhere and categorize it. There are systems that are like blank systems. Like, for example, was a system called an SDK. Almost a war between 18 countries broke out because, they only had like 26 of them. That runs a whole continent, what I'm talking about. Like it runs all the satellite systems. It's like your mother of mother, gate.
Yeah.
Yeah, I'm telling you, like, I know I've personally updated. I was going to do my own, like, play test, like mining system. I upgraded the electricity and everything. The second I started like inquiring information and this, my life collapsed. My, all of it. The banking system is fighting me. It's so I'm living off of the cash world, and I keep on pissing them off just because I go and I deposit 1 penny, and okay, and I'm tracking it. Now what?
Yeah.
Like, or and so forth. But I'm playing with the system just to prove that, hey, it needs an update. Like from a person that really wants us to evolve as a species. I listen to Isaac Arthur. And he talks about, the future human, and there's a Kardashev scale, and why can't we have it all? We're right there. We're about to be classified as civilization type 1. Hooray! But greedy people and ignorance is holding everybody back. And that's the sad part. So I think either let's fix it for the idiots, or teach them how to do it. And, if we consider our group as, visionaries, then I believe that we should do that. Why not? Like, why not?
We're trying to make anti-gravity. That's what this is all about.
Yeah.
Who wants to, dance with the stars,
Well, Lulu, thank you, ma'am. Thank you. And so let me go to William Schramm, who's been patiently waiting, and I just need to jump to him fast because we're pushing up against the hour. So, William, go ahead, sir.
Yeah, this will be brief. So I'm an engineer. So my question to Mark is really a question about what can we build? What experiment can we run? It looks like the device you propose is a caterpillar drive, a linear, like magnetohydrodynamic type drive. So I guess a two-part question. What's the first experiment to conduct? And then the second one would be, have you considered a need for buoyancy for this craft? If it's going to be somewhere floating around Earth, have you considered how this craft stays up in the air when it's not in locomotion?
The buoyancy is accomplished by the field itself. By using the rotational magnetic field in this case, assuming a spherical shaped craft, or we could use the cigar shaped one. It's kind of pulsing back and forth in that mode. You get the anti-gravity effect because you're biasing space. You're going to cancel out the contraction, the gradient field of gravity by countering it with an expanding field. So you get buoyancy from the fact that the gravitational field can no longer influence your spacecraft because you've expanded the space around your bias space, spatial bias drive. You've changed the metric, you've caused it to expand, and now the gravitational pull will not affect it. So there's your buoyancy. The other problem is you now want to use that same system for propulsion. So now you have to use a gradient magnetic field, something that spans across the ship in a particular direction, so that you have a really strong, powerful magnetic field at the back of the ship and a less powerful one at the front. And then increase that incrementally to the back of the ship. That gives you a velocity, a motion in a direction, propulsion. So you have both things handled simultaneously by using the magnetic field. And when you want to move, you use a gradient magnetic field. When you want to hover, you balance it, just evenly, back and forth, or either way. Hey, look, you go to these sites, landing sites where spherical or saucer-shaped things landed. Look at the pattern that's in the grasses. They're laid down either clockwise or counterclockwise. You're getting a really strong magnetic field that's whipping across and beating down the grasses. There's evidence right there that's been kind of overlooked. So my suggestion is to do just what I just said. You got to use a magnetic field gradient, field strength, intensity from one end to the other. And when you just want to hover, buoyancy, whatever, you just make it even across the bottom of the ship.
Okay. And so in the case of the cigar ship, is it horizontal in orientation, or would it be vertical in orientation in order to remain buoyant?
Well, the rings, you're just sweeping across from front to back, continuously.
Maybe the question is, does it
really
matter its
fast.
orientation?
You're getting just enough. It's not going to move because you're in between. The magnetic field is keeping you afloat as long as you do it at a fast enough rate. You don't want to do it too slow; you'll fall like a rock, or it'll wobble, which would be very bad. So you got to do it rapidly enough. I mean, you'll know this, you'll learn this by experimentation when you first start building these things and you see, oh, wow, 20 hertz is way too slow. We got to do, 550 or 700 or whatever to get this thing to stabilize. It's the kind of engineering and physics that guys like you are going to be able to figure out and work out those details. Right now, we have to prove to the world that anti-gravity fields can exist, can be made. We're at that point. We're not at this point where we're figuring out how to balance this. We're not even close to that yet. So that's my answer to that one.
Okay, thank you.
I can't hear you, Tim.
Oh, sorry about that. We are almost at the top of the hour. We've got 2 minutes left. Sorry, I forgot to turn my mic off there. So let me do this. Let me put this on gallery view. And everyone, please give Mark Fiorentino an enormous hand.
Thank you.
Mark, thank you. That was a wonderful session. Thank you for doing the Q&A. That was absolutely amazing. So what I would like to do next is I'd like to go to our next guest, if he's ready, David Perez. And before I do that, though, let me do a brief introduction for him. Okay. So David Perez has worked in Air Force meteorology, defense contracting, Lone Eagle Systems Incorporated as the president, Space Warp Dynamics as the president, Quantum Electrodynamics as chief engineer of space systems. He's the university adjunct at 5 colleges: meteorology, astronomy, geography, geology, earth science, and physics, and has U.S. patents pending for a space warp motor and many other devices. He has additional background in electronics, software, hardware, equipment design and fab, ham radio, and aviation. His education is AS Engineering Science from Middletown, New York, BGS Geography from the University of Nebraska at Omaha, MS in Geography from the University of Nebraska, and he was also registered as a science. He was also registered science with Battelle Memorial Research Lab in atmospheric sciences at the U.S. Army. So I want to welcome David Perez to today's call. He's going to be talking about the variable electromagnetic drive. Everyone, please welcome him here with us. And David, there you go, sir. Let me ask you to oops, sorry, wrong one. There you go. Okay. Wonderful. Thank you for joining us, sir. And it is all yours.
All right. I'll need to take over the screen, for my PowerPoint presentation, if that's okay.
Yes, absolutely. It's the green screen share button at the bottom.
Right. Okay.
And there's a little bit of background noise, it sounds like, but
I got a little fan going here. All right. I don't know why this is taking so long here.
Okay. Yeah. And it sounds like we can hear you okay.
All right. Very good.
There we go. Okay. So you're in screen sharing. I think yeah, perfect.
Let's see here. Oh, I have my PowerPoint up. No, it's not there. All right. Great start to the presentation right there. All right, just take a second. Sorry about that. Anyway, this entire process of developing a warp drive, or the VEM drive, has taken over 10 years of hardware development and over 50 years of research development. And let's see. Okay. Sorry for the delay, but my internet was been down. It only came back on about 20 minutes before 3 o'clock. So.
No worries at all. It looks like everything is working great. I just appreciate you joining us and sharing us about this.
Okay. Is this screen okay? I can go to the slideshow if you want, or I can just go down slide by slide manually. What do you prefer? Slideshow?
Yeah, slideshow probably works better if you can navigate that one.
Yep. Okay. Well, we're going to go for it. We'll see what happens. All right. Everybody can see? Perfect. Okay. All right. Quantum electrodynamics. It's been a series of companies. Lone Eagle Systems was, as you mentioned, that was more backpack meteorology for the Army to bring it out into the field, bring weather within a 20-minute time span to build weather products and that to the field. And the space warp dynamics was the originator of the field effect of what we refer to as the putting two arrays together, mimicking basically as a thunderstorm. And how this all started was looking at Alcubierre, Miguel Alcubierre, and according to general relativity, any type of matter or energy bends space-time. And we can observe this as for actual experiments from the 1919 editing experiment, where they photographed a star behind the limb of the sun during the eclipse. The star was appeared on the photographic evidence. We've seen other examples of this. The gravity B experiment in space also validates the fact that matter can bend light, but also it represents the fabric of space. And that's what we're going to be talking about today, is how to manipulate the fabric of space. Thunderstorms. Very naturally, they have been basically forming since the Earth been formed in essence, but the real power of a thunderstorm is immense. A typical thunderstorm, 20 degrees north latitude off Fort Lauderdale or Miami, can get up to 80,000 plus feet. As a radar operator in weather with the Air Force, I've measured storms up to that height at that latitude. And the amount of energy that these things can produce is like 10 to the 15th watts of power. And to give you kind of a reference, the small 13 kiloton atomic weapon will produce 10 to the 7th watts of power. So there's a 10 to the 8th watts power difference in the amount of energy that's created in these thunderstorms. And when they get close enough to each other, when they overlap, their electric fields overlap as well. And it can provide, in certain times of the year, certain instances when solar winds are over 700 kilometers per second, the bidirectional flow of energy from the surface of the Earth to space and back again. When all these different parameters kind of engage each other, you can form a natural local space warp bubble. Now, is that just theoretical, or do we have actual evidence of this displacing aircraft? And we do. And what's interesting about this is that if you fly through what they refer to as the sucker hole near the freezing level of a cloud, you can be ejected and cause a linear displacement. And we have, I've got 4 examples today that we can look at. The structure of these thunderstorms really are 2 dipoles, a positive dipole on the top and an inverted dipole on the bottom. So that's plus, minus, minus, plus. And the minus characteristics are into the freezing level of the actual cloud itself. So height makes a difference. The amount of intensity, particularly oceanic thunderstorm evolution development, like variable winds aloft, are the key elements. And the girth of the cloud will extend out to 30 to, in some cases, up to 50 miles. And what happens within these clouds is this tremendous amount of energy. They also create antimatter. In 2007, it was thought possibility that clouds could have enough energy to create antimatter. By 2010, it was proven by the Fermi spacecraft, which was sent up by NASA to examine the universe to see if there were puddles of antimatter left from the early evolution of the universe. And they actually did find puddles of this antimatter out in space. However, they kept getting gamma ray residuals on the back end of the spacecraft. And they began to figure out that absolutely antimatter was being formed in thunderstorms. And it's not just a few antimatter particles or positrons, but we're talking of hundreds of thousands of these things energizing within thunderstorms all over the world, of which we have approximately 50,000 active thunderstorms at any given time. So very, very interesting. The 500,000 electron volts that's available for every positron that kicks off inside the thunderstorms. Gamma rays are emitted. Flight characteristics for the FAA have been changed. That restrictions to aircraft, 20 miles, no more. That's close flying in a normal aviation setting because of the gamma rays that are emitted. And this is like 70,000 gamma rays per minute that can be generated from these storms. So these puffy white little things that we see up into the sky are actually quite energetic, to say the least. Now, the positive dipole and the inverted dipole plus, minus, minus, plus, was actually researched and verified by Earl Williams from MIT, atmospheric physicist. And this shows the actual type of current flow that you would generally see from the top, goes to the ground, and then comes back up to the bottom of the thunderstorm. So this is a lot different than you'll see in typical textbooks, but utilizing the same capability that Earl Williams had indicated, that is referred to as tripole fields. And when you cross these tripole fields, you will get this crossover of fields, which will generate a non-sustainable space warp bubble. And in this particular case, the terrestrial evidence that we have from Bruce Gernon, 1970, Lieutenant Colonel Hopkins, 1966, Arthur Godfrey, maybe some of you remembered him as an entertainer, was actually a naval pilot before he was the entertainer, and he's flown all the various naval aircraft, and we'll talk about him in a minute. Flying Officer O'Brien in World War II. So let's start out with Flying Officer O'Brien. In northern London, there was a Tiger Moth squadron that was testing out radar for aircraft in the early part of the war in 1941. He was aloft that day, late in the afternoon, 3 o'clock in the afternoon. He got caught up in a thunderstorm. And as he got sucked up by an updraft, he felt that his whole life was over at this point, that he was going to get damage on his airplane, he was out of control, and then suddenly he saw an opening in the cloud. He was able to veer the aircraft off into the tunnel, and he ends up in northern England. He flies back, takes him several hours. He lands, he tells the story, and they say, don't put this in your logbook because, this can't happen. And of course, belief.
David, I'm sorry. I'm terribly sorry to interrupt you, sir. We're getting some audio crackle from your headset. Would you have a wired headset that you might be able to use instead?
Okay.
And if not, that's no problem. I feel very guilty about interrupting, but I think maybe the battery might be low on your wireless.
All right, hold on.
And again, please accept my sincere apologies for interrupting. I know I didn't want you to lose your train of thought or anything like that. That's why I always feel really guilty about interrupting folks.
Okay, can you hear me now?
Yeah, actually, you're kind of too loud now. Could you turn the volume down just a bit? No, you sound great though. It's super loud, but
Well, whatever can go wrong, obviously does go wrong.
you know what? You sound wonderful now, though. Actually, I think that's perfect. I think that's perfect, just the way it is.
Okay. All right.
Well, thank you again. I'll mute myself back out, and again, my apologies.
It's no problem. Whatever works. That's we're not overly concerned about the interruptions. Don't worry about it. If something else happens, let me know. All right. And so Officer O'Brien relates this into a letter to his family. And we've done a number of television shows about Bermuda Triangle and warp fields, linear displacements with Bruce Gernon. And as a result, we got sent this email that tells the entire story, which was very, very interesting. Tiger Moth is a double winger aircraft, and it's an open cockpit, and it's not really frail. I mean, it's a training aircraft, but they adapted it for early development of radar during the war. So we get the letter, and here we have evidence of World War II. And undoubtedly, there's been other cases way back in history, but people just don't report things very often. Arthur Godfrey, the late 50s, has an experience going from Alaska to Japan. He knocks off like a half hour off of his flight time. He shouldn't have been there a half hour early. He went through a thunderstorm, went through the sucker hole, and the same thing happened to him. He relates this as a result of Bruce Gernon's experience in 1970, where Bruce encounters getting surrounded by thunderstorms near Bimini Island, and being thunderstorms evolving in development from the surface of the ocean to well in excess of 68,000 feet. Well, he finds a sucker hole there, and he flies through it, and the hole is actually rotating, kind of like the right-hand rule here. And inside the tunnel, the clouds are rotating around like a cement mixer. And so he's got two thunderstorms that are close together and then form the hole up near the freezing level, which is about 10,000 feet. So he flies into this, and he starts feeling a hydroplaning of the aircraft and kind of a sense of weightlessness within the first few seconds. And then suddenly, a white ionized cloud surrounds the aircraft, and he can't see out. So he calls on the radio to approach control, and it goes, I'm over Bimini Island, but I'm blinded. I can't see anything, and my compasses are spinning. Well, the radar operator, approach control, tells him is that I don't have any aircraft over Bimini Island, but I have an aircraft over Miami Beach at 10,000 feet. And he says, that's impossible. I'm over Bimini Island. You have to have a mistake here. And they go, no, there's nothing there. Well, approach control radar rotates 4 revolutions per minute. So that's 15 seconds a sweep. He disappears and he reappears on the second sweep. And that's 108 miles distance from Bimini to where they picked him up on radar. He continues his flight. The ionized particles have left the aircraft. He flies to West Palm Beach, lands. He takes off at Andrews Island at 3 o'clock in the afternoon, and he lands at West Palm Beach at 3:47. All confirmed and logged. And again, he's befuddled. His ground clock is the same as the controllers. So there's no time differential here. Something weird has happened. And so he spends nearly the rest of his life trying to resolve what actually happened in 1970. Now we put Lieutenant Colonel Frank Hopkins in there because he has a aircraft, a C-97, which is a very lumbering, kind of like a pregnant B-29, and it's a cargo version, and they also known as the KC-97. These things flying around 202, 210 miles an hour. They're not really fast. They're heavily, laden with equipment and things of this nature. They're flying from Kwajalein to Guam, and it takes 6.5 hours to get there. They fly that mission in 5 hours. And as he looks at his waypoints, an expert navigator, he was considered to be a master navigator. He's 300 miles downrange of where his last waypoint was. And they're flying into storm activity as well. So what's the same similar characteristics that these individuals had? And we can all say that it's anecdotal, nice story. And in fact, he was told not to report this upon landing, but he writes an article for the Ergus magazine in the 1960s, and it gets published. And I've investigated him, and I read his obituaries and everything. And this guy's on the up and up. The guy is just a very precise navigator. His whole life is very precise. Very similar to Bruce Kernan. If the pencil's out of place, the man gets very upset when you're flying with him. Arthur Godfrey contacted Bruce because he had heard a program on radio of Bruce's experiences, and Arthur also had this similar experience. And so he wanted to get together. Unfortunately, 2 weeks before he had made contact with Bruce, he passed away. And so his publicist then conveyed the bad news to Bruce. And then Bruce eventually writes a book. And at that point, it's basically history. He annotates all the events that occurred during the flight, why he was there, how many times they had made the mission or flying from Andros to West Palm Beach. They were looking to put a resort in there. And this is a picture of an actual tiger moth, but this was used in radar research. I just wanted to kind of show that, let you know, is that this non-sustainable local spaceport bubble that he gets caught up into, that's an air-breathing engine. It's an open cockpit. He wasn't on oxygen, and he still maintained flight control with the aircraft, breathing the whole bit. But when he was surrounded by the bubble, it protected him from the any kind of exterior momentum or momentum from G-forces of the aircraft. The crew was protected. The ground clocks or the clocks inside the aircraft were matched identically to the ground observer. So there's no time travel, no time shift, nothing of that nature. And I'm overly stating that because it's important to realize what really is going on here. Now, it took me years to figure this out. I don't believe a physicist would have figured this out, because you need to be the meteorologist and the physicist in order to put the various pieces of the pie together. And researching the cloud activity, getting back into the weather records for the time for that exact day. We have his refueling ticket. He always had, it was a A36 Beach Bonanza, carried 80 gallons of fuel, Andros Island, of where he came from West Palm Beach to Andros. There are no refueling stations. It's a grass field at that time. So what you came in with is what you leave with. Now, a 210-mile trip, that's what he has on his logbooks, and on the flight records, 75-minute flight. On this particular day, which was December 5th, a day before, almost 25 years to the day of Flight 19, this area seems to have a lot of characteristics or like climate records that match a lot of these occurrences in the early December timeframe in this region. Is that a good thing or a bad thing? Well, we looked at this and tried to set up aircraft, a UAV, to actually go and fly into thunderstorms, into these sucker holes, to see if we could recreate the same type of scenario. Well, we had pilots lined up, we had the monies and all this other, and suddenly everybody dropped out because they were afraid that they would get caught up into this phenomena. And some people had visions of crashing into the ocean. So project was canceled. So it was then I decided to bring this in the lab. If this occurs in nature, and if thunderstorms do indeed create these warp bubbles, these natural warp bubbles, then we should be able to do this and bring it in the lab. The other convincing piece of information that we had was that he typically burns 15 gallons an hour, 180 miles per hour. Now, he had to do some maneuvering around, and it increased his trip distance to 250 miles. Typically, he will use 28 gallons of fuel round trip. He actually only used 29, and I got to correct on the date. It was December 4th, not 5th. 5th was the flight 19, excuse me. Anyway, he had 9 extra gallons, and he's very finicky about flying, refueling. As soon as he landed, he goes and refuels. And we actually have a copy of his refueling ticket, and it actually says 29 gallons. Well, he uses 38 typically. We have other refueling tickets that verify that. So 9 gallons. Well, as that turns out, 0.78 fraction of an hour, that comes to for the 250 mile an hour, 250 miles that he traversed, that means he would have traveled 320 miles an hour from Andros to West Palm Beach. Well, the wings get structural cracks at 220 if you sustain for more than 20 minutes. So we've done all this research, we've looked at all this, and there's no real positive explanation other than eventually figured out from the 1994 when Miguel Alcubierre proposed a warp bubble, and it go from point A to B. And what's interesting about it is that everybody got on his case. They gave him nothing but a bunch of garbage. And all of us know, right? You guys are doing anti-gravity. You're messing with the magnetism and everything, fields, electrons, and all this. Well, they gave him the same kind of hassle. And his estimates for being able to create one of these things was all the energy in the universe. Well, we know that's not quite practical. Then they started to claim dark matter, dark energy, antimatter, exotic energy to actually create a warp bubble. And so you go through the list of scientists that have been working on this. And again, these are all theoreticians. They don't build anything, all right? And this is Van der Broek, Kleber, Obasi, and Sonny White, Dr. Sonny White, Eagle Works, which I think they closed that particular lab. But anyway, if any of those names are familiar, these guys have been working on space-time metrics. Same thing with Harold Puthoff, long worker, physicist in space-time metrics as well. So we move on here, and we finally determine, based on his experience in his particular case, and this is a rendition of what it looked like from his aircraft, or from his aircraft into the sucker hole, into the cloud. This is one of the proposed experiments. I built a UAV in the garage, and it's 7 by 7 feet. And this was a flying UAV that would be controlled from another aircraft. And once we found the sucker hole, we would fly the aircraft in, be stationed down at Bimini. It was a very intricate potential experiment. It would have been really neat to do, but we had to take this to the lab. And so energy can bend space-time. And according to Miguel Alcubierre, this all is very possible. And theory, granted, but I'm more of an empirical. I guess I didn't realize this particular slide came out fuzzy, but anyway, on our website, you can look at the papers that we have and all the other explanations that go with this. But essentially, it allows you to go from point A to B. Alcubierre, with the being a theoretician, he didn't understand the actual practical side of this. In other words, his intent was, or his explanation, that a warp bubble would go a straight line if you engaged it, which means you compress the front part of space-time, in this case, the fabric of space, and in the back of the craft, it begins to push or expand, and it pushes it all through relative space. But the bubble is isolated, and it protects the crew. No momentum, time stays the same as the ground observer, and then everything's hunky-dory. There's some tidal actions at the outside of the warp bubble. However, in Bruce Gernon's flight, he went in 10,000 feet and came out at 10,000 feet. If he actually traveled the straight line, he would have been in outer space. And so Alcubierre was incorrect, is that mass influences a warp bubble. So if you do go to space with a warp bubble, you have to accommodate for all the mass that is near and around you. You have to be able to compensate and have a navigation system that can also adjust and compensate for that relative action of being attracted to a larger mass. Now, when we brought this into the lab, we built an interferometer. We built a set of VHF antennas, which would then correspond to the frequencies at the freezing level of a thunderstorm. And so in this particular emulation, we then passed a laser down through the interferometer in between the VHF antennas, and the results of the fringe patterns that we got when the system was off, the fringe pattern would open, and when the system was on, it would close. So we were actually compressing a laser beam. And it was in, like 4.223 microns of compression. And this was extremely significant. This gave us our first clues that what we were dealing with was the potential reality. So we went on and did some additional experiments. We also looked at a frequency meter, and we put it into the throat of our primitive motor, and we got a redshift in the frequency from the frequencies that we obtained from other flights that we did from the television programs. I used the frequency data that I had collected inside the cloud. And with that said, building our first arrays, that we got a redshift, which is also pertinent in detecting the presence of a warp field. Now, the next thing that we did to try to get this to collect more and more evidence as we went along was what would happen if we were to put the motor against or near, and we've gotten results way beyond 140 centimeters. But to start off, we were 50 centimeters away from this torsion bar, which had no metal. It's a non-ferrous wood material. And we have a small little mirror, which has a mylar covering. We used the laser, and we pointed at the laser. We turned the motor on, and it was 25 watts of power. And the entire mass, which is 1.5 pounds of mass, supported on this torsion bar, moved towards the motor. So the motor we developed is a pulling motor, okay? So it doesn't thrust, it pulls. And that's what makes it very unique here. But the effects of the fabric of space goes right through solid material. And we've tested it with metal, actually trailer hitch balls, and that weighed 3.5 pounds, suspended them on a torsion bar. And we moved those as well. And we've tested at 25 watts of power, 100 watts of power, 200 watts of power. We have the video that we'll show you here in a bit. But it can actually adjust or pull matter through solid objects. Now, that's not charge, because we've been out to 140 centimeters. This is non-ferrous material. You see the wood torsion bar there. It's got a piece of fishing line, monofilament line. There's nothing there that can cause this. It's some of the graphs that we plotted out and trying to put a lot of these things together. But the interesting piece, no matter what we did, 25 watts or 100 watts of power, you follow the relative same curve. So the fabric of space really doesn't care what it is, whether it be ferrous or non-ferrous material, the curvature at various power levels, they're the same. Now, let's see. This is going to be a little tricky. Nothing's worked for us so far. Internet going out, headset not really good. You guys want to take a chance, or we want to wait at the end of the presentation before we do this?
You know, it's up to you, David. What do you feel the most comfortable with? I would say give it a shot if if you feel up for it.
You want to take a shot? Okay.
Now, it may not play audio. I've noticed that's a Zoom thing. It depends on your setup, so it may not play audio if that's in there, but the video should come through.
My experience has been it doesn't play the audio correctly, but I'll narrate it if this works. It's getting out of it with the escape key. Well, let's just try.
Okay, yeah, go for it.
Okay, here we go. Now these were made about this summer or was it last year or spring or something? Anyway, I don't know if we have oh yeah. Let's skip the ad here. There we go. The wonders of YouTube. You're probably not hearing anything.
Yeah, no, there's no sound. There actually is a workaround for that, but you have to shut down Zoom and install other software to do it.
I don't think we're going to do that today.
Yeah.
Okay. So May 17, 2021 experiment. We call this the Cavendish experiment because it's very similar to Cavendish in his universal gravity experiment. I used to work on that as a side projects at Oswego State, but developing a new technique to measure universal gravitation. So remembering that experiment, we have components that are similar. Anyway, that's the reason why we name it Cavendish experiment. So this is at 1.5 pounds. And so we are actually going to move here. The motor is 50 centimeters away. We're running at 200 watts. It's approximately 55 seconds. So we're looping it. And that's actually pulling 1.5. And this and what's interesting about this versus the laser that we would have normally on there, you're seeing the actual physical movement due to the motor that was being used to pull this towards the motor. So the fabric of space actually is depending on how much energy that you have, it will move objects accordingly. Now they're going to go through let you see it naturally. I don't know if you're really interested in that because it takes time to do that, and we're trying to push on. Let me see if we can get back to our presentation. If I don't mess this up. Uh-oh. Can you still hear me, Tim?
Yeah, I can still hear you. Okay. So you're just trying to get back into the slideshow, right?
Yes.
Yeah, so it should be your PowerPoint icon, I think, down there in the lower right. There you go.
Okay.
Perfect.
I teach online too, but usually I don't run into these kind of problems. You know what I mean? Anyway, after that experiment, there was a 4-video scene of the movement and how the lab is set up. But we'll go to this one now that we know that we can do this. Now this one is actually the engine, drive, engine, motor, all of the above. Skip an ad. Here we go. So like I said, this has been under a number of years of development. And Kyle's going to be talking in my headset, and then it's going to wreck my train of thought. All right, so this is June 15, 2020, 1500 watt experiment, 30 seconds. Most of all of our experiments that we do are because of the graphs that we produce, the plot data that we get, everything is consistent under the 30-second time test. And as we see comparison charts of energy generated, you're going to be quite amazed at how much power, at the small amount of power that we do use, that we can attain, like up to 15 newtons of power, 3.37 pounds. And in this particular experiment, that's exactly what you're going to see. Now we have a Faraday cage around this. We've done biologic tests and radiation tests with this, and there isn't anything that the motor puts out of any consequence. It's 1.5 microrads of radiation from the motor. And we've used lab flies in a test and gone out to the second generation of the flies after they've been exposed to over 1,000 watts of power for over a minute. And then they were traced, a control group against the actual activated flies, and everything turned out to be normal. In other words, one group loss of flies wasn't any greater than the other group. They were all pretty much the same, identical. Eating patterns were the same. And then we even went to the second generation of flies where nothing was detected. No malformations, same eating habits, the same lifestyle of the flies were maintained even out to the second generation. But we used the Faraday cage since in the beginning we didn't know about this. We wanted to protect ourselves. Now this is what the lab looks like. And you'll see Kyle standing back over here. We have multiple cameras onto the VEM drive itself. We even have a 3-dimensional or 3D photo that you can actually get in and move it around and look all over the lab and watch the experiment in progress. The motor weighs approximately 1.25 pounds. The cables here are really high weight times cables, 600 variety of thickness or semi-rigid cables that we employ on this. Now that whole apparatus is suspended by a spring, and let's see here. It's suspended by a spring, and taking a hanging a hanging weight like you would use in the airport, weigh your clothes or whatever, is in a scale, a hanging scale, lifting it up it's 3.37 pounds. And for that to have moved all that material takes 15 newtons of power, or 1500 watts. Now, what's interesting, a year prior to that, we had lifted 1.5 pounds of 6.26 newtons of force at 1700 watts of power, or 1800 watts of power. And we were able to actually reduce the amount of wattage with the new design of the motor down to 1500 watts and over double the weight. So we made a lot of progress in the last year. And our goal for the end of this year is to lift 10 pounds. So the actual experiment itself, power ratio to wattage, is actually exponential. And that's what's very exciting about this technology, is that, for example, like well, here's one of our latest motors, Model 18. This one's made out of aluminum. Our typical ones are made out of copper. And but each one of those, there are 4 tripole fields. So in essence, we have 4 thunderstorms mounted on the board. We're using fractal technology here, Koch curves, that are specifically tuned to the frequencies identified to the mid-levels of thunderstorms. And what we've been able to do is create in those tripole fields plus, minus, minus, plus. And on one side of the array, we have 2 sets of tripoles. On the other side of the array are another 2 sets, and one opposes the other. So the near fields actually cross on these arrays that have been built. And we've built 18 engines, each engine giving us a little bit more empirical data and then applying that and improving. Pad spacing is critical. Everything. When you're working with VHF, I don't know if many of you work with that or know of it. VHF is extremely tricky to work with, and you got to know your stuff. We've performed hundreds and hundreds of experiments to get the proper pad spacing. And even though that we had equations to give us a predictor, it wasn't until we actually did the empirical, the real live stuff, that we were able to get this thing tuned and prepared in such a way as that the near fields could cross in a fashion that actually then pushes the compression of the fabric space down in one direction. We actually use a throttle. We have a throttle here. We also have computer control. We can turn the motor on and off for as long duration as we need, but we can actually start from 0 and then going up to the maximum force, which is 4,000 watts of power in our particular case. We're very cautious about over exercising, going immediately to 4,000 watts of power, because our linears that we use are, if you overpower too quickly, you could pop some circuits. This is all custom equipment, and this stuff costs well, let me just say, thousands and thousands of dollars. You don't go to your local Kmart and go buy one of these things. Everything is custom. So we not only have software control built in, we can turn it on and off as far as software goes. We can do it from a local basis, which I do many times. On testing, we have a momentary switch, we have a fully engaged transmit switch, and then using the pot, turning up the throttle. We have 2 settings, low and high. We have the timer here. And again, software controls we use on occasion. We also have a tuner. We have works on a battery, DC, 48 volts. And it's 180 amp hour battery set that I've constructed here. Designed and built this. It's all custom again. It's all custom. Throttles are custom. The whole system is custom. There aren't any parts that you can buy anywhere you'd have to start this out from scratch. The power curves. We've done a number of analysis with different types of engines, looking at the R² numbers here. For those of you, the closer you get to 1, the more perfect it is. And then if it's off on the predictor from the exponential curve, and that's what we've been working to improve, and we've gotten up to 0.992 on our R² values. And that was model 15, and we're working on 18 now. So a lot of questions come up like, what it's going to look like outside the windscreen of a spacecraft? Well, if you approach you go faster than light, it's going to be a milky looking screen as light is built up into the compression field in front of the craft. And chances are, my prediction is, you're not going to really see much. You're going to have to depend internally to a navigation system. Oh, look at that. A better Alcubierre matrix. Well, I guess you can't ask for everything, right? We got a fuzzy one in the beginning and we got a nice one here. But anyway, this is what he came up with. And like I said, these don't really match what we have found. There are differences, is that the materials will go to the mass of the Earth or whatever mass is nearby. The other characteristics that we have not detected are the tidal actions outside of the warp bubble. They're pretty much non-existent. He indicated some very, very violent activity on the exterior of the warp bubble. But again, maybe we'll detect that as we go up in power. But to date, at 1,500 watts for 3.37 pounds, we haven't detected any type of interference on the exterior. Now, what does this all mean? Well, in this case, we have the compression of the fabric of space in front of the spacecraft, the expansion behind. What does that really look like for the motor? Well, here we are, the near field compression with the crossover of the near fields, which is a radar term actually, from the arrays. What happens is that this focal point gets elongated and it pushes down. So behind the engine, you have expansion of the fabric of space. In front of the engine, you have compression. Now, we went to a lot of trouble to actually map this. And we have the magnetic flux data, and we also have gravity data. We used a Raspberry Pi and an Adafruit sensor that had an accelerometer on it. And one of the interesting pieces about this is that we can see here is that the gravity data, which is fractional, corresponds to our magnetic flux data. And you see this bowing or the curving around, which is then the releasing of the compression of the fabric of space. Again, the empirical data of pulling the solid mass or the ball through towards the solid case so that the fabric of space does affect things right through solid materials. The redshift, but in this particular case, the important part here is gravity. We're actually causing a fluctuation or fractional piece of gravity. Now this summer, and it's took a couple of months to collect the data, and we have 55 points across the, we call it the base sheet here. And we had the top sheet already done from a year previous. We used the same motor, model 15, and then we analyzed, collected all the points, and this is all done in 10 watts of power at 4 inches from the base of the motor to the top of the motor. It matches. It's beautiful. We even left in this little, you'll see like there's a mound here. We weren't going to be accused of altering any data. This what came out. Apparently we got a saturation in the sensor, and that's what it was. That's how we report it, and no apologies. So in this regard, with gravity data being shown that we can compress, well, we can also use this as artificial gravity in a spacecraft. Not only make the engines, because you can overlap warp bubbles and make bigger warp bubbles. It's really fascinating. We've already done this in the lab. We've been able to do full axial control. If you put a stronger amount of energy to the right, for example, it will pull to the strong side, and the other side opposite, weak, goes strong, it pulls to that side as well. So we have full axial control capability with being able to manipulate warp fields. This wouldn't be any good unless you could actually manipulate the fields. The other things that we detected was that we had a thermal infrared camera. We put it at the end of the motor, similar to what you're seeing here on the first slide. And before, this is ambient temperature, and after. So we cooled the ambient air around the motor by 4.5 degrees. Now, what's interesting about this is the recent release of Navy footage of F-18 Hornet aircraft using their thermal infrared around UAPs, which is now the new name. To say UFO, you're classified as a whack. UAPs, you're okay, right? Just a little bit of trying to inject a little humor here, okay? But the overall objective is that those infrared images produce cold segments around those craft. We get the same thing. I believe that those UAPs or UFOs are actually operating with warp fields and have obviously really polished it up highly in evolving their technology to be able to go from 29,000 feet to the surface of the ocean in just a second, as radar operators have indicated. This is warp. This is exactly what warp is about. Now, they're more sophisticated than what we have. We don't know if anybody else has it, if the government has it or whatever, but from a private from a private enterprise, as we are in QED, we have it, the basics, and we're learning every day, and we're applying every day to further the technology. Now, there are other EM drives that are out there. Roger Shire's drive, he has a he uses his in a cavity perspective, and he also uses a gigahertz worth of frequency. The problem with it is that the cavity heats up because of the gigahertz frequencies. This detunes it, and it really becomes ineffective. EM drives, or the electric drives, these have been used in space. They're very, very low amount of thrust on these things. Ion drives are the standard that they are using out in space. You got to remember one thing, is that these things take long periods of time to accelerate to a pertinent practical application, to get from point A to B. To go from the Earth to Pluto to 10 years. That's 5.5 hours light speed, okay? But it took them 10 years. It took 4 years to build up to 25,000 miles an hour, and then they looped it around Jupiter to give gravity assist and got it up to 50,000 miles an hour, the fastest spacecraft humans have ever designed. So the big problem with space, as I see it, it's too damn slow. And to get from point A to B to the asteroid belt, if you're going to do mining, you got to be able to make turnarounds really quick. Get the materials, bring them back, process them, either in space or on Earth. NASA's Ion Drive, let's also put this into characteristics. The Dawn spacecraft was a 0.92 or 92 millinewtons, which is, you can't even make a Kleenex blow in its thrust. It uses fuel, xenon gas, and they're susceptible to corrosion. The motors that we've developed, there is no corrosion, there's no moving parts, everything is solid state. And so the life expectancy of a device like that potentially could be in tens of years. But until we get to space, we won't know that. So I'm not going to make big, claims here. I'm just saying is we've shown you what we've actually done to date, and they're very time consuming. It's very expensive. That's why I work 5 jobs, and to lay the cash down instead of writing. I mean, of course, I have equations and everything else, but here are the comparisons of 15 newtons and the amount of time it takes to get there. In our space warp dynamics drive, model 16, we were at 20 seconds, and we were able to develop 1260 millinewtons of power or compression of the fabric of space. And here in our latest model, model 17, we're able to actually get to 15 newtons, lifting 3.37 pounds. Now, all of these other motors, they either use gas or they're using electrical energy, and the amount of wattage that they use, you know, we use 1500 watts. Here's the Dawn spacecraft. This is 2100 watts of power. That's expensive on board a spacecraft. So what we're trying to do is our initial attempts to get into space will be station keeping motors, even though we have more capacity than an ion drive ever thought about. We run circles around them all, except just like a lot of the technology that all you guys are working on. And I refer guys to everybody. I'm from New York. That's how you talk. Well, whatever. No apologies. Anyway, that's what you guys are up against, is people believing, not believing. We're in the same predicament because we're going against NASA. We're going against everybody else. We have something that actually works, and they don't, as far as we understand. As the new picture of the lab, we just got finished remodeling. It was too cramped. We ended up discarding a lot of stuff that we never used, and we streamlined it, built new benches and workstations, and we're trying to declutter and create more space. I mean, we only had 18 inches of space, to be honest with you, between the workbench and the tables that we had set up. So now we have 4.5 feet, and we're creating an aisle all the way down. So model 16, just to finish up, I know I'm going over a minute or so. These are the goals of what we're trying to produce: VEM drives for satellites and future space stations, produce artificial gravity for any environment. That's kind of a real important thing. Retrofit and upgrade existing spacecraft, and/or as we get more powerful aircraft, terrestrial or space, our designs are adaptable to power up and not to have to rebuild a particular device or a craft or a spacecraft. Our ultimate goal is to travel faster than light. Predictions are from Harold Puthoff is 100 times faster than light, doesn't violate anything of general relativity. I've heard concepts of 1,000 times. But to put it in perspective, even if we went 1,000 times faster than light, 1,000 light years, some of the most interesting places that we could go, 5 light years, 4.6 Proxima Centauri. If we could get faster than light, obviously we can narrow down the amount of time. But this is going to be the biggest problem that we face in our universe, or actually just in our own Milky Way. We're going to be restricted by the limitations, if there are, to how many times faster than light can you travel. And we'd like to test on that. So our idea for artificial gravity inside the spacecraft, putting our VEM drives, the smaller versions, the low power ones, to create a gravity dose. A recent magazine article that talked about life in space, human existence, and also plant life. They were talking 1.25 gravity to 2.45 gravity in a spacecraft for human existence. At 20 watts of power, we can produce 1.45 gravity dose. which is more than ample for human existence inside inside of a spacecraft and for plant life and whatnot. So we believe we've solved many, many problems of being able to manipulate the fabric of space, even within a space warp bubble, a larger one. You can also manipulate within there. So this is our Bluebird spacecraft that I designed. The full size, 7-passenger, 30 by 30 feet. And there would be pods on the side that would have the engines, but this is a test setup of lifting a 36-pound craft, all made of aluminum, handmade. It took me 5 years to build that. Okay. This is some of the ideas that we have, missile technology. You know, there's a little scary stuff here. If you could deliver a warhead in a couple of seconds or a second to your enemy, that presents a lot of ethical problems, I guess, unstable power distribution around the world, adaptability to aircraft, going out in space where we're at. We're going to be limited to the local space, which would be within 1,000 light years if we can get faster than light. Man-carrying craft. We already have the base of this constructed. We're just waiting for the rest of our hardware to evolve and miniaturize. And Bluebird 2. And that's the end.
Wonderful. David, thank you so much. So let me do this before we do anything else here. Let me see. I'm going to stop your screen sharing. Okay.
Gotcha. Yep.
And let me put this on gallery view. And everyone, please give David Perez an enormous hand for a truly in-depth presentation. David, that was wonderful. Now, I probably shouldn't mention this, but Jeremiah and Mark have both been telling me about your work for the last 9 months. They're like, you have to get him on. You have to get him on. And so I'm excited to finally have you on. They have been literally, in fact, Jeremiah was almost jumping for joy when I said, yeah, he's coming on. Kyle emailed me. So thank you for presenting for us.
My apologies for any of the technological foibles that we had here, but stuff happens.
Oh, no. I will try. I probably should have said something earlier. I always feel really guilty about interrupting people, but
no problem.
Yeah. No problem. So let's go to Q&A. Let me go to Jeremiah first. Jeremiah, go for it, sir.
Could I interrupt just for a second?
Oh, sure.
If you want, I'll answer anything you want. Go to our website, QED-NE.
Oh, yeah.
And that has 5 papers that I've written about a variety of subjects, and also images, all kinds of great information that we've been able to compile. It's brand new. I think it's very modern looking, and I think you would all probably enjoy it.
Yeah.
Okay. Sorry.
Well, actually, yeah, no, that's a good point. So anyone who's looking to support your work, anyone who wants to learn more about it, it's QED-NE.com, and they can contact you through that as well, right?
Yeah. QED-NE.
Okay. Yeah, because I know that you guys are looking for supporters and looking for people to get engaged and learn more about it. So we'll put links in the show info as well to that.
Okay. Thank you.
Okay. So let me go to Jeremiah now.
Okay. Hopefully everyone can hear me. I thought that man, besides that just being absolutely fantastic, and I'm overjoyed that you're finally coming on and not only talking about it but showing what your actual drives look like, getting up close and detailed, giving the theory, giving the disclosure. I was so hoping today that you were going to do it. I was so hoping you were actually going to come out with that information. But what I really wanted to ask, and what you didn't talk about, was the nonlinearity response to the drive for the same power input over time. And I was wondering if you could touch on, the output or thrust observed from the drive over a period of time that it runs with the same exact power input.
Well,
have you noticed it?
It's a cumulative. So it deployed to space, it would accelerate continuously, just like an ion drive would. but the fabric of space would continue to compress with a constant power level if you wanted to operate that way. We've tested in a pulse mode, thinking of conserving batteries or solar panels input. It works. On constant power, like I said, it's a cooling feature. It's almost like a Peltier diode in a way, where the fields cross over. That's what we've observed. But, here's a little bit, I usually don't talk about it because it's all of you, all right, very specialized and interested in stuff of antigravity.
Well, if I could jump in really quick though, I don't want you. I know that you guys have a lot of proprietary material. I don't want you to share anything proprietary, right? And
I haven't given you, even though you may think that I've given you a lot, there are many trade secrets and company proprietary information that I don't disclose and that would never disclose.
No, and that's perfect. I just wanted to stop you before, I don't want you to share anything that you feel uncomfortable sharing, I guess.
No. I mean,
yeah, but you already showed us your system, your filing system. I mean, I went to science information technology and they teach you about databasing and SQL and stuff like that. I mean, you already put that information. I could search this and retrieve it back, because it's already there. So everybody has to take an oath that you share it for good, really for good.
There, we'll do the scouts oath.
Yeah. Well, really, I mean, I'm beyond serious. This is
no, yeah,
very important.
Yeah, no, I think what he's saying is he has a lot of other scientific data and in-depth analysis and stuff that, and again, that's perfectly fine. I know that that's an area that you guys are sensitive about. So I just didn't want to.
For me, listen, I was going for cybersecurity. So it was
believe me, I would not disclose anything that I wasn't comfortable disclosing.
So for me, find some kind of, I think is a breach of some kind of thing. It's just in my nature, I have to, because that was the thing that I chose, to close the gaps in.
Wonderful. So. Oh, well, thank you, Lulu.
Let me finish up,
Jeremiah. And
right. Let me finish up with his question. I'll let you in on a little thing that we found. I haven't spent a lot of time researching this, but when you turn the motor off, drive motor, there's different definitions. The VEM drive. When you turn it off, it still moves.
Yeah. Absolutely. And that's specifically what I wanted you to talk about. The reason why I wanted you to talk about it, and I know you don't want to talk about this because it's one of those things that currently you think is a really deep, dark secret. And it's one of the great discoveries that you haven't heard priorly talked about. But I did some deep digging and it turns out there's actually 9 other drives that also show the same exact thing. And so because you put in so much work and so much effort, and because you have a functional version of a device that can be demonstrated today, right now, you're in a position to basically, they're going to come out and talk about their wave bands, talk about all that information too. So why let somebody who put in less work be the first to talk about that when realistically you're already on top and you could be positioned perfectly to be recognized and credited for what you've already discovered? Because otherwise they're going to start talking, and they're already talking.
Yeah, I would say with lifters, we saw the same thing. It's interesting that you mentioned that, David. We did see that. I saw the same thing. It's a horrible way to describe it, but I almost felt like it was conditioning space. The effects are not. Yeah, it's not tied to the power on off, and in our case, we didn't see anything like what you have, right? With the far more rudimentary, but we did see some weird stuff, and it wasn't directly tied to the on off. It felt like there was a space itself was changing a little bit. So
the other interesting piece of this and the development of the VEM drive is that it comes from a natural occurrence in nature. Antimatter, thunderstorms, the evolution of this particular situation of non-sustainable local space warp bubbles and these aircraft that went through, these airmen that went through this. And we have their testimony and we've got their data. Most scientists ignored these people and said, like on these typical TV programs that the guy's crazy. Or you have Michio Kaku criticizing, calling Bruce Gernon.
David, I just had that a second ago. I went out to Sonny White and told him, listen, David Perez is working on this right now. He's got results. Come and check it out. And he totally blew me off. Said, no, I'm going to go to this other conference room. And he didn't even go there. He was just trying to get rid of me.
Well, that's
the mainstream is not interested in listening to this.
No, they're not.
They're totally. I just experienced it 2 minutes ago, and I could take my laptop over there and watch, literally chase him. He'll run away from me. He's like, they're just not interested in this.
Well, here's the other part. We know the government's been watching us. That's why we have the website. That's why we do these things. So we just let them know this is exactly what we're doing. I find it's easier to hide in public than it is to, hide in my lab and then have them pull up in their, black SUVs. We have had a break-in that was like over 2 years ago, and they did steal some of our parts and they damaged our system. It took 3 months to bring the whole thing back up online, but they broke in. It was very touchy on how we figured out that they did break in. See, I always have the power turned off in the lab. I don't want to end up like Nikola Tesla with his lab burning down. So there's no power in the lab at all. So when I leave, that switch, boom, it's gone. Well, I come into the lab and the lights are on. And I'm going, what is going on here? I'm looking around. I can't see anything missing. And then from the day prior, we were going to do a live stream to lift a motor to demonstrate. Well, guess what? System doesn't work. It's like a short somewhere. We're checking it out. And then I noticed that one of our motors is missing that we have, but we have 18 of these things. It's kind of hard to keep track of all this pieces and parts that you got hanging around. And then I noticed the one I had hanging up over the workbench was missing. And then I looked and some of our fractals were gone. I knew exactly how many fractals were sitting on the bench. There were 16. 2 of them were missing, and 2 of the associated plastic plates that we put them in were missing. Now we 3D print our motors now. So, we've cut down on weight. We've gone from 10 pounds down to less, actually to 1 pound. And the way I'm looking at this, the lighter I can get the apparatus and the more efficiency that I got, less power, more compression of the fabric of space, then the more dramatic, more than 4 millimeters of lift on the motors right now. But it's lifting itself plus the harness. I mean, it's there. But no one wants to believe it. They only will believe
it's like Galileo, that they refuse to even look through the telescope. And here it is in real life. They're refusing to walk 150 feet and come and check out APEC and see actual results. They'll rather push you off and run away.
Right.
Yeah, well, David, I should mention we have a number of people in the conference, and I am not one of them, but Mark is very deep into 3D printing, and I believe Thomas, who was on earlier, I think he's still with us. So that might be an area that people could contribute as well. With
we also have a large 4-axis CNC machine, and I've been cutting lots of copper sheet. Yeah, we can cut you some stuff if you like. I've actually done that for Todd Desiato over here, and he just sent me the diagram, and I cut some aluminum stuff for him and shipped it over.
Yeah, we have to go out to get that done. We outsource. And
so we can take care of that. We have up to, I think, 30 by 20 by 16 inches is what we can cut.
Wow.
Yeah,
very
so
nice.
I just thought I'd mention that because Mark is really active, and Jeremiah is active also, although he lives kind of a different part. So I think Mark is the person with the big lab. But then, again, we have other folks like Thomas who are doing a lot, and like I'm not sure if you heard earlier, they were talking about material science stuff. So
yes, I heard that.
Yeah, there's a lot going on here, and what I found is folks are pretty willing to just help and contribute and stuff like that. So. And it looks like
Jeremiah's holding up.
Yeah, so I think Jeremiah is already
into some fractals there.
Yeah. Well, again, I think he's been greatly inspired by your work. He's been talking about it for like 9 months. So
I've been watching QED since QED started producing videos. And then I watch those videos disappear. And then I watch the new ones pop up, and then I watch those ones disappear. And you go through the process of realizing that you come across something that you maybe were a little open about at first and thought was much more. Well, the thing is, it was exclusive because nobody was talking about what they were seeing. It was just too weird. And now finally they're all coming out of the woodwork. The gateway has been opened. Pandora's box will not be closed. And
Well, we have a
we're the
couple.
demons that are coming out that that
Go
the
ahead.
others are afraid of. So
yeah. Well, let me go to Michael Boyd. Michael had a question. Michael, go for it, sir.
So Dave, I'm curious, you know what a lightning sprite is?
Yeah.
And you know what an elf is? An elf, it's the one that's like a circle and it's up at 50,000 feet.
Oh, yeah. Okay.
Okay. Would you consider those both forms of positive lightning? By positive, I mean it's a positive charge as opposed to a negative charge, like from the Earth from the bottom layer down to the Earth. That's a negative charge.
Well, actually, the lightning down to the Earth
can be positive too.
Is positive actually.
Oh, it is.
Yeah. The current flow out of the clouds go positive to ground positive. So positive out to ground, then up. So go negative from the ground up to the base of the thunderstorm. And which is
that's my understanding too.
Right.
So my question is so in your experiment, did you see any coronal discharge?
No coronal discharge at all.
Interesting. So that's my question. I'm just curious about.
Now the fields that we produced, that we actually mapped the signature, the warp signature, which I believe is a first, took us a long time to develop the code, to analyze it, to manipulate the code, to collect the matrix of data and then produce an image. Kyle Finley, he does all of that for us. And we have an engineer, Jim, he's our double E, and I put out the specifications for the equipment. I help assembly, I build the motors, I design the motors. Everybody's delegated different responsibilities in the organization. There's about, and we have people dripped in and out, but we have about 8 people in the group, 4 highly active people. We meet, and when we're doing experiments, everybody's there and collecting the information and whatnot. But to answer your question, the sprites and blue jets that come up from the tops of thunderstorms, since it's a positive current that comes out of the top of the thunderstorm, I could only assume that it's a positive energy that comes up out from the thunderstorm.
So like anti-gravitational as opposed to gravitational. It's repulsive.
You know, in that context, in the atmosphere, I don't have any data to support that.
You just know it's electrostatically positive.
Yes, that's correct.
Okay, well, I appreciate
it's a lot of it's a lot of energy.
You didn't observe any of that in your experiment, which I thought that which is probably how you can make it coherent, where you're actually getting that time or that, I guess, what is actually changing? Is it space?
Yes.
It's
yeah,
the actual. It's kind of like expanded space-time. So Hal Puthoff described it as he calls it anti-gravitational, or it's actually the length dilates.
Well, the compression of the fabric of space is what we're dealing with here in our space-time.
Oh,
so what we're actually doing is forcing local space and to compress it and form a bubble and in this case, around the engine. So if you go to the website and you see some of the imagery that we have there, the graphics, you'll see the base plate expanding out and the top plate expanding in. The compression of the fabric is space expanding or compressing into the motor.
Gotcha. Okay, well, thank you for answering my questions. I appreciate it.
Now, David, I have a quick question actually, and I'm not sure if this is something that you guys have looked at or not, but I'm really intrigued by when you looked at the aircraft and the flight times and things like that. Oh, sorry about that. So, because you're talking about the Dragon's Triangle and the Bermuda Triangle, did you guys look at the ships at all? Right, that's been the long-term ongoing mystery. I know planes are a big part of that, but
I have, and I've gotten several emails from guys who sail yachts that got displaced. There are many accounts in the Bermuda Triangle. I've actually flown in the Bermuda Triangle, collecting data. And you got to remember also, this is not a phenomena that's isolated to one part of the Earth. When the weather forensics have shown these parameters, and I figured all that out, in between a high and low pressure system, the zone of transitions, when you get a lot of convective activity coming up, and this can happen all over the world. If you have solar winds that are over 700 kilometers per second, this is a good time for this actual phenomena to occur on Earth. In my particular case, when I did the weather forensics and I analyzed 26 aircraft after out of 50 plus aircraft that disappeared, I found a commonality of the investigating the weather forensics. So onshore flow, dew point to ambient air temperature less than 6 degrees. All these characteristics start the thunderstorm activity into the Key West, and then it flows up towards 20 degrees north latitude. And this is also involved with the trans-equatorial propagation of electrons that occur up and past 20 degrees north and south latitude. So this energetic atmosphere on the strong side of the sun, this occurs every day. But when you get these other characteristics from space down and from ground up, this is the ideal time. And it appears that early December, because this flight that this Tiger Moth took was in the late fall. I didn't have an exact date, but they indicated it was late fall that they were flying. And this all could correspond to being able to predict when this can occur in an aircraft fly through. My problem was, okay, if I can pre-predict this, fly an aircraft through, and then this thing does a linear displacement, depending upon which way I'm pointed, I could run out of fuel or I could get to land. In Bruce's case, he was fortunate that he was headed east to west. If he was going the other direction and encountered this, he'd be out in the middle of the Atlantic. He would have never had enough fuel to get back.
Well, it sounds like you could use the analysis and the technology. You could also use this to develop kind of an early warning system, right? Something you could put in an aircraft or a ship to help improve safety.
To detect the warp bubble, we haven't done that yet. We only produce warp bubbles. But from the weather standpoint, from relating the parameters of weather to look out and beware, yes, they could do that. We could come up with a weather forecast for warp bubbles. They don't occur very often, but the thing is that we could produce a early warning system for pilots beware in these regions. I don't know if anybody would accept the parameters, but anyway, we could make an attempt to do that.
Yeah, no, that's intriguing. Well, let me go to Wayne next, and I should ask how you're doing on. So we're around 3:30 now. We have about half an hour left in the Q&A session. I should ask if you're doing okay or if you need a break or anything like that.
I'm good.
Okay. Just wanted to double
I
check.
I teach 4.5-hour classes. So
And you go online too, right?
Yeah.
So
I'm just getting warmed up here.
okay. Our 11-year-old did online school last year, so that was a learning experience. So my hat's off to you, sir, because that is not easy. But
no.
Okay, well let me go to Wayne then. Wayne, go for it, sir.
Hey, that's fascinating. Very fascinating. Your work there. I was wondering if you could comment more on the geometry of the so-called warp bubble. Like, is it a sphere, or does it kind of project in different kind of geometries through space? Or could you mention 140 centimeter distance between your torsion balance and this device
and the motor? Yeah. We have different size engines. We have engines that are 6 inches, 13 inches, 2 feet engines. Those are our modern ones, our newer ones. There's been comments from people. We applied for an NSF grant. We got rejected, and provided it took 3 months to put all this stuff together. And one of the reviewers said it's impossible, can't happen, even though we provided videos. And as you're saying about the warp bubble, we described what they would look like. And the warp signature mapping that we've done goes out to 7 inches. And it still has the same characteristics of going into the engine and coming out and expanding behind. So should I define this as kind of a circular or an actual bubble? That's more a description than it is reality. My experience so far has been that it's not, quote, a bubble, so to speak, but it's literally like taking a slinky and compressing it, but it going into the motor. And then as you look at that image that we produced with the undersheet, you can see where the outer top part starts to expand up and around. And that, I guess you might want to consider to be kind of a bubble. But I think in the symmetry of it is that it's not really going to come out to be a, sphere, like a bubble, a bubble that kids would play with, with soap bubble.
Yeah.
Not going to look like that. It's actually going to be more definitive, depending upon the engine that you use and the amount of power. All of that will be adjusted. At least that's how I'm predicting it. I mean, the experience I have right now shows that that's exactly what will happen. Now, maybe at a higher level of energy, we may get something totally different, but I kind of suspect that it's going to maintain a signature like we've produced already. If it's that way at 10 watts, it'll be that way at a 10,000 watts as well, if not bigger.
Yeah, and correct me if I'm wrong, but it has to do with the wave fronts of the radiation coming off those antennas and how they collide with each other and create like a superposition.
So the near fields,
like a crossover of the two different amplitudes of.
Yes, yes, the near
so
fields.
That doesn't imply necessarily the formation of a sphere or a bubble. So
that's correct. However, as you look at that image, you see where it curves out and around.
Okay.
So there's an influence to the exterior space, which ties into Alcubierre. So I would classify this as an Alcubierre-based warp drive. I'm using the term warp drive because we couldn't get our papers published unless we changed our terminology to variable electromagnetic drive. And because Sonny White had gotten his paper published by the AIAA, which there's been a lot of criticism of, I'll just mention, we couldn't get our paper published until we went the realm of variable electromagnetic drive. And once we did that, the correspondence principle was in force. We're not going outside, the legions of science, and you must conform. Hey, look, we think outside the box. This whole thing was outside the box. And as far as we know right now, we don't violate any of the accepted physics laws, except I damn well intend to go faster than light. And once we can get this out in space and we can encourage miners to actually engage these engines, purchase them to get to point A and B to make the turnaround, that's where the next revolution of our economy is going to, it's not here on the earth, it's out there, becoming a spacefaring nation. And I am so tired of all the talk, and NASA pushing off their projections to go to space. You got Elon Musk trying to get to Mars, and it's going to take him, he says, 7 months. But the astronauts, whoever's inside these craft, are going to get overly exposed to the radiation. They're going to be dead or nearly dead by the time they get there. They're going to experience over 300 rads of radiation. At 125, you're puking your guts out and you're red all over like you've been exposed to the sun. The engine that we have today, the estimates that I made with the constant acceleration, we could get there less than 45 days. That cuts the exposure down to a minimum. That means you could get there, you could come back. However, all the emails, all the papers that we've tried to send him behind the scenes, it's fallen on deaf ears. And so, you know, that's what we live with.
Or were you sending it to Sony White papers?
No.
Oh, to the AIA?
AIA, we published the paper for the 2018 conference in Cincinnati, and we presented there, and the room was packed. They didn't have any of these little side discussions that had as many people as we had. But then afterward, everybody left. And, you know, that's
Nothing happened.
You could hear a cricket.
That's that's the main. That's
we
the
have
mainstream.
We have an experiment coming up using standing waves on a basically a round plate, and trying to get some interactions with that. Why were you using fractal antennas instead of just regular dipoles or plates?
Being the ham radio operator that I am, I don't like buying anybody's stuff. I build my own. And I had heard about fractals. There was a professor at MIT. Actually, the company name is Fractal Incorporated, I believe. Anyway, he was restricted to an apartment that didn't allow him to build antennas and hang them outside. So he got this idea, hey, what if I built a fractal, put it up on the window? And what he discovered was that the fractal, so long as you keep the a wave characteristic, in other words, say you're doing 150 megahertz, okay, and the antenna is tuned and it's like over 3 feet to equate to 150 megahertz, but you can take fractional pieces of that, and what he found out with the fractal analysis or his fractal antenna is that he could have the same amount of gain as a full size heavy antenna. And so taking that idea and incorporating that, I had a real problem, despite the fact that I figured out how these pilots got a linear displacement. How could I reenact this, artificially create this? Do I create 2 huge radio antennas and then sail an airplane through it at, you know, hundreds of thousands of watts of power to create that scenario and poof, you know, let them go out? And the only way to achieve this and to miniaturize it was to look at fractal technology and to use fractional wavelengths of the frequency that I was using, which is emulating a thunderstorm. Does that answer your question?
Pretty much. I just wanted to say that if you need any fractal antennas made, we'd be glad to help you out in our lab. We have lots of copper, aluminum, steel, all different materials. I could CNC it out and ship it out to you.
Okay.
Anything that can move this technology forward, would be glad to help.
Yeah, and the other thing I always need to mention is that in one of the declining of this technology from NSF was that they didn't believe this could be scalable. Well, we've scaled it from 6 inches up to 2 feet. And I've gotten results on every engine that we have produced. So apparently they didn't read, they got paid to do this analysis of our proposal. And this is the kind of people that we got at NSF. I mean, maybe they've done some great stuff, but we laid it all out. But that's why I won't patent this thing. The patent pending is to put our placement of intellectual property. If you patent stuff, the US government can come in and take it. And they don't have to pay you. They'll declare national security, and that's the end of that. So that's why even talking to Harold Puthoff, which I've had discussions on the phone with him, in the past, he said they don't patent anything because of the fear of the government coming in and taking it.
Yeah. Let me go to Thomas Anderson next, because and again, Thomas does a lot of material stuff as well, so he's a good person to ask. Thomas, go for it, sir.
Yeah, can you hear me?
Yeah.
Okay. I was going to say that was my question, was like, what materials are acceptable materials for the fractal antenna? Like, as far as the conductive part, like, could you use graphene foam for it?
We've not tried that. Our standard is copper. We've done solid state etching on circuit boards with our patterns. We've CNC'd out the fractals. We have used solder, and we have produced solid state arrays. This last motor was aluminum.
Actually, I just realized if the graphene foam doesn't work, because the reason I thought of that was that you can use a very cheap laser engraver to do really tiny controlled fractals using Kapton tape, and it turns it into the graphene foam. I made the mistake of basically trying to use a what do you call it, electrolysis process to speed up removing aluminum using copper acetate, and I ended up plating the graphite with the copper. So that means that if you connect to the end of the fractal array and put it in like a solution of copper acetate and using the copper electrode on the other end, you should be able to plate the whole thing just where the graphene is formation is formed. And because it's a foam, it should infiltrate the graphene too. So it's not graphene and then a layer of copper, but rather you end up with this fluffed up graphene that is filled up as well as a coating of copper across the top. So,
well, we're very interested in solid state copper arrays at this juncture. The less we found through experimentation, and I don't know, one person mentioned, why cut somebody else's progress, but it doesn't take long to figure this one out. Solder crystallizes with these arrays.
Especially with bismuth in it.
And what we had to do was about every 50, 60 runs, we'd have to strip all the solder off and redo everything. So that's why we went to solid state. Our solid state circuit boards work fine. However, the thickness of the copper clad was not enough as we went up in wattage. We'd blow fractals right off those things and cause a lot more additional work. But look, this is 10 years in progress. So of course we know a lot more stuff than somebody else is starting out. We've had people ask us, can you send us plans and diagrams? And I'm going, are you out of your mind? I'm going to turn over everything I know about this thing just so you can experiment. I don't think so. Would you go to Boeing or Lockheed to do the same thing?
Right. So, well, I mean, the economy thing was mentioned earlier, and it's like, I don't think people realize that the only way to go to a moneyless society is to make people stop counting, period. No numbers, period. Because we use that as a tallying method and my understanding is it's a tallying of ideas to direct, energy to do the work, and materials to create. So that's your money. So you're counting that, and then you tally that up. And of course, there are people, who do a bunch of misdirection in order to basically be like stage alchemists, like a stage magician, where it's not real magic, it's just sleight of hand to turn paper into gold and whatnot. But the concept is still solid. Just because somebody is using people's ignorance to basically rip them off using that concept,
right,
doesn't mean that the concept itself is bad. Just like you can use a gun to fire something to cut through material in order to make something, just as easily as you could go out and use it to like extort something from another country. So it's all who's using it and what's their intent, and how do the other people feel about how it's being used against them. So, but yeah, I have experimented with that, just using a 50 milliwatt UV laser to make conductive foam, and the conduction's actually pretty good. I mean, 10 centimeter squared, it's like between 0.2 and 0.5 ohm. So, and I would think that the carbon would be more durable because of the fact that the graphene layers themselves are actually stronger than diamond, and the heat levels that you can hit with that, as long as it's not oxidizing. If you're in an oxide environment, you can't do this, but in a non-oxidizing environment, you can hit almost 5,000 degrees before it finally melts.
Huh?
So, but I mean, I wasn't sure if there were other properties about what you're using for it that are necessary that this would not have, and therefore it wouldn't just wouldn't be usable for it. Just like bismuth has a diamagnetic property and steel doesn't. So if you're trying to build something that needs a diamagnetic property, the steel is not going to do you any good.
Right. And that's why our material science investigations has been limited because of the cost involved in getting these things produced, buying the copper, buying the aluminum. Everything's gone up in price very substantially. And so we haven't explored that, except it's a small team. Here's my problem. All the various techniques that could be incorporated into this motor are great. My goal is, and my focus is, to get this damn thing off the ground, 10 feet, 20 feet off the ground. And at that point, nobody can complain that this thing doesn't work. Right now, they're still, looky-looksies, looking at this thing. Oh, it only does 4 millimeters. Well, show me an ion drive engine that can do more. They can't.
Can I make a suggestion?
Yeah.
Change your goal to making it useful, because that seems to be the one way that stops all of the pushback, where they say, oh, you're crazy, or that idea won't work, or we don't want to use that. Because the second they see you're going to get an advantage they're not going to have, they will come and do whatever they have to get that advantage too, and not be left behind. So if they even think you're going to do it, it doesn't even matter if you honestly think you can get to that point because of the cost and everything. If it's put out there that you're going to be capable of doing that, they're going to be knocking your door down to try to work with you and do whatever they got to basically get your benefit, your capabilities, in order to basically make this thing a worldwide available technology to change the economy, like you said before, of being able, like you said, you were talking about miners and turning around and whatnot. And my thought is, if you have that capability, why mine like what most people would think of? Oh, you're going to go mine asteroids, you're going to go to other planets and mine. There's nowhere near the amount of material in all of the planetoids, all of the asteroids, all of the Kuiper belt, everything else that's in our solar system than there is inside the sun. And you can use the very energy the sun has to pump that out as plasma and catch it. And it actually reduces the poisoning it does to the sun, so that the sun will last longer. So.
Well, the reason why I mentioned about getting the altitude is that as a function of Burning Man, there's a art project that they want to do and lift it with a warp drive. And so my goal to getting it to 10 pounds. Hey, believe it or not, they got 70,000 people.
Oh,
and they got
but yeah,
checkbooks.
I was gonna say, if you
I will
wanna see how
personally help you
crazy
with
and how
that.
rich
If we're
those
going,
people are,
if we're going to a Burning Man with a warp drive, that will be disclosure.
well, I was gonna say, if you want to see how much money and how
Yes.
crazy the people are that are behind all that, go look up Omega Mark, because it's the same people. It's the BlackRock Art Foundation
Yeah.
that funded, and then like it's like they said, hey, yeah, here's enough money, build a whole Walmart and just stock it full of professional grade products that are you're gonna have to make them yourself, because it's like sodas that are like the flavors new car smell, you know.
But
Now,
that's what one of our goals, one of our reasons to improve the motor weight of the motor, or to be able to lift more, is for that very project. It's a worthwhile goal. I've been told that it could be a year, 2 years off, but then again, I've been in this for 10 years, so I don't expect much patronizing from any aerospace company, anybody from NASA. We've actually sent an envoy out to NASA, to JPL, and no interest, despite the fact
I
they
think
had
the
the
reason-
videos and everything else. No interest at all.
Well, I think the reason you're not getting any interest there is because of tenure. Once people have gotten used to the concept of tenure, they really don't have any drive to do anything more than what they had to in order to get recognized and get into getting the tenure. So they're going to push back on anything that would challenge their position.
That was the impression we got, was that we're working on soft money here, and we're not getting involved in anything that distracts from our livelihood. And that was pretty much the nail on the coffin right there.
Yeah. So
well, let me go to Harold Tabarez next. So Thomas, thank you again, and Harold, go for it, sir.
Great presentation. I like it a lot. But the idea that somebody broke into your lab is still in my mind. So I'm wondering, if you were to speculate, an educated guess, do you think was an aerospace company, a propulsion manufacturer, or some foreign country that may have broken into your lab, that may have some interest in gaining your technology, your know-how, so that they can themselves then put it out in the market? What is your educated guess?
We initially thought it was the government and one of the intelligence agencies or something. But then again, they know about us, and I've been told by people in the government that have contacted us that we're being watched. So I don't believe it was one of them. And if they were really that professional, they would have turned the lights off. Unless they wanted us to know they were there and they got our stuff. They broke lights in the back of the garage. They came in through the back and picked the locks, because they're always locked. I don't know if you know people from New York. If you don't lock stuff, it's gone the next day. I'm a New Yorker, okay? I'm looking over my shoulder, everything. I'm Mr. Security. I got, but they did their job. And the other thing that really disturbed me was it wasn't so much taking the motor parts, because I don't care. If you took one of our motors and you tried to replicate the stuff, it ain't gonna work. You got to know all the other pieces and the parts. You got to know all the process that goes into it to make it work. And if you don't know that, you just wasted your time. We've had people try to replicate it and they get horrible results. Well, sorry, we're not giving that out. So as far as speculation goes, to answer your question, I really don't know. I honestly don't know. I suspected intelligence agencies, but they left the lights on, and that's a sign maybe they ought to get some new intelligence guys.
Oh, so do you think maybe it was a competitor then? Maybe it was a competitor, or like a crazed fan or something like that.
Yeah, it could be, but I'm here all the time.
Yeah.
And it was done late at night, I can tell you that. And I'm kind of a light sleeper as well. And I get up through the night, I got ideas, I write them down. I go to bed with problems, and I get a solution, I wake up, I'll write it down. So whoever it was, they were in between my sleep cycle, like, or I was deep in my sleep cycle, and they got by me. But
yeah, well, let me go to Jeremiah, and I think we're pushing up close to our time. But Jeremiah, go for it, sir. Oh.
Yeah, the reason I wanted to just put in one last question / comment here at the end before he goes off is, David, do you have any restrictive corporate, government, or other investment interests that would prevent you from working with private individuals in terms of funding?
No.
And even if that funding was small or something, I mean, would it help you guys out in a significant way, do you think? Putting every dollar to use?
Well, depending upon the amount of funding, would make a huge technological jump. Right now, I self-fund everything. That's why I work 5 jobs.
You've got a great outlet right now to basically let people know that you're open to receiving donation-based funding in order to further this research with the reward of teaching the public more about the technology and giving them what they want to see, which is we want to see this stuff get out there for the rest of humanity. So
yeah,
if you're open to that, maybe create a channel so that you can receive that kind of funding. Set yourself up some kind of crypto address or some kind of crypto wallet and give people a link to it so that they can anonymously donate to you if they should choose to. I mean, offer yourself an option to receive private donations that don't legally bind you so that this work can progress.
Another consideration might be, so there is Kickstarter, right? You can do a Kickstarter, and those are usually goal-based, right? Where you say we're going to produce X and we're going to do it by this date. And they usually offer some kind of a reward depending on the project, right? Like you'll get a discount on the first unit or whatever. There are other competitors to Kickstarter, and you might want to look this up. I always say anyone in this conference, there are probably 5 or 10 types of Kickstarter organizations out there. Kickstarter is the big one. There's 1 or 2 others that are pretty substantial. One of them is not goal-based. It's just basically support our project, and they've kind of got their own way of doing things.
Originally, years ago, we did Indiegogo.
That's the one I was thinking of.
And it was a total failure. A lot of work building the videos and all that. It's still out there. We asked for it to be deleted. Oh, we don't delete anything. So all of our videos and stuff is still up on there. And but it was a total failure. We've talked about doing some funding. My real goal is to get a buyer for the technology to go to space. And that may be another year, another 2. I mean, we're getting by fine right now, but yeah, if we got additional funding, donations or whatever, we could definitely push the technology. I mean, you almost need to go full-time on this project. I spend a lot of time working on it, but I also have other duties that I got to fulfill. And that's the only one. I basically teach 3 full-time faculty positions. I teach 75 semester hours a year, and I go all year round. So this is kind of like a vacation. I'll come back again if you want.
Yeah, no, I would love to. I'll say that right now. I'd love to have you come back again. We'll figure out when it works and
sure. I mean, yeah. I love to talk about the technology, and I love to share the ideas and share the videos and things of that nature. Sometimes being able to explain it more you get additional ideas, and I'm all for that. We got some new designs I'm really excited about pursuing, and it will, I believe, really revolutionize the amount of compression of the fabric of space. I got several designs, and they're on the drawing board. I had several. There was somebody was talking about particle entanglement, and we've actually got equations to build to initialize a particle entangled tunnel, and then put the warp bubble inside. That's all theoretical, but it's looking pretty good. I've spent about 3 years working on those equations. And our engineering equations that we can pre-predict the amount of power and the amount of compression of the fabric of space, or how many newtons does it produce, are looking pretty good as well. So the predictor for engineering is kind of critical in advancing the technology.
Wonderful. Well, so we are just at the top of the hour. So David, I think that's everything. Let me put it back on gallery view. Everyone, please give David Perez an enormous hand. Sir, I cannot thank you enough. If you'd like to come back, we'd absolutely love to have you come back. But
you bet. You bet.
Yeah, give it some thought. Find a time that works. We'd love to have you come back. So again, I want to say thank you yet again. And I should go to Todd Desiato now. Todd is here, and we're squeezing our schedule a little bit, but
can you hear me?
I can.
Coming through.
Todd, let me hand things over to you, sir. Welcome back. It has been a while. You have a lot to share. And you were talking about, yes, spin stabilized magnetic levitation versus gravity. Now I will hand things over to you and mute myself out.
Yeah. Okay. Let me know if I can't hear me or something. Okay, so last year around this time, I did a talk about quantum gravity from atomic resonance states. And in that model, I discussed the harmonic oscillator in a gravity well. And in the gravity well, from the perspective of an outside observer looking from far away down into the gravity well, the oscillator falling into a gravity well is losing power. And that's depicted here by this first equation. You have so you're subtracting a delta P for power. And anti-gravity and warp drive are the opposite. So the total power of the oscillator is increasing. And the reason this is relevant is that in the polarizable vacuum representation of general relativity, originally by Halpatoff, this coincides with a variable speed of light due to a variable refractive index caused by gravity. What I've shown in the previous presentation was that this can also be modeled by quantum radiative damping acting on the harmonic oscillator. The effects of radiative damping and the effects of gravity appear to be identical. So with that in mind, you can have a potential and just an arbitrary binding potential, but I propose that we take Planck's constant times the gyromagnetic ratio times the magnitude of the magnetic flux density. And this was related to gauge potentials and magnetic flux density, the magnitude of the magnetic flux density affecting the frequency of subatomic particles. In other words, the Compton frequency of an electron, for example, is affected by the magnitude of a scalar magnitude of a magnetic flux density. So from that scalar magnetic flux density, we define that as chi, and it's the sum of all the quanta of magnetic flux, the Webers or the Weber field. And from that, we can apply Poisson's equation and calculate solutions. And this led to mimicking free fall in a gravitational field using NMR, nuclear magnetic resonance, or electron paramagnetic spin resonance, or dynamic nuclear orientation. Last year, I started out working on building my own NMR machine. I had to build a 0 Gauss chamber, and at the end of the day, I couldn't get it to work because the weight that I need to measure a change in weight due to the effect of this equation in a gradient magnitude of a B field, that my scale balance, I never got it to work, and I'm still kind of working on it. And then Mark is still working on the Alzaphon experiment, which is the same thing. He's going to look for a change in weight of a test sample. Sorry. And then, and these are the experiments that we had proposed last year. Then this came along, the Graviflyer by Alexei Chekurkov. And this thing is not a drone. There's no propellers, and it apparently levitates. He has many videos on his website, which is a YouTube channel called Technologies from the Garage, for those of you that can't read Russian. And it's got, he's got a lot more than 4 videos there about the Graviflyer, and he goes to great lengths to try to show it's real. And he even provides a schematic. He's got diagrams and a spinning disc exerting a force upward. There's a motor, there's the spinning discs, and then he's got, he's shows close-ups of it. You can see under here, it's a lot like what was proposed earlier with the spinning magnets on an iron steel disc. And then he's got another disc above it that spins they counter rotate each other. And then he's got high voltage, supposedly about 30 kilovolts applied negative to the bottom disc and positive to the top disc. And here's a diagram of it, negative to the bottom disc, positive to the top disc, with a Tesla coil attached to the center disc and the vertical support posts, and a little regulator and an oscillator that generate an ultrasonic frequency. This little speaker cone on the top is the ultrasonic speaker. Although in the video here on the bottom left, there's no audible sound of that oscillator. On other videos like this one over here, you can hear it at about 12.4 kilohertz. I'm not sure it does anything. I'm not sure the Tesla coil does anything because it's not a hardwired connection. It's just floating. And when you touch it, that charge gets grounded to 0 and the thing still flies. Here's a picture. He's kicking it and it comes right back. And when it's sitting there hovering, it's like it's pinned to that spot, like magnetic levitation and flux pinning. And that's just the way it behaves. So again, I'm not sure that the Tesla coil actually does anything because he can touch it while it's flying, which grounds this out because this is not a hardwired connection. It's just a close proximity and it still flies. And I'm not sure this ultrasonic resonator has any effect because he touches it and it still flies and it doesn't seem to change anything. And in some videos, it's not working. You don't hear it. So the gist of it is the spinning magnets and the counter rotating plate above it is like a spinning parallel plate capacitor with magnets. And this reminded me of this little homemade toy. It's a homemade toy that you can watch this video on YouTube. The guy makes it out of magnets and a CD case, and makes a little spinning top and can make it levitate. And if you have ever heard of a Levitron, it's the same thing. I used to have one. In fact, I still do, but I could never get it to work. But that's what Alexei has, is the same kind of configuration, all the magnets facing the same direction, but it's the magnets that are spinning. And I think it's the Earth that's the top, and that makes it levitate. And so I went investigating this, and I found this paper, very informative paper, and it says that the stability of the levitron cannot be explained if the top's axis has a fixed direction in space. Stability against flipping is not enough. Gyroscopic precession around the local magnetic field direction is necessary. An analysis and numerical integration of the equations of motion for an experimental stemless top that includes gyroscopic precession around the local magnetic field lines predict that the top will be supported stably up to spin speeds of about 3,065 RPM. An upper spin limit of 2,779 RPM for this top is observed experimentally and explained as an adiabatic condition. And spin-stabilized magnetic levitation is a macroscopic analog of magnetic gradient traps used to confine particles with a quantum magnetic moment. And that's very important, the quantum magnetic moment. Now, Alexei says his motor is spinning just around 3,000 RPM. And we measured it based on the sound of the motor, that it's probably around 2,800 RPM. So it's right in that range where their paper says it should be. And this is what they modeled. It was basically a ring magnet, polarized. So the two flat faces are, the flat face is north and the bottom flat face is south. And the spinning top as the bottom flat face is north and the top flat face is south. And you can see here it precesses about the magnetic flux lines. The gyroscopic action must do more than prevent the top from flipping. It must act to continuously align the top's precession axis to the local magnetic field direction. Under suitable conditions, the component of the magnetic moment along the local magnetic field direction is an adiabatic invariant. When these conditions are met, the potential energy depends only on the magnitude of the magnetic field and gravity. While each component of the magnetic field must satisfy Laplace's equation, the magnitude of the magnetic field does not. This allows the curvature of the potential energy to concave up, not a saddle point, at the levitation height, forming like a bowl for the top to sit in. And the fact that this force depends on the magnitude of the magnetic field matches what I was saying, a year ago back here with this equation, with the magnitude of the magnetic flux acting like a gravitational potential. So it's the same thing. So now he gives these equations with the torque, and this is the force we're talking about that centers it and holds it in place. And then this is the equation for the precession frequency around the magnetic flux lines. And we know the gradient of the gravitational potential, Newtonian potential, is what gives us G. So this is a gradient force, and this is a gradient force. So their combined potential gives us this. And if you take the dot product is the magnitude of the two vectors times the cosine of the angle between them. And in this case, the magnetic moment is parallel to the magnetic field, so there's no cosine term. So you can just substitute in the values mu b plus mgz. And this is your potential energy function that lifts and supports the top. This equation here for the precession frequency is exactly the same precession frequency that we had in the NMR experiment and in nuclear magnetic resonance and in the Alzafon electron spin resonance experiment. This is exactly the same thing. It's not a different thing. The NMR experiment, the Alzafon experiment, and relating this to gravity is the same thing as this device that Alexei came up with. And that surprised me. But we were all in the group, we were all trying to find a way to explain this thing. There's at least 5 groups right now that are replicating this. And rather than try to replicate everything he did and hope it works, I'm going through it methodically, step by step, starting with the spinning magnets and then adding charge and adding a parallel plate on top of it. And I'm going to try several things that would effectively solve this equation here, equation 2. You have a gradient in the magnetic field and a gradient in the magnetic moment. And this leads to a force or a change in the potential energy over a change in height. And as you can see, if we take out that gyromagnetic ratio, then we have the gyromagnetic ratio is the charge to mass ratio. And like I said, Alexei is charging those disks. And then you have this magnitude magnetic field gives you a frequency. So if you pull out the gyromagnetic ratio out of your magnetic moment and effectively just to clarify, if you have a moment of inertia, I, and you multiply the moment of inertia by the gyromagnetic ratio, Q over M, you get a magnetic moment. And that's how you model the magnetic moment. It's the same as the angular momentum multiplied, by a charge to mass ratio, which basically takes out the mass term from angular momentum and puts in the charge term instead. And so it breaks down to the angular momentum times the difference in frequency or the time dilation between the height Z1 and Z2. So now we have parallel angular momentum and the frequency, but now in terms of gravity, the gravitational potential is basically identical. You have mg times height Z2 minus Z1, which you can replace m by the Compton frequency times Planck's constant. So this is divided by c squared is your mass term. So h omega c, g z over c squared is unitless. So this is essentially the angular momentum times the difference in frequency between the two heights. It's exactly the same. So this magnetic potential and the gravitational potential, it's just a mimic of it. It's the same equation. I hate when I do that. So it's equivalent to gravitomagnetism by similarity because the gravitomagnetic field has units of angular frequency. Its units are hertz or radians per second. So you have this potential due to Planck's constant and the gyromagnetic ratio and the magnitude of the magnetic flux density, which is equivalent to the magnitude of the magnetic moment times the flux density. But if you paired it the other way, like if you pair Planck's constant with the gyromagnetic ratio, you get the magnetic moment. But if you pair the gyromagnetic ratio with the magnetic field, you get a frequency, which is a gravitomagnetic field. So essentially the precession frequency, which is gamma B, is also equal to gamma squared over GE naught times the gravitomagnetic field. So this is linearly related by this value here to the gravitomagnetic field. And so this is really amplifying the gravitomagnetic field using the gyromagnetic ratio of the particles, or in this case, the disk. Now this came as a surprise to me, and I want to, it's not really that important yet, but it might be. In 1994, and was mentioned earlier today, about Alcubierre's warp drive metric equation, and this is it. And yeah, I know I'm using the Z instead of X because it looks cooler. And then in 2003, I wrote a paper called Warp Drive Propulsion in Maxwell's Equations. It's available on ResearchGate. And in that, I used the line element plus the interaction term, Lagrangian density, I should say the Lagrangian density of the line element plus the Lagrangian density of the interaction between electromagnetism and charged particles, basically JA, where J is the current density and A is the magnetic vector potential. So when you take those two pieces in the Lagrangian density and you square them, you get term for term the Alcubierre metric, where the VSRS, the ship velocity, and the ship frame bubble correspond to the charge to mass ratio over the speed of light times the electromagnetic gauge potential energy, I should say. So this is basically the same potential we had before. It is exactly equivalent if you're talking about a circular current and the magnetic flux flowing through that area and the A field around the perimeter, you get exactly that mu dot B is QV dot A, or V is velocity, orthogonal to the direction of the ship velocity. So if we just model a parallel plate capacitor, and this is the voltage, we've solved the equation that creates Alcubierre's metric in electromagnetic potentials. And from this, if you take the gradients of the potential, you get a force, which is what we were talking about. So here's that equation 2 again. Here's your disk with the 6 magnets around. It's Mark, this is the one Mark made for me, but I added a mu metal cover on it. So it's a thin disk of mu metal attached to an aluminum disc behind it. Now Mark had the convenience of a CNC machine and made his out of copper and mu metal. And this all came up after we had already made the aluminum ones and he had already shipped them to me. So so we're working on that. Hopefully we're both working on the same kind of experiment. But what I wanted to point out is I got this graphic from kjmagnetics.com, and it shows a disk magnet on a steel plate. And you can see the flux lines, magnetic flux lines here, and the magnetic field in the Z direction here has a gradient. From the bottom of the steel plate to the top, the Z field magnetic field is increasing. And this is inside a, quote, metamaterial. This is a steel disk, but it's the gradient in the magnetic field inside the material that matters. And now we're going to put a charge on this disk and we're going to spin it to create a magnetic moment. And the magnetic moment acting on the gradient in the magnetic field will generate this force. And since the gradient is in the Z direction, this disk should exert a levitation orthogonal to the velocity V, just like I said in the 2003 warp drive paper. So it's the same thing. We finally found a solution to it. And this matches Alexei's graviflyer, and all of this comes together. Even this is mu metal. This is the permeability of mu metal, or these diagonals here. And this is like a BH curve. And you can see that with a DC magnetic field right through here, the permeability is changing. So you've got a gradient in the permeability in the magnetic plate in the variable magnetic field. So here where I'm saying you've got a gradient in the Z direction of the magnetic field, there's also a permeability gradient in here because the permeability is not constant at these different values of the magnetic flux density. So those two things put together give us a gravitational-like effect off of this spinning charged disk with magnets. So there's evidence of a flying machine that hypothetically may work by ultrasonic resonance. It could be an ion accelerator. The high voltage on the disks could be accelerating air. And or it could be due to gradient forces mimicking gravitomagnetism. it clearly, the behavior of it when it's floating there, it clearly resembles spin stabilized magnetic levitation. It doesn't resemble a drone with propellers. It doesn't resemble something hanging on a string that would swing and wobble around and things like that. It doesn't behave like that at all. And I can't attribute all of that to just the wires hanging off the bottom. It's really, it locks itself like magnetic pinning. So the same gradient forces may be interpreted as the 2003 electrogravimagnetic, that was what we called it, Rick Storti and I, the EGM warp drive equation proposed by myself and Rick Storti in 2003. And experiments are currently being conducted by 5 or more members of our group, including Falcon Space and myself. So there's more to come. I tried to get this thing built this week, but I didn't get it done. I bought a little high voltage power supply unit. Where'd it go? Yeah, this little thing, hard to see. Just a little power supply unit. It's supposed to put out 15,000 volts, but I think I must have miswired the transformer because there's no instructions and it didn't work. So I got to take it back apart and correct that. And I'm not sure it'll give me enough power to do what I want to do. I've got some other parts on the way, but they won't be here till like Tuesday or Wednesday. Hopefully by the next meeting, I might have something to demonstrate. We shall see. Last of all, I'd like to thank you all for coming to these meetings. So the folks here at APEC, we really appreciate it. And we're growing by leaps and bounds. But I also have my own little YouTube channel. I've posted a couple of videos documenting my progress, building my own graviflyer, making my discs, the U-metal disc, showing you Mark's discs, all this stuff. And it's all on my warp drive check channel. And I have, for anybody who'd like to support, because I am mostly self-funded, Mark was generous enough to send me those discs, no charge, and Jeremiah has helped me out quite a bit. But I do have, for anybody else who wants to help us out, I have PayPal and a Patreon, but I don't hide anything there. Everything you want is, I put it on YouTube and it's freely available. So, you're just doing it because you want to support us. So I think that's it. We can go to Q&A really quick, and then
yeah.
we can
Well, Todd, let me do this really quick. So I want to read those out though. So the one on top is paypal.me/warpdrivetech. Can they just go there? It looks like there's more to it. So PayPal.
Question mark local.
Okay. And then the second one is patreon.com/warpdrivetech. And again, you're not holding anything back, but again, if people want to support you, they can go there to donate, and that will go into the parts fund and all that kind of stuff. So
believe me, Amazon loves me. I buy a lot of parts on Amazon and McMaster-Carr, and they're coming to my house almost every day this week.
Yeah. Well, but before we do Q&A, let me do this. We have to applaud for you. Oops. And okay, let me remove spotlight. Let me stop sharing there. And everyone, please give Todd an enormous hand.
Thank you.
And Todd, that was a great presentation. Now, I think last night you were showing me, we were on a video call last night, and you were showing me some of Alexi's videos too, which I thought was interesting. I don't know if you'd want to do a screen share and put some more of those up or not.
I wasn't doing it. Jeremy was doing it. I would have trouble doing it.
Yeah, I would have trouble finding those offhand also. That was why I asked.
But there is a video that Charlie, one of the members of our group, he put together all the pertinent scenes into one video. So he took the like 10 or 12 videos Alexi had, and then he cut out all the stuff that really wasn't about the thing actually flying and demonstrating it, and then he put all the demonstrations into that one video. I'll see if I can pull it up and stick it in the chat.
Okay. Yeah, absolutely. Well, so let's take questions. Who has questions for Todd? And I know you drilled down pretty deep into into the physics behind Lexi's device.
Well, I was surprised because to me, in my mind, there's only one thing that would make it work, and that is if you really had figured it out. And given my engineering model of quantum gravity that I've been presenting since 2016, it appears that he did. It actually appears that what he came up with is exactly what my model predicts. And so if it works, and a lot of people say it's fake, but I don't think so. He just seems to go to great lengths to show it's not. And we'll see.
Yeah. Well, let me go to Harold, sir. Oh, you're still muted, Harold. Let me.
Oh, yeah.
There we go.
Presentation. What I want to ask you, two-part question. Number one, I know you discussed the energy relation, in that particular video, how it would create a force. Going back to another earlier presentation that you gave, how does the Maxwell temporal field effect, applies in this particular presentation that you're giving in terms of a lifter produce a lift, the way the energy input is being used?
Okay, so the Maxwell temporal field is my pet name for a magnetic scalar field. So scalar magnetic flux density. It's just a magnetic flux density with no vector direction. And that's exactly what this is. It's the magnitude of B is a scalar magnetic flux density without any vector direction. So anywhere you see the magnitude of B, that's a Maxwell temporal field.
Yeah,
and so that B field will affect the Compton frequency of any subatomic particle with a charge to mass ratio. So if you change that magnitude of B, it'll change the mass of the particle.
I can see that you're using, exactly providing a vector field with a magnetic flux density. Now, my second question applies to that. Now, what is the role of Newton's third law in that particular example? Is it, where is it going with the Newton's third law? Have you taken that into account in that particular model?
Yeah, it's in terms of the stress energy tensor. What is happening is below the disk and around it is you have a magnetic pressure gradient, and that pressure gradient is what supports it. Now, that equation to generate the force is the gradient in the magnetic field, but it's also the gradient in the magnetic moment. And Alexei has not only the steel plate with the magnets on it, he's also got a parallel plate capacitor that with the counter rotating spin on the other disk, and that forms a magnetic moment. Both disks have their own magnetic moment, and it's possible that he's got a gradient between them in that magnetic moment that is supporting itself in the Earth's magnetic field.
You said, they say a partial Newton third law, like one of them create a force on the other, but the other one does not create an equal and opposite force on the other.
Yeah, and I believe he's exerting a force on the Earth's ambient magnetic flux density.
All right, thank you. Great presentation.
Thanks, Harold. Okay, so actually, while you guys were talking, I found, I want to thank Pablo. Pablo found the clip. So he found one that compared it to Hutchison, and then I found one that, so I guess we have a couple. We could start with this one. Todd, do you want me to do a screen share, or do you want me to send you the clip and you can screen share?
No, go ahead.
Okay, I wasn't sure, because if you screen share, you can fast forward and stuff through it, but.
Yeah, if you don't see him, yeah, this is a good one. This is,
yeah,
this one you don't have to fast forward through because he clips it really quick.
Here, and I will maximize that. Hopefully this doesn't goof anything up. But yeah, I would love your thoughts on this. I'll spotlight you for everyone, and that way we can see you. And
yeah, you can see here, you're seeing right through both discs. You can see right through. He's got the magnet spinning below it, and the one what so it was stuck on the ground, and he touched it, gave it and it came loose from the ground and lifted, popped right up. And then this one, he gets it up. And I think, mostly I think he's either adjusting the voltage between the plates or the frequency of the spin of the motors to get it to lift higher or lower. And then it tends to lock itself right to that spot.
Yeah, see, and then he jumps into Hutchison stuff.
You can skip this.
Yeah. Yeah, the Hutchison. But you know what? Let me go to the other one here real quick.
Yeah.
So we have more Grab-a-Flyer clips, and again, this is a compilation by Charlie.
This is a good one. You're in the middle of it.
Oh, I'm sorry about that. Okay. Yeah, and just let me know if you want me to fast forward through here, Todd. And I would love your feedback.
Just a little bit to get it to where he's got it. You can see it where he's a little further. Yeah.
Like right there, something like that.
Yeah, right there. He's plugging things in.
What is the YouTube website?
Oh, it's in chat, actually. I'm not going to read that one out loud because it's just a bunch of letters and numbers.
No, his YouTube channel is Alexei Chekurkov. I'm going to fast forward a little more. He's still, it's the video is very slow and choppy.
Oh, there we go.
There we go. Yeah.
So this is one of the older ones, right?
Yeah, this was his first one. And I'm not sure he really understands how it works because he built a third one that didn't fly. And he's trying to make it better and he made it worse. So, he's showing his successes and failures. This one, he said, I think this is the one he said someone stole it. And then he built another one that's worked much better. This is the one that had the AC fans. So that's what he just unplugged it. And fast forward a bit, he's done on this one.
Okay. Oops. Oh, sorry about that. So that
he's showing you.
Oh, he's okay. Let me
go.
A
little further up on this one.
Yeah.
Yeah, right in there. So this is the better one. This is the one I showed the pictures of. And he's out here in the field and on another video, he showed the same field and he's got his camera out there. He says, there's no wires up there. There's no telephone poles or power lines. There's no trees. He's out in the middle of the field. And then he gets this big stick and starts waving it around behind it, in front of it, walking around it. And it's just, it would be, it's possible, but I give him the benefit of the doubt because he goes to such great lengths to show it's not.
Yeah. Oh. And Todd just messaged me. He said that we're gonna go to Interstellar in about 5 minutes. So
okay.
But yeah, this is the one that Jeremy Reese showed us last night.
Yeah.
Yeah.
But you'll see he touches it next, and when he touches it, he's grounding out the effect of the Tesla coil. So I don't think this Tesla coil is doing anything. And that's what's weird. And he's grabbing the wires and, he took the weight off the wires and immediately tried to go up higher.
But Todd, it's not directly connected to the Tesla coil. There's wire that feeds into it. So it's not really high voltage, right?
Right. Well, if you're not touching it, it is. But as soon as you touch it, you ground it. The high voltage doesn't have any hard connection. So even a tiny trickle current of microamps through your body is enough to bleed it off. But this thing, you see, it just, even when it's a windy day and the thing just pins itself there. So he must have cranked the voltage way up on that one, because he's lifting all that wire all the way up there. You know, so the thing's got some force behind it. And that equation I just gave you guys, I mean, there's some force behind that equation. It's not a weak equation. It's linearly related to a gravitomagnetic field. So it's as close to mimicking gravity as you're going to get.
Yeah, and he turned it off there, and it drops. So
yeah, but like you guys were saying it previously, when he turns it off, it sits there for about 20 seconds before it actually falls. So it's you know, like you said, it kind of conditions the environment.
I'll just forward through, because he's now that then he does have another one as well.
Yeah, he's got a bunch of them. Like I say, they're all in this video, but
here's another one where you mentioned him touching it. This is the one that I noticed.
Yeah, he's leaning on it.
Yeah, I mean, he's that's probably the best example of any. So I mean, it looks like he's stepping over the power cords. I don't know, but
in this one, this is the one where he kicks it. You know, he kicks the thing and it just comes right back, and it doesn't behave like it's being held up by a drone or it's got a propeller or anything like that. It's not moving the grass below it.
Yeah, and this is further. I'm just fast forwarding through this clip because we're pushing up against Mark's time here.
Yeah.
You know, I guess I would say probably the same way a lot of people feel. When I look at this, probably because of the rudimentary construction, right? It's pieced together and all that. My gut tells me it's fake. I just can't figure out how.
Same here.
You know, like logically, the logical part of my brain, maybe, you know, but it just my intuition is like, okay, this is fake. But then
until I found that paper on levitation, I was right there with you, Tim.
Yeah.
And I saw that and I was like, okay, this equation actually matches what it's supposed to be. And then I was like backtracking, like, wait a minute, this thing might actually work.
Yeah, I mean,
so
I don't see any dead giveaways. I haven't seen any dead giveaways yet.
We got to get him on here, even if we need an interpreter with him to, you know, even Jack needed an interpreter.
Russell Anderson is trying to purchase one of these from him, and so we might be able to get an interview too. And you know, Russell might be able to, if nothing else, he could go through it and say, okay, this is kind of what Alexi is doing. So
yeah,
so it would be interesting. It would be interesting. Yeah.
Any other questions or?
You know what? I think we're all set. I think Mark is patiently waiting for us. So let me stop sharing, and I'll remove spotlight. And again, everyone, please give Todd Desiato an enormous hand. Todd, thank you very much for running us through that. I'm really excited to see as you keep working on this. I'm really excited to see what you come up with.
Well, like I said, I went from working on an NMR experiment where I was hoping to see a couple of milligrams of weight loss to something that hopefully is going to take off the table.
Yeah.
Lift off the table and stick to the ceiling, as I've been saying for 20 years.
It's kind of a high publicity area, right? So whatever on it is going to, I think there's interest there. People are asking questions. So I think that'll help fill in the blanks no matter which way it goes.
Yeah. And I think someone needs to figure out what he's doing. I mean, if there's something going on there, my goal is to find out what it is.
I hope it's not fishing line.
Yeah, me too. Me too. And I really hope it's not like a lifter or it's blowing ions or blowing an ion wind or something. But I mean, the thing weighs several kilograms.
Yeah.
I don't think it would be ultrasonics or ions that are going to lift that thing.
No. Yeah. I would be amazed if it was ions. And you know what? If he was able to lift that using ions, that would open up a whole new propulsion
yeah.
system using ions. So
Yeah,
even,
I
even
mean, it's not millinewtons. It's like, newtons. That's orders of magnitude better.
yeah. Okay, well,
Thank you
so
all.
thanks again, Todd. So let me go to Mark.
Okay, first let's do a mic check because we are using these mics. Can you hear that? Tapping on it.
Yeah. Wait, I can hear something.
You hear tapping on the microphone?
Yeah. Yes, I can.
Okay, and this microphone?
Yeah, I can hear it on that.
Okay, perfect. So this is going to be the mic for the interviewers. We're going to be heading over to the poster room where there are several presenters talking about their alternative propulsion concepts. But getting back to what Todd was talking about earlier, that experiment, I actually helped him CNC some of those discs, and this is something that we built. Has a motor and the new metal copper with the magnets stuck to it, and then there's another new metal copper, and we apply high voltage using this high voltage power supply over here that Jeremiah pop built, and I modified, adding an extra battery to it, so we get a bigger spark. It is of course rectified using a vacuum tube, which is pretty darn cool, and it has this really nice relay switch that Jeremiah invented. So that's a cool experiment that we hope to set up maybe later tonight. If I can find a place in this hotel they won't kick us out of. Interstellar Research Group. This is the symposium that we're at right now. It's very mainstream. We have Sony White here. Avi Loeb didn't show up, but he's doing it remotely, and it's sort of like a half remote, half Zoom. That it's a hybrid conference right now, and it's really strange to see 100 people show up to watch somebody on Zoom present. But that's kind of what we have going on over here. And we're going to go across the hall right now, and hopefully we don't lose Wi-Fi as we do it. And let's head over and see what's happening on the other side of the conference. So we're now in the copper room, and we're heading out across the hall. This is the Marriott. Here's our alternative propulsion poster. If you made it onto this poster, then you're the who's who of APEC. John Brandenburg, Paul Murad, Tony Robertson, who's going to be presenting right now. This is a fold-up poster that we're going to be able to bring to other conferences. Okay, let's head out over here. This is the main atrium of the hotel. Again, this is the Marriott Bonvoy in Tucson, Arizona. And now we're coming into the poster section room. Let's see who. Oh, we're good? We're good? Okay. Here, so we're heading into the autos section, and here is. We have a familiar face. This, of course, is Glenn Robertson explaining his quantum gravity theory. Let's see if we can get him. Glenn, we're live right now. Live on APEC. Here, that's for you. So what you got going on here? Just bring it close to your mouth. That's the speaker. What? That's the microphone.
Well, this is my poster I've done for the 7th Interstellar Symposium. Basically, the paper I talked about before. I've rewritten the paper for the symposium. I'll put some more information into the paper.
Bring the microphone a little closer to your mouth.
If you're interested in it, if you'll go up here, that's my email, and you can find the paper on ResearchGate if you want to just go search for the title there. You can find it. It's hard to explain. This poster is basically the centerpiece is just one paragraph out of a 20-page paper that's 10 points. And even all the figures is just part of it. So not all the equations are here and everything, but in general, it's like I was telling you guys further. Every mass has this energy shell around it, which is basically a quantum energy field. If you can operate on the mass to cause that to be asymmetric, it will accelerate. And this is actually what happens with gravity. The gravitation, the quantum fields between a large object and a small object change the quantum field around it and causes this energy shell to get asymmetric and causes gravity.
This is related to the Casimir effect, right?
It's related because it's quantum energy that behaves like a Casimir cavity. You can have a Casimir cavity between two boundaries. So basically, you have the boundary of the surface of an object, and then some boundary that you just selected away from that object.
There's a laser if you want to point.
I guess I'm fine. But
is that also an analogy for momentum, for acceleration?
yeah, in this model, the energy shells carry the momentum, and it's a lot like this Newton's cradle here, where you have in this state you have the quantum energy on both sides are equal, so it doesn't move. When you move one, you're changing the shells asymmetrically while it's moving, and then when you stop it, it goes back to being symmetric. But then when you drop it, it goes asymmetric again with the larger asymmetry forward. So when it hits this other one, the quantum energy is going through these, the last one, and since its shell is being changed asymmetry, it accelerates.
Wow.
And it's these energy shells carrying the momentum, not the mass. But the thing about it is, the model looks identical to the Alcubierre warp drive. So the objects that move at any speed at all create a warp field, and you don't have to.
And that warp field then becomes their new local space-time, and that's why they continue on with their momentum.
In this model, the quantum energy field is actually space-time. It's no different between the quantum energy field is no different than space-time. Warp the quantum energy field, you warp with space-time. And you don't have to have exotic energy because it already exists on ground mass energy. It's in these energy.
So what kind of energy can we use to alter the quantum energy field?
Well, the interesting thing is that a mass has two quantum fields in it, a quantum mechanical field and a quantum energy field. The quantum energy field is the same as what's outside. And the quantum mechanical field is like the mass itself oscillates, like electrons and stuff. So you could operate on the electrons in here in a given matter because the external field become asymmetric and accelerate. So you really can turn this into an EM acceleration by manipulating this, throw an electron in here or whatever, so this fits within almost anything that accelerates will fit in this model.
Wow. How long were you developing this for?
Since about 2005. It's actually based upon the Canadian cosmology model. I had a particle physics professor who worked with us, Dr. Raymond Lewis, who gave me the Canadian cosmology paper that came out like in 2004. And he said, "Hey, look this, what do you think about it?" I looked at it and said, "Well, this is a new acceleration model. I mean, a new gravity model. There's a gravity model, gravity acceleration, and there should be an acceleration counterpart." And so it took me till 2009 to understand the paper and write a paper into an acceleration model. But basically, this equation here, I want differently. Read the paper. This is the thin shell thickness in the Canadian acceleration model. And I've shown my paper that rather than the complicated equation they have, you can write it this way, which is just depending on the density of the mass that you're operating on. So it's an acceleration equivalent to Canadian cosmology.
Wow. Why aren't you one of the presenters? Like that? This is
They
what.
actually rejected my paper, and then about 3 or 4 weeks ago, they said, "Oh, we'll let you do a poster."
What's up with that? I mean, I saw some presentations here that had nothing to do with interstellar travel. I think this is a lot more related. Like,
They don't like theory very well at this conference.
well, I saw lots of theory, and I saw databases about theory that you can't even access. An entire career based
I'm
on
not
that.
going to argue online. Talk to the people who run it.
Okay.
I've had problems with these people before trying to because they think this is too thorough. And I think it's well, actually, until I finished the model, I actually finished this model late last year, and now that it's finished, I don't think it's theoretically finished. It's done. And what's interesting about it is that under the model, if you this is the gravitational equation that I came up with. So if you put the Earth's gravitation here at 9.81 meters per second, but the Earth's radius here, and you can calculate this energy, this quantum energy that's here. And the quantum energy is related by this equation to a given mass. So what it turned out was this mass is equivalent to the electron mass, but this is really an average mass. This is really an average energy. But this is a new gravitational equation, and this will give you the gravitational.
How does that relate to the gravitational constant equation? Oh, it's part of it. Okay.
But this mass will change with the radius as you move away from it. So this is really energy, but if you just pick a radius above the Earth, then from say my hand to the floor, there's a given amount of different energies in that, and those energies are quantized. So the energies are quantized, and I haven't done it yet. But if you can determine what the minimum energy is here, then you can come up with a gravity to radius ratio, and if you can relate that to a mass, you can come up with quantized gravitational mass.
Okay. Really cool. Thank you very much. Okay, I hope everyone was able to hear that. It is a little loud in here. There's a lot of presenters, so let's go see who else is willing to talk to us right now. Okay. What's going on over here? Classical and quantum computing algorithms designed for hypersonic propulsion computation fluid dynamics. He seems a little busy. Let's move on. We're going to take pictures of all this. There's a lot going on here in this room. It's actually a pretty crowded room right now. And there's a lot of posters going on here.
Mark, I think this is absolutely amazing. I think this is amazing.
It's like the preview session for it. Hey, we're live right now. You want to give your spiel? We're live right now on APEC. Okay, just grab that.
All right.
Put it in close because it's loud in here. Close your mouth.
Okay. So hi.
Close your mouth.
That mouth?
Yeah.
Okay. Thanks. Okay. So we're describing our poster presentation here. Kreutz comets, which are the fastest moving objects we've observed in the solar system to date. They're objects that travel towards the sun from a source outside of the solar system that nearly intersects the sun's surface. They're called some of them are called sun divers and other sun skirters, and they result in an ultimate terminal velocity of 600 kilometers per second. And this of course gives us a lot of interest from people at the Interstellar Research Group, because we are looking for means of getting objects, particularly spaceships, up to a high speed relative to the speed of light. 600 kilometers per second is 0.2% of the speed of light. And at that speed, if it were maintained, would cross the orbits of between Earth and Mars in about a week. So that's obviously a highly desirable speed that would enable quick travel through the solar system. Now, these are natural objects which have only been discovered since 1994 when the SOHO Observatory went into action. And that's what this is over here. This is a colorized picture from SOHO showing objects coming in towards the sun. So it's circling. But if you look up SOHO, you'll see these little bright spots moving towards the sun, and many of them move past the sun and out again. So there's an obvious process that's going on here. We ask the question, how does material get transferred normally in the solar system and in the universe? Is it by carrier on neutral objects like rocks and other kinds of non-charged matter like asteroids, or is there an intermediate state of charge that allows these things to travel under some other mechanism, which we claim it's very similar to electrical forces that we study on Earth. So we claim that there is a voltage potential between an outer surface, such as the edge of the heliosphere, and the inner core of it, which is the sun. So there's a charge differential that these objects move along, which enables their high speed. So we want to study how these objects develop the voltage, how they develop the capacity to travel in this manner. And so we also ask the question, is this a phenomenon that has been observed before in history? We don't claim new physics. We claim that it could be a lost science. So here, maybe Holger would like to come in here and describe the temple at Dendera. This
Dendera?
Yeah.
You have to handle the microphone. That is also interesting here because this is the old map from the 18th century. It's a map of the trade winds in the Atlantic Ocean, which are the base of making transcontinental.
Oh, and the audio is a little faint.
And the first publication in the book of this tracing map was made by Halley, the famous discoverer or the economist of the Halley's Comet. And it was one reason I added here to the post that it was a special comet group here.
Halley, in other words, do an analogy to the ocean current on the comet crowd. We're expanding on that analogy. And we're claiming there's an analogy between the ocean currents and the currents that we're seeing in outer space, which carry objects into and out of the sun. And the specific mechanism is charge. So, charge is electromagnetic energy is 10 to 29 times more powerful than gravity. Gravity is kind of the old age of planetary formation, whereas plasma processes are the young age of planetary and stellar formations. The idea is also expanded in the so-called electric universe concept developed by Christian Birkeland in Norway and Hans Alfvén in Norway, who received the Nobel Prize in 1970 for these concepts. It's just in U.S. science it has been broadly accepted because the conventional understanding is there's no charge separation. Even though we see ionized matter, the assumption has always been that the electrons that escape from the atoms quickly return to the atoms, and so there's no net charge. But now we know, and Birkeland and Alfvén and Bruce and others pretty much showed that there is charge separation of back and forth flow. So you have cations, which are positive ions, flowing from the sun and accelerated away from the sun, and you have electrons going back towards the sun that are negatively charged and attracted to the positively charged solar chromosphere. In other words, there's parts of the solar surface that are charged as such. So we see charge separation as a means of motivating the spacecraft, if you will, to travel from A to B along certain channels, not isotropically like gravity does, because we have ships, we have rocket ships, so we want to fly in any direction. But as we know in science fiction, that there are flux tubes. There are, there's the warp. Warp takes place through a tube of a kind, and that's what we found at the sun. We found that the comets travel along these tubes, along these charged tubes, and we hope to demonstrate that the charge is what explains the high speed. Now, we're not claiming.
Are those tubes like the magnetic field lines of the sun that the
magnetic field lines help create the tubes? They intersect in such a way that they form the flux tube in such a way because of the way that they interact with the electric charges. Electric charges cannot be detected remotely. You have to have a special probe called a Langmuir probe to detect these to detect the motion of charged particles. You can see their magnetic fields, but you can't detect the charged particles themselves. Except that a Rosetta mission did have a Langmuir probe. So a Langmuir probe consists of two antennas, if you will, differentially charged, so they can see a particle moving between the two. And then then you can get some idea of the mass and charge of the particles.
Did we learn anything from the recent solar mission? The Parker mission.
Yes, the Parker. We've described what we now see as the Parker spiral. There's a spiral of charged particles that come out of the sun and swirl around towards the outer solar system. And that is another idea.
Is it with the rotation of the sun, or is it?
Yeah, the sun drags along the Parker spiral. So
that's about, for those who don't know, every 30 days it rotates.
Yeah, it's about 20. Yeah,
that's about the rotation of the moon.
Yeah. Okay. And so the charged particles come out of the sun at different rates according to the latitude of the sun.
Oh, right. Yeah, because the sun is basically a ball of gas, so it doesn't all rotate at the same speed.
Yeah, but we're moving from the idea of a sun as a ball of gas with a little bit of charge on it to a lot of plasma with a little bit of neutral matter coming away from it. So the solar wind consists of both neutral matter and charged matter. We're flipping the model from the wind carrying around the charge to the charge motivating and carrying along the neutral particles.
Oh, wow.
So that's how we see this as developing into a concept of interstellar travel without any notion right now if that amounts to a warp type speed situation. But even today, Jeff Grayson demonstrated if you have what he called pelletized fusion drive, where you lay out a sequence of pellets and you go downwind or upwind on those pellets. You grab onto those pellets and they transfer kinetic energy to you. So we see these comets as a potential stream of pellets that have already been laid out naturally. And then you could accelerate a spacecraft along these up to 20% of the speed of light, at least according to his computations, by this method.
And this is using standard rocket physics right now, right?
Right. There's no new physics here. There's just neglected physics.
Okay, or neglected keyhole into a possible way to get to the outer planets and.
Right. Yeah. So that's the idea. I mean,
can you see a manned mission using this technology, or is it solely for?
So that's what we're proposing here. We're proposing an initial experiment with a test probe that we can send into these flux tubes and see if we can put a charge on the test object and see if we can accelerate it. Put a charge on a neutral object and accelerate it. In fact, in the Star Trek universe, in Star Trek Enterprise, the prequel to the whole Star Trek series, the warp drive is the Captain Archer, played by Scott Bakula, saying, "Charge the deck plates."
Mm-hmm. People were mentioning in the conference, we didn't even get your name yet.
Oh, I'm Bill Gardner.
Bill Gardner, and
I'm an analytical chemist, and this is my colleague,
Holger Eisenberg.
What's your name?
Holger Eisenberg, and I'm a co-author here. We're also what do you do for a living generally?
Holger Eisenberg, wonderful.
I'm working at a software company in Silicon Valley.
Okay.
Yeah, and again, we will put them. we'll give them a mention on the APEC conference.
Wow. You and Brenda will probably have something to talk about.
So yeah, we're very into finding out what's in water and other kind of materials.
Okay. Do you have a website or anything that we can find you or learn more about this?
The website search on Facebook for Analytech on Facebook.
Analytech. Okay.
Yeah, that's my company name.
And is that your email address?
Yeah, that's the email address there, analytech1981@gmail.com. I also conduct a contest for the National Space Society, which is the problems of spaceflight, dealing with problems of spaceflight, which include exposure to ionizing radiation and microgravity. And so we've had 2 years in a row we've awarded prizes to students and citizen scientists who've demonstrated some knowledge about the issues of spaceflight and how to deal with it, improved nutrition, intermittent fasting, and lifestyle changes.
Okay, very cool. We love your presentation. Thank you very much for this. Welcome to APEC.
Okay.
We'll give you a pat soon. Okay, let's continue on. Co. Okay. So we're just coming around the corner over here. Let's see what other presentations we have. Doesn't look like everyone has arrived yet. A.A. Jackson, PhD. I'm not really sure who this is. It looks like we're talking about ramjets over here. Rocket to mass ratio problems. Yeah, this is just a little bit out there. It's changing from rockets, but not really alternative propulsion in the truest sense. Here we have an interstellar university concept. Is this your presentation? Hey, Steve, do you want to do
alternative propulsion engineering conference, and that's going on now.
You're live on it right now.
Oh,
why don't you just tell us what this is about?
Sure. Are you part of the conference?
Yes, yeah, we're part of the conference.
Awesome. Well, I'm here representing Kansas as well as my own astronautical astrophysical initiatives, projects. But the idea of an interstellar university arose from observing the rise of the interstellar community pretty much this century, and it's Mark and Brenda. And here it shows you just in the last, say, 10 or 20 years, the various organizations, including this one here, which started as TBIW and is now the Interstellar Research Group. Well, what was the significance of this, of the rise of the interstellar community? And all these institutes already exist, and what a next step up might be something even larger, grander, like a university. So the idea arose from the reality of this 21st century phenomenon, pretty far out. And that coupled with my 50-year interest in Kansas, first, as I mentioned, from my background in American history, noting that it's thread in the middle, which is an attribute in itself. And then when I found that the state motto was ad astra per astra on the seal, this was almost 50 years ago. Kansas became my adopted state. I live and work in Hawaii and California, originally from the East Coast, so that was another person. Kansas was in the middle, to stop rather than fly over back and forth. But it's really very interesting, again, from both an American history point of view and an interstellar point of view.
So what would we be learning at the Interstellar University?
Well, good question. Through this initiative the last couple of years, sure. In the state, we've met a number of, in fact, because of this initiative a few years ago, we formed a couple of groups based on the state motto of At Kansas Newsletter, Holding Kansas Day, Kansas Foundation, Kansas Foundation. The next step was to explore interstellar possibilities, which is really a direct equivalent of that asteroid. Right? And we engaged with this community, participated in an earlier one of these TVIW Interstellar Symposiums, and invited TVIW to hold their
TVIW is what?
TVIW.
That's the precursor for the interstellar research,
correct.
Which is where we're at right now.
Exactly. And we invited TVIW to join to hold their 6th Interstellar Symposium in the Addis state of Kansas. And that was done 2 years ago, November 2019, in Wichita. And out of that, a Wichita professor proposed just a few months ago Interstellar 101.
Look at that.
Brenda, you might catch this.
Celestial mechanics, mitigation habitats, radiation, microgravity. Where's anti-gravity on there?
This is just a provisional tentative proposal, and fair enough.
Loving it, yeah.
Because you probably heard some of the presentations on anti-gravity. So where you have gravity, of course, you'll have anti-gravity.
I mean, that's probably how we're going to get there. To the start. So,
well,
people need to learn about it. Different types of propulsion. We got to move past the rocket age and into the true space age.
No, exactly into the next phase of it. And I think there was a question asked of the first speaker. Do you remember Mark Millis this morning?
Yes,
did you ask him?
I was the one who asked that question.
Good question.
Have you developed any actual technology? What was his answer? Hardware.
Hardware. And the answer is like what? They're working on it?
No, the answer was no.
No. I thought the question that you're referring to was the Mark Millis, when humans will achieve interstellar travel.
Oh.
Do you remember that? That
was probably one of the earlier questions. Yeah.
Yeah. And you said decades, maybe 50, 100, maybe 200 years.
Oh, I think it happened 50 years ago.
Well,
that's another question.
That's a fair consideration, I suppose, in some ways. Jim Benford looking for artifacts. I guess that's a new phase of SETI. Is looking for techno-signatures for artifacts.
What about the pyramids? Maybe the pyramids are artifacts.
Well,
we know the ancient Egyptians painted them, but that's all we know.
That's something that I haven't dug into as deep as perhaps I would like or am interested in to we've heard the references repeatedly to the placement of the pyramids are reflecting what the stars on the Orion belt.
Yeah, we've seen that actually in a couple pyramid schemes. But let's keep it back to what you have going on over here.
Yeah.
Is any university actually open to this idea, to the curriculum?
I was mentioning, Mark, Paul State University, where there was supposed to be a professor here at NIAC,
Unfortunately, NIAC didn't come.
Well, it is unfortunate, these times in government, public institutions. So this is a proposal that has already attracted the support of 4 or 5 professors at this one university, Wichita State University, which was a co-host, like I've been co-host of today's event. Wichita State University co-hosted the Interstellar Symposium in 2019. And the idea of this proposed Interstellar 101 is that this semester, 1 week presentations through a semester would occur rotationally amongst the universities of the state universities. So that will just, the exposure, access to interstellar fusion. But I think it's not just a Kansas matter, it's a national and global matter. And nationally, this is really an innovation. You're maybe one of the first persons that I have to practice this explanation of. Besides that relatively providential state motto, which didn't come in 1861 from any precocious Trekkie or anything. Again, I have a background in American history, and that was the day that Kansas joined the Union of USA.
So maybe they were talking about a star on the flag and not actually stars.
Well,
in
they
the
were
sky.
talking about the stars on the flag, and they became the 34th star on the American constellation that day. But it was right at the beginning of the Civil War, and Kansas had been pulled, north and south, freeing the slaves, and they joined right after the hostilities began as a free state, and hence the state motto for the stars in the flag through difficulties. But of course, what do the stars in the flag represent? What we're after anyhow.
Right.
It's pretty amazing that USA, that we've got 50-star flag. So that's the second asset I think that's unique besides this motto, because it means that what they say, the university system here in Arizona or in Colorado is much more robust than what my friends in Kansas do that, but it's more substantive. The Arizona universities regarding interstellar matters, and the same thing Colorado, much less California or Texas. But because it's in the center, it can be aware and incorporate all the assets in these interstellar rich states into its curriculum or understanding, and the same with the East Coast. It's in the center. It's equidistant, which is a unique advantage that no other city has. So those are, and then Wichita is. There are more airplanes produced in Wichita than any other city in the world.
Oh, really?
Yeah.
I think property is pretty cheap down there too.
Yeah. Well, what about Arizona? I'm not sure about that.
We're seeing that. You got to see.
So tell me about your work here.
We're doing APEC, which is the Alternative Propulsion Engineering Conference. We're actually live right now with about 50 people on the Zoom call and several hundred watching on YouTube, and we're checking out IRG for any similarities and anything that we can work with you guys on.
Alternative Propulsion
Engineering Conference, APEC.
And I saw the APEC and I remember what it was.
Well, this is it right now. You've just been on it. Steve Dirsch, where can we get your information? How can people reach out to you?
Sure. News at spaceagepub.com will connect your email to us. News at spaceagepub.com. That's our publishing company based in Hawaii and California.
And spacehub.com is your website?
That's our website, and you can link to Ad Astra Kansas Foundation operates a website also, and you can go to the Ad Astra Kansas Foundation website. You can call it up on the internet, and we do have a website there. And there's an alternative engineer there. Is that right? This is an alternative engineer?
Yeah. Yeah, that's what we're looking at.
Tell me about the design and innovation. It sounds appropriate for this conference.
Yeah. It is. We're going to get back to you in a little bit. We just want to continue on to the other presenters. Co, can you grab the laptop? Let's move on. Brenda, I'm hearing that the picture is now backwards.
No, it has been backwards. I just started out just like that.
Oh, okay. Okay, so.
I saw like, oh, my.
Well, Mark, you're doing great. This is amazing.
Okay. Hey, Bart, this is yours, right? Do you want to give us a little presentation?
I can do that, sure.
Just bring it close to your mouth because there is a lot of background noise here. Okay, arts and recreation. Mask off, yeah. Oh, look, and he has a mustache.
Hi, my name is Bert Lee. I'm here talking about arts and recreation on a theoretical city on Mars, but this would also substitute for any city being built off of Earth. The idea is we've got art and we've got recreation on Earth now, and it's part of our daily lives. Our architecture, our painting, our design, everything in our lives, even this carpet is artistic in a way. And I was looking at different ways of looking at it, not just from a quality of life perspective, but also therapeutic. You've got people immigrants who went away for their families, people who got stuck at home with COVID, people on submarines, people in those small space simulators, ISS, prisons, Antarctica, space stations. All these people have been doing art and recreation in their own way as long as we've been doing them. It's just part of what human beings do. It adds meaning to life. It adds quality to life. So the idea was once we have a dedicated civilization out there, people actually living, working in space, building cities, they should be dedicating resources to making sure people can live happily. So I was recommending things like providing stages, providing art galleries, providing sculpture walls, things like that. You know, in good times and bad, fun and joy lives. We need to bring them to beyond, because if we're not, what's the point? That's why the Hawaiian shirt here, things like that. I'm passionate about this because I'm not a scientist, I'm not an engineer, and there's a lot of people that we will be in space who are not scientists and engineers. They're going to want to go too. And they might want to go. We make it more inviting if they have arts and recreation. Like that. Let's go more questions faster.
Yeah, what kind of sports can we play in quarter gravity?
Oh, well, I mean, gymnastics would be hilarious and fun.
Looked it up.
I would love to see Simone Biles doing gymnastics in space and just met with like Earth, lunar gravity or Mars gravity. Just think of how much further they can jump, how much higher they can jump. You need higher ceilings and perhaps different shapes to.
It would probably take years to adapt to new gravity. Yeah.
Arts would be interesting in zero gravity. Low gravity. Zero gravity, you have a whole different set of things. But swimming you could do, tennis, maybe some of the
dining, sex,
yes. Well, that's a recreation. Yes, it could be an art. The idea is all these things can be done. Most of it can be done on Earth and done in space. So we want to make sure that people have the opportunity to do those things. We want to be able to facilitate them as much as possible.
Okay, and what's your name and how can we reach you?
I am Bart Leahy. I can be found on heroictechnicalwriting.com, heroictechwriting.com, sorry. And I'm also the Facebook guy for IRG, so I can be found that way.
Okay, perfect. Thank you very much. Thank you. Okay, you've just been on APEC, the Alternative Propulsion Engineering Conference. Let's move along. Over here, we don't have the speaker, but the poster is up, talking about wormholes, warp drives, and other possible means of interstellar migration by Gonzalo Never, PhD. Hopefully, he'll be around a little bit later. Let's get a nice roll down of this. Solid start to Emerson. Okay, what is the technology behind this exactly? Cables and disconnect. And of course, he talks about the Alcubierre warp drive here. I think we could just get this on a picture, and maybe we'll get back to it later. Let's move on and see if there's any other presenters. Thank you very much. On altpropulsion.com. Okay, we already heard from the comments people. Let's go around this side past this booth and see if we can. Hello there. Can I bother you to do your spiel again? We're live on APEC right now, which is the Alternative Propulsion Engineering Conference. Are you able to hold this or?
Not really. Actually, I'm supposed to go, so I only maybe have like 30 seconds.
Okay, just tell us real fast what's going on.
So this is my poster presentation on using classical and quantum computing to help solve the problem of propulsion and hypersonic propulsion with computational fluid dynamics. And so you've maybe heard of quantum computing being the new up and coming thing. The real interesting thing is being able to apply this technology to solving the Poisson equation and the Navier-Stokes equation. And so that's what this poster is about. And then incorporating photonic elements on the hardware side, and then going through once you do this, how do you set up the equations, how do you set up the boundary conditions, all of the parameters that you would normally do in a classical computing, but do it in a quantum computing regime. So this work is probably some of the first work ever presented in it. In 2018, we presented at the Ecole Institute in Paris that this work and applying the solving the quantum computing application to the partial differential equations of matter. So basically doing fluid dynamic solutions. So it's really interesting, bringing together many forms of physics and then trying to, solve some very difficult problems, which looking at the propulsion system and the fluid output of a jet, of a rocket engine, there's all these vortices that can happen. And these are very, like little windstorms, like what you would see on Jupiter or Saturn. So those are the kind of things that you're looking at? That's the type of things we're looking at, and the chaos. And as we go over a manifold, what are the things that spin off? So like in Formula One, when you have a rear wing on a race car holding it down, you get these turbulent things. It's like that we're looking at.
The little vortices,
and these create.
When the smoke's just right, you can see it like a little tornado.
The humidity is just right. You see them on jet engines and jet planes, And
in rocket engines, it's very well formed. They're like diamonds when it's done right.
And so as, for interstellar travel, it's important to think about how are we going to get to these really high level speeds, but we have to slow down and we have to, come into some atmosphere. So hypersonic is still an important thing, is that transition between we're just taking off from a runway versus we're going into a completely planetary mode of transportation, and then using things like magnetohydrodynamic propulsion, nuclear propulsion. So there's a lot of things that are being drag raced together for propulsion. And so this is talking about the magnetohydrodynamic, and so the electromagnetic. So one of the big things involved with this, of course, is the cooling of things down. So using electromagnetic fields and Hall effects, you can actually, control those hotspots. So like on the F-15, the fastest thing that we've created for man in the development of that, one of the biggest things was the hotspots forming on the fuselage, both on the aerodynamic side as well as the
that would
side.
be something that you guys would be working on.
This is what would be the first things that you would be, from an e-design point of view, most things that you're doing as a designer now is in an e-design form. This is how you would approach that problem.
Yeah, once you stand next to your poster, so we can just get a better idea. Also, what's your name again?
Mark Preston.
Mark Preston. Where can we reach you?
I started two companies 20 years ago called Silicon Arts and Optical Design Labs. There's cards here that my contact is there. But be happy to talk with everybody. We're doing a lot of work internationally, and we've been think house, design house for the last 20 years, a fabulous design house.
I'm definitely going to grab one of those. I see you're taking COVID very seriously.
Well,
two layers of masks and no judgment. So I'm going to grab one of those. And
it's only because we're on a project and we're just trying to keep everything.
I understand. There's regulation and stuff. Okay.
Yeah.
So here is and it's a really nice business card too. This is nice and shiny. Is it made out of silicone?
It's a special material.
Can I take two?
Absolutely.
Thank you so much. These are really nice business cards, by the way.
We worked on everything from some of the most expensive weapon systems of the Navy to Avatar. So we've been both on the media side as well as the high content side.
And I'll tell you this much, for the electromagnetic wave interaction parts, we might be very interested in what you're doing over here.
Absolutely. And you're from?
I'm from Falcon Space, and we're associated with APEC, which is the Alternative Propulsion Engineering Conference, which you are streaming on live right now.
We actually have a laptop connecting and copying your stuff. So I don't know if it's going to all be recorded, but I'll probably be contacting you. So if you have a card, it would be great to get that.
Yeah, let me see if I have a card. I'll come back in a little bit with the cards, okay?
Okay, thank you.
Not a problem. Is this his presentation?
I don't know. It's self-destructive.
No. Okay, let's move on. Okay, it looks like we're missing the rest of the presenters, but let's step out of here for a moment and show what else is going on here. So of course, and the main
Mark, your signal's dropping out.
Stragglers. There's our signals. So maybe we should head back toward the hall. Yeah, it's becoming unstable. So let's go back to the copper room where we started, and we'll hear from everyone else. Hopefully there'll be some stragglers. I saw Sony Light was running around before.
Well, Mark, I think this is amazing. You know, you're like, I'm not sure what this is. You're like a live reporter.
Yeah. So Brenda Stoudemire, she's the videographer over here. She's holding the camera, and her son Ko is actually holding the laptop. That's how we made this happen.
All system checks are go so far.
Yeah,
well,
so
thank you, sir.
Ko is
Thank
actually reading the comments and stuff and telling us when there's a problem. This is how we have this set up right now. And there's these are lapel mics that are hooked up to the camera. No, you were mentioning the comments before. That's what I was telling you. So let's see if there's anything going on at the copper room, which is the hospitality suite as well. We're coming up on dinner time now, so people might be running away for that. Conferences are big food events, of course. So here is the hospitality suite. This is where we set up, and once again, here's our APEC poster. People were checking this out all day, and sure enough, it's empty.
Nobody has come to visit.
I think we could let them take it away from here now. We showed them everything that there is to say.
So far, because like not all the people are here yet.
That's right.
Ah, okay.
You can watch me struggle with the door. Come on in. Okay, Tim, so I think we could send it off to you now.
Yeah, well, no, that was wonderful. Mark, thank you, sir. So I guess the thing I should ask is, what are your thoughts of IRG? What are your thoughts of the conference?
My thoughts of the conference are similar to what David Perez mentioned earlier. That there is back from the mainstream community. We're off that. There is some pushback from the mainstream community. There's sort of this Galileo effect where they don't want to listen to, they don't even want to hear us. and that is slowly changing. It also, I'm also here with another conference, you know, so we're kind of like trying to steal eyes and stuff. So there's a little bit of that going on, but it's definitely very mainstream, uptight. It doesn't have the loose feeling that we have at APEC or that we had at Tesla Tech. So it's a very different vibe from anything I've experienced before. Very mainstream, very dry. Almost, I saw almost no hardware related to the things that they're talking about.
Okay. No, it's interesting to hear that feedback. It does seem a little bit more mainstream, you know, but but I think there's a place for all of these different groups and approaches and all of that. So,
well, the mainstream is really the safe stream. That's where, you know, that's.
Oops. Okay, and everybody, it looks like we just lost. Yes, we just lost Mark. Okay, Mark said his laptop just died. So I think everybody, should we go to open discussion now? I'll give it just a moment and.
Yeah, we can move to open discussion, I guess, if you guys want.
We'll move to open discussion. Okay, Jeremy. I wasn't sure. Yeah, so let's do that. We'll plant the flag. Open discussion time. It'll be.
Mark can always come back on if his laptop comes back up.
Yeah. So Jeremy, what do you think? Is mainstream is the safe stream?
Yeah, Simon in the chat said science advances one funeral at a time. I don't think we have to be quite so dark, but mainstream is safe stream. I tend to agree. We're kind of like fringe. This is a topic that's been considered fringe, and but at least as long as we're using, you know, acceptable physics and we're not, you know, trying to throw out, you know, all of the accepted physics, and we're going off academically accepted methods, then, you know, I can see, you know, why some people might not choose this as a field, but man, like I don't understand why more people aren't into this, you know, like this is the whole reason I wanted to study physics, because I wanted to learn how to do anti-gravity and understand how gravity works and unify the four forces of nature and stuff. But
you know, Jeremy, if I could offer a thought though, and this is, I'm just kind of thinking out loud here, but your channel, you're at like what, 110, 120,000 subscribers, right? And you talk about this stuff all the time. I mean, this is your forte, right? Now, I know it's taking you a long time to build that up, but let's say 110 conservative, 110,000 subscribers. This conference, this Interstellar Conference, maybe, I don't know, a couple hundred at the most, a couple thousand on a wonderful day. So in a strange sort of way, you are the mainstream. You're reaching the mainstream, you know? And so it is kind of strange in a sense.
If only the numbers were bigger, man. I got a lot of my subscribers early on with YouTube because I've just been around for so long. My channel, I started in, I think, 2008. So that's part of the reason I have so many. A lot of them are probably inactive accounts and stuff. But we do reach a big audience. I mean, considering that it is a technical subject matter, and you know, you've reached 3,000 people on a stream like this with you know that you're getting at least some of those people are technical people who can understand this on that level. I found that, you know, whether or not the community is on this level and ready for this yet, you know, like a lot of people have commented that the stuff that we talk about on these discussions is way above the pay grade of UFO Twitter. or some of these other you know, communities and stuff. But it is that are there, those people are more on the fringe, I'd say. So it's all right because they're catching up, and it gives them something to work toward, and also gives, you know, younger people something to, you know, like, oh, there's a whole bunch of curriculum that I can study now. This is, you know, there's actual, you know, papers that I can read, and scientists that I can talk to and get advisement from on my direction in school and stuff. So I've learned a lot from, you know, watching the speakers who've come here, you know, like figuring out which colleges you should be going to for what, and if you want to be you want to get involved in this type of research and this type of stuff professionally. I think that's super important for the next generation that's actually going to build these craft. You know, I look at my kids are still young. When they grow up, are they going to you know, how are we going to get there in a generation? You know, when my kids are graduating high school, how are we going to get from right now to 18, 20 years from now when they're going to college and starting this stuff?
Well, and they'll be bored with rockets by then too, right? I mean, Elon Musk today, that's kind of exciting, but you know, by the time they're going to college, they'll be like, you know, that'll be the same way we look at Apollo. They'll be like, okay, that's it. You know, what have you done since then? So yeah. So it's interesting. You know, there are a lot of other things too. I mean, I think that the mainstream is moving forward, and so stuff like modifying gravity doesn't seem as silly anymore. I mean, you look at like quantum computing, right? I just saw a new story on quantum supremacy like yesterday. They just hit a brand new level. They did in 4.5 hours what a regular computer, like a supercomputer, would take thousands of years to do. You know, and that's real world, right? And that's advanced quantum mechanics. So if stuff like that is already being done in the lab, then how far away is stuff like, you know, warp drives or gravity modification, things like that?
Right. We're approaching this singularity, I would call it, with in terms of the technology, with the material science is now reaching that level where we can, you know, lock on and manipulate the very fabric of space-time. And I don't know. I think it's part of this is, you know, people have talked about disclosure and that there might be people in the government that don't want this stuff to come out. Well, there's lots of people in the government that do want this stuff to come out, and but also albeit safely. And I think that we're doing that a responsible job of, you know, making the scientific community feel the presence of this technology that is coming out, and to prepare humanity. The next step is to prepare like humanity for, you know, the step that's going to take, because we're not, if we have the technology to do warp drives, you know, we need to find ways to use that, not in way, you know, in safe ways, to constructive ways to help save humanity, because this technology is going to empower us to save our species and have absolute freedom, or it could, you know, be absolute enslavement if someone like Kim Jong-un got a hold of this technology. So it's certainly a discussion worth having, but again, the material science is the key part of this, because it's not like even the theoretical stuff that we talk about here is hard for someone like Kim Jong-un even to physically obtain, because he'd have to go through the logistics, and it's going to take a cooperative community effort to build this technology. And I think that's an important part of this, because if it were a low-hanging fruit and it were too easy to replicate or produce, then and anyone could have it, and that would be quite dangerous. And I think in order to achieve this on a global scale, we're going to have to come together globally, and that's why I like the fact that this is an international conference, and it's open to, you know, anyone in the world as long as they speak English.
And if they bring a translator, we'll do other languages too.
Yes, that could happen in the future.
Yeah,
for sure.
Well, I like the fact that our conference is kind of mellow. You know, I think that makes it work.
Mellow is key.
Oh, you're back.
Yeah, I'm back. The computer died literally as I was plugging it in. So it was perfect timing on that end. We are going to have more of the poster presenters coming back. So hopefully in the next half hour or so, I'll charge up my laptop a little bit here. We'll be able to go back out there and grab the last few of them. I see Mark Preston, who was one of our interviews, is now joining the conference.
Yeah. So, and Mark, I was going to say, we're in open discussion now, just so you know. So, and I think things are pretty quiet. Yeah, I like the mellow thing, and I think the fact that you're basically reporting on another conference is truly a breakthrough. And I hope that our audience, like the people watching on YouTube, I hope that they're able to learn more about IRG the same way that they learned about Tesla Tech, right? And
here's something really cool that I wanted to show you. So I actually brought a book on high power microwaves to the conference, thinking if I have any spare time, I'll read up on this and try to learn a little bit more about, the klystron, the setup that I have over there, make sure everything's okay. Turns out the author of this book is one of the presenters. So I went to talk to him, got him to sign it. He doesn't believe in UFOs too. He thinks that they are weather phenomenon. So I gave him a copy of David Alzafon's book, Gravity Control with Present Technology, and told him that we're building weather phenomena that will get us to Mars in a couple minutes. And he actually signed the book for me. And
there you go.
Nice.
Yeah. So that is, us pulling the mainstream toward the technology a little bit. And he's now very interested. He's going to read David Alzafon's book and see how it's connected to high power microwaves. And he never even heard of EPR before. He never heard of electron paramagnetic resonance, which is strange because that's what you use high power microwaves for. And he actually wrote the book on it.
I see Mr. Boyd laughing on camera.
Here, James Benford, and here is his signature, James Benford.
Nice.
And I got the Polaroid.
There you go.
There you go, man.
Had to get the Polaroid of him signing it.
You're pushing the balloon.
We're pushing really hard. Very pushy.
Tell them to also check out PBS Spacetime's latest video on how matter arises from electron spin. That was a really good, really good. It's like it's like Alzaphon in reverse. He like literally lays out like how spin gives rise to matter, and it just like if you do it in reverse, it's Alzaphon. It's like, oh my god, it's coming out to the mainstream. Yes.
Post a link to that, or actually send me a link to that on WhatsApp. That's a video that I really need to watch.
Yeah, it was good. It was like 23 minutes long. Let me find it. PBS.
The average age here is pretty old too. I'm probably one of the youngest people here.
This is it. It's this one right here. I'll post a link to it right in the live chat. And,
we were handing them out.
So now there's that temptation. Now that we know that Mark is willing to travel, there's like, let me see, what conferences could we send Mark to? Just how far can we push this envelope?
Oh yeah, we were handing out little flyers about the conference.
You're organizing. That's what you're doing.
Yeah, we're handing these out. People love them.
But you paid for the conference too, right?
Canvassing.
Yeah, I paid for the conference. It includes, dinner. We met some cool people and scared off Sonny White. And
although in his defense, right? Yeah, I mean he has to do fundraising for his lab and his projects and stuff like that. So I would imagine that he's quite a busy person.
So Mark,
not just that, but what we're doing is really dangerous for him, because if he's not on board and in front of this technology, then he's just going to get run over, and he knows it.
So do they have a bar there?
Oh yeah.
Are most of the people that are there at the bar, or are they like milling around?
No, it's almost 6. Give them about 10 minutes, and they'll be there. Yeah, that's how these things work.
They're at the bar. Yeah, actually went out partying with Glenn Robertson last night.
Yeah,
I bet that was fun.
So Glenn was tagging along with this college reunion people that were all drunk off their ass, and we tagged along with him, and it was just a bunch of fun.
So now, how about the?
Glenn bought me a drink.
Are many women there?
Not many women. No, there aren't many women. And there aren't many women over. I mean, APEC is doing okay comparatively to the scientific community, but we have Noel and Lauren. We have also had what was her name from?
Oh yeah, yeah, and she's wonderful too.
And
yeah,
Brenda.
Brenda was the camera woman.
Yeah,
but
and then we're hoping to have Chantel Butler on, and then again Chantel is, and Mark knows more about this than I do, right? So her company Geometric Space, I think that they actively want to just let people know that they are willing to take payloads up. And so she wanted to come on and talk about that. And what I suggested was, I said, look, if you want to come on, tell us more about what you guys are doing. So she hasn't said no, but she had a conference this weekend.
I think people are afraid of the stigma.
No, they're afraid of Mark's hair. They're afraid of Mark's hair.
Oh yeah, well that could be too. But
I'm just teasing.
And Mark, didn't you say that most of the people were, say, over 40 that were there?
Yeah, I would say most.
Would you say they're retired? They're retired.
Yeah, most of them are retired. Yeah, most of the people are retired.
So there would be a lot. So as you get to the older crowd, the stigma is greater, wouldn't you think?
Yeah.
Yes, because they're set in their ways.
Well, plus they've been beaten down for 20, 30 years. If they even said anything, they'd be in the unemployment line. So it's kind of like the stigma is slowly going away, but you got to keep pushing
every old scientist that passes away is where the stigma goes. Because
well, you got to keep pushing the envelope there. That's the thing. I think that's a great idea.
There's some people that will never change their mind, but you can change their kid's mind.
What's that? Say it again.
Some people will never change their mind, but you can only hope to change their kid's mind.
Well, you can change their mind if you can show them something. If you can show them some.
Have you heard of
it'll
it was a
take
UFO
them a while to
incident?
accept it.
There was a UFO incident on a commercial flight, and it happened for quite a while, and all the passengers were looking out the window and pointing and screaming, whatever. And there was this psychiatrist there that refused to look outside the window, saying he doesn't believe in UFOs. That's a psychiatrist.
Well, maybe he should have been a physicist. He would have been,
might as well could.
He would have been more open.
It would have been more appropriate, right?
Yeah.
I'm gonna.
Oops. Oh, and that was Mark's. Oh, Mark, you're muted. Okay. Oh yeah, because I think you were getting background noise.
Oh, I said I'm gonna go check out what's happening out there. So I'll be.
Oh, okay.
Nice.
Yeah, I don't know. Well, it is interesting. I don't know, Michael. I think what you're saying is right. If it's a crowd with older folks, you're more likely to have stigma. That people are more indoctrinated, right? And that kind of things are changing. Though we live in a world with 16 genders now. If we can live in a world with 16 genders, then we could talk about warp drives in public.
Well, we already always had the 16 genders. We just now figuring it out. That's all. It's like the culture is lagging behind the technology. There's a hysteresis that we're dealing with. But if we keep pushing, eventually it'll go over, right? And it's with the government basically coming a little bit out of the closet about what they know. I think that's making it more acceptable. It's more, it's reducing the stigma.
Yeah.
Yeah.
I think that's true. And again, from a pure science perspective, I think a lot of the ideas that drive these technologies, right, like Alcubierre and stuff. I mean, Alcubierre is taken for granted. It's not. I would say that most traditional scientists don't consider it feasible, but I think that they look at the physics and say, okay, this is in general how it's done. It's not considered, out there too far. It's like, if you're going to do it, this is how you can do it. We just don't think it's possible. Well, so over time that changes, right? From you know, I mean, it's kind of like fusion research, right? Like, you know, there's no way it can be done, and then maybe we can do it, and then hey, we're getting a little bit of results, and you know.
So now I'm curious. I had a couple of. Is Ron still on? Ron Kita?
Ron is. Let me see. I'll click ask to unmute. And looks like Brenda just joined again. Brenda,
Hello?
if you can hear me.
Yeah. Hello?
Oh, there's Ron. Okay, you're not Brenda,
Hey,
but I was going
Ron.
to say
Oh,
thank you
sorry.
to Brenda
Oh,
for the.
I got it. Never mind.
No. Yeah, Michael have asked about you. I was just going to say thank you to
I
Brenda
sent you.
for taping.
I sent you a chat message about. You sent a video out a couple of days ago about gravity shielding, where you had some experimental results, and I wanted to check with you if it would be okay if I share that.
Yeah, okay. I want to mention, I'm unmuted. In terms of what it is, I've gone beyond those results.
Oh.
Only reason why I published it is because it was going downhill. And with making electrets, there's no guarantee. There's a lot of the chemicals I have to make myself because chemical suppliers do not want to sell me. I got to sell my firstborn son to get a chemical. And so I make the damn things myself. But yeah, if you want to give that, what I did is I put stuff on, I put it on LinkedIn, and there's another one. Did you see the one on unipolar electrets?
I have the one I have is where it shows basically you have the can with the electret, and then you flip it over and there's a weight loss, and that's what I wanted to share.
Okay. What I wanted to say is the only reason why I made that because it was going away, and I said if I wait 2 more days, I may not get it back for months, and I put it up quickly, and I didn't want to share it because the results. But I have since. Hold on, can you wait? If you wait on it, I can show you something on the screen in a second. Who's next?
Yeah. If you got something else that you'd like to show, that it'd be fine.
You just wait a few seconds. Just hang on here.
Okay. So, and then there was this other thing I wanted to talk about, to deal with basically virtual electron pairing. And there was a couple of the speakers were talking about creating antiparticles from photons, stuff like that. And let's wait and see what's up with
Carl said Cooper pairs. Carl?
Cooper? No, it's not Cooper pairs, but
I'll drag Carl in. He's being quiet.
No, I love the idea of virtual subatomic particles, and it's a great idea. I mean, I just assumed that's what you're talking about because of type 2 superconductors, but that was what I thought you were indicating.
Oh.
So yeah, what I'm talking about is, hold on, can you guys see my screen?
No, you have to finish screen sharing. You started it, but you haven't finished. There we go. Oh, and there's Ron. there's Ron's as big as life there.
Yeah. So here's this thing I wanted to show you. Okay, it's talking about why pair production cannot occur in the vacuum, empty space. And this is like I've advanced it to the parts where basically he's talking about what the paradox is.
Down to basically conservation laws. So if I look at the conservation laws associated with this process, specifically the conservation of energy and the conservation of momentum, as I'll show you, we cannot conserve energy and momentum simultaneously for this process if
something happened. Oh, it's just locking up. It'll come back.
If there is no external material or an atom or a nucleus present nearby. So let me show you how we can come to that conclusion. So let's look at the conservation laws of energy and momentum for this particular case. So you have a gamma photon, which is extremely high energetic. energy of this gamma photon is greater than this quantity. Why am I drawing the diagram in this particular manner is that the gamma photon, if it is moving in this direction, has some initial linear momentum in this direction. All right. The gamma photon does not have momentum associated in this particular perpendicular direction. So the particle-antiparticle should also have a similar kind of momentum. So therefore, the particle-antiparticle will move in this direction. So the combined linear momentum is also facing thiswards, and also the linear momentum is in this axis should be 0. And by imposing that, I can say that the angle at which the particle-antiparticle is created, let's suppose it is theta, is also equal. Why? Because the linear momentum in this perpendicular direction initially was 0. So the linear momentum in this perpendicular direction after the pair production should also be 0. So they should cancel each other out. Since they have same mass, they should be ejected at same angles to cancel out the linear momentum in this particular direction. The only linear momentum existing will be in this particular direction. So let's suppose the linear momentum of the electron is given by P and the linear momentum of the positron is given by P here. So the electron will have a linear momentum in this direction, which is given by P.
Oh, countdown to ads.
Are you? You look vaguely familiar.
Cos theta, yes. And the positron will also have a linear momentum in this particular direction, which is also given by P cos theta. Yes. So now we can look at the conservation laws of energy and momentum. First, let's look at the conservation law of energy. So if I write down the conservation law of energy, then I can say that the total amount of energy of the gamma photon, which is basically h nu, is basically equal to the total amount of energy of the electron and the positron, which is nothing but this particular equation. So the gamma photon leads to the creation of an electron-positron pair. So the relativistic mass of the electron-positron pair will come out of m naught c square. This is the first equation. This has to hold true for conservation of energy to hold true. Now let's look at the conservation of momentum. So the light photon has a momentum associated with it. Yes, the momentum of the light photon is nothing but its energy divided by the speed of light, which is E upon C. Yes, or this is equal to h nu upon C. So the momentum of the light photon is its energy upon C, or h nu upon C, and the momentum of the light photon in this direction is basically equal to the momentum of the electron and the positron, which is twice of 2p cos theta. Fine till now. What is p? P is nothing but the momentum of the particle here. So this is nothing but mass times its velocity. Now, as I already said, this mass is the relativistic mass. So we can write this as gamma m naught v. So this can be written as 2m 2 gamma m naught v cos theta, or h nu is equal to 2 gamma m naught c v cos theta, or 2 gamma m naught c square v upon c cos theta. Now let's look at this particular term here. Here I have basically multiplied c in the denominator and the numerator. Why? You'll understand it in a second. So v upon c, what is v upon c? V is the velocity of the electron and the positron. C is the velocity of light. So since the particles cannot move beyond the speed of light, so v upon c is always going to be less than 1. Also, cos theta can never have values greater than 1. Cos theta will also have values less than equal to 1. So in this particular term, which contains so many individual quantities, this quantity is less than 1. This quantity is also less than equal to 1. So I can say that h nu is basically less than 2 gamma m naught c square. Yeah, so 2 gamma m naught c square is being multiplied by two quantities whose values is always less than 1. So therefore, this equation I can say that this is less than 2 gamma m naught c square. So which is my second equation. As you can see, you can make a comparison between equation number 1 and equation number 2. In equation number 1, you have h nu is equal to 2 gamma m naught c square, and in equation number 2, you have h nu is less than 2 gamma m naught c square. This is a contradiction, no?
Good morning, team.
Oh, and it's a cliffhanger. It's a cliffhanger moment.
Conservation of energy tells us that these two quantities are equal, but conservation of momentum tells us that this quantity has to be less than this quantity. So this is a contradiction here. It cannot be true because we know that both conservation of energy and conservation of momentum hold true in a given physical process. If these quantities are not conserved, then that kind of physical process is not possible. We end up getting a contradiction when we try to conserve both momentum and energy at the same time, which simply means that this kind of a process is not possible. This kind of a process does not conserve energy and momentum at the same time. So this kind of a process does not happen. The light photon does not become an electron and a positron because we cannot conserve momentum and energy simultaneously. The only way this kind of a process is possible is if there was some other physical object which could take some of the recoil of the initial light photon and make this equation equal. This can only happen if, let's suppose, there was some kind of a nucleus in its near vicinity. If there is a material medium in which this light was penetrating and there are lots of atoms, then this light photon in the presence of some kind of an atomic nucleus can lead to a creation of electron and a positron, because now the nucleus can experience some of the recoil of this particular process and balance this particular equation. As you can see here, this quantity is less than this. The only way I can prevent this kind of a contradiction is if in this term there was some other momentum, let's suppose P1 associated with it, and this P1 is nothing but the momentum transferred to some kind of a nearby atomic nucleus. So pair production can only happen in the presence of an external object like an atomic nucleus, which can experience some of the recoil in this particular process to conserve energy and momentum at the same time. So one important distinction between annihilation and pair creation is that annihilation can happen anywhere. If you look at the kinematics of this equation, energy and momentum is conserved in the pair annihilation case, but for pair production, you need an external atomic nucleus. So that is the answer to why a pair production cannot occur in empty space, because we cannot conserve energy and momentum at the same time. Now, I just want to make another point that this is also one of the most common ways in how extremely high energetic radiation interacts with matter. So you know about different kinds of phenomena that takes place when radiation interacts with matter. For example, for low energetic radiation can lead to photoelectric effect. Even lower energetic radiation can lead to some kind of a Rayleigh scattering. For medium energetic radiation can lead to Compton effect. For extremely high energetic radiation, which has sufficient energy, which is much greater than this particular value, when those kind of radiation interact with matter, then they lead to this kind of a pair production process. So that's it for today.
Okay, let me go to Carl real quick. Carl Rose. Carl, there you go.
Oh, that's great. Go. So,
you know, in open discussion, you don't have to raise your hand, man. Just jump in.
Oh, that's nice. Hey, Mike, I'm a huge fan. Every time you have something to say, I just want to shut up and listen. But no, it's so great because that's exactly the point of a Cooper's pair. So in a type 2 superconductor, you've got that really tiny channel, and you've got basically two negative electrons that are entangled because they're so close. And what happens is that in between them is a virtual particle, a Cooper's pair. And that is a virtual positively charged particle, a nucleus, a proton. It's a virtual proton. And that's what gets quantum locked. And to go back to what Todd was talking about with the gravity flyer, and it looked like it was like magnetically locked in place. That's what I think is happening. I think that it's like a type 2 superconductor, and it's quantum locked onto virtual particles. That's what it seems like, the analogy in my mind.
My reason for showing this is that my hypothesis is that there is no virtual pairs in the vacuum, and the vacuum energy isn't a result of virtual pairs, but as a result of proton flux, because the whole universe is in a proton flux, and if you're within the Oort shield of the sun, the proton flux is different than it is outside the Oort shield. And cosmic rays are essentially protons that are relativistic protons that hit the planet's atmosphere and mainly convert into muons, which are like, what is it, 209 times heavier than an electron?
So it's not a virtual particle. It's like a muon or something else that's taken on the guise of, like, it's filling in the void of the positive charge that needs to be there.
There is no empty space.
Yeah, I would go with that. Well, and then don't forget about neutrinos, right?
There's neutrinos too, but I mean, it's like if you take you can't have a free neutron. When you have a free neutron, it turns into a proton and an electron and a neutrino. So basically, protons are where the mass of matter comes from, not electrons. And so, and in the semiconductor, they actually they call protons holes, and they're mobile. But the thing is, there's a what I call anti-symmetric effect to mass. An electron is really light compared to a proton. It's like 1/1640th of the mass of a proton. So, and neutrons are just protons, essentially in a different form, a neutral proton. And so basically all the gravitational field's coming from protons, not electrons. But everybody's focused on electrons. So now the reason I wanted Ron to show his thing though is because what Ron is doing, he's using a chiral proton, essentially, a proton that has a certain special speed.
Well, and that brings us back to Ron, who now has safety glasses, which terrifies me. But
well, these materials are a tad nasty, and by being charged, these are the only material I had worse was a push-pull molecule called hold it, oh god, diamino. It was a push-pull molecule across the benzene ring. It was amino. Oh God, 2-methyl-4-nitroaniline. Okay, it's 2-methyl-4-nitroaniline on a benzene ring, a push-pull molecule, and it was not really that toxic, but the slightest bit. I tried dissolving some in alcohol because it was a polar molecule, and I was careful, and the slightest vapor of it caused a lot of eye irritation for about 2 or 3 days, and that was on the border of parts per million, and that was simply a push-pull molecule. This one is simply a chlorobenzene that's charged, and myself, I can tell. The thing is, I have an open end on it, which I do not like at all. But the best thing is to see the YouTube. I'll send it to Tim. This thing started. The whole thing is you can charge something by simply pouring it into a cavity. It's called triboelectric charging. There's a patent by me, 7340919. It has to do with the tribo charging of refrigerants, and it was popular. Oh God, about maybe 7, 8 years ago, when they were trying to increase the efficiency of air conditioning. But anyhow, it was very, very, very simple. And in there, I have a triboelectric chart. And I knew when I pour a dielectric into this cavity, I'd get a charge. I also knew by virtue of this material wanting to sublime through the initial charging, it would get more charge. And the thing is, this was never intended to be an electret cavity. It's metal. All my cavities are PVC. So I thought after it cooled down, I gave it like 4 hours to cool down. I put it on the scale, and then I flipped it over. The YouTube, which you saw, shows the difference. I was getting close to 1% weight change, face up versus face down, which is what Rhodes saw. What Rhodes saw with his transducer was 14% weight change, face up versus face down, on a chlorobenzene, chloronaphthalene electret. And so the only reason why I made the YouTube is because this was approaching 1%. I was hoping to break a 1% barrier, and then what happened is it started to decay. And I thought it's going to take a while to make this another one of these. And so I went and recorded it on YouTube. And I figured I'll just put it up there and not get too involved. And then what I did is I figured, well, I have enough residual material to make one twice the size. And these are binary electrets. There's a two-part component. In the patent US 890143. The binary electrets have a polar component, and they also have a non-polar component. The only trouble is, a lot of times your polar component is a chlorinated benzene, which is far heavier than your non-polar matrix. And the trouble with this is, I tell people these are very, very diode-like, because you're trapping electrons in interstitial lattice works. And so what happened is, this one was an ugly one because it did not want to form something homogeneous. And well, same with the other one. It didn't want to form anything homogeneous. And I had to keep stirring it to keep it from separating and bring it to a close temperature, and then allow it to solidify enough, and then let it settle down. And so normally this one was a 2-3 ratio, a 2/3, 1/3. So I always try to get 2 experiments out of 1 run. So I made this one 50-50, and there was virtually no effect. The effect was minimal. So then I dropped it back to 2/3, and this one went over 1%. And I think by changing the ratios, and this is without DC charging. This is just so. Anyways, that's where I am. So it's if you want to mention more about it, Mike, you can. But also, what came out a few days earlier or weeks earlier, I started measuring I have my, by the way, this is my field meter, and these things, you cannot pick up much of a electrostatic charge on these. The charge, I have no idea what this is going to look like when it's under full power. It's possible that by being, when these triboelectrically charged, they're charged under a very clean electrostatic situation as compared when you make something from a voltage source. Because some people would make electrets from batteries. I don't want to have 500 batteries or a large group of batteries. I take my chances with AC powered power sources. But in terms of being a very clean power supply, you can't get a more natural power supply than triboelectric charging. Or I think I could go Van de Graaff, because my friend Boyd Bushman, in his electret patents, he went Van de Graaff. So I may have to use Van de Graaff to get something clean. It's just that this all happened within the past. This one is like 10 days old. The bigger one is maybe 3 days old. And this one is more stable for various reasons. But when I went to 50-50, there was nothing here. I cut back to this, and by virtue of size and I didn't want to make a YouTube until I beat Podkletnov. That was my goal. And it's just when you see things deteriorating, you figure, well, it might be a while till you get back there, or you may never get back there. But what I want to mention, there is when I was monitoring my other electrets, I realized some of my electrets were monopolar. There was no, and then I started researching monopolar electrets. Back in, it's in the YouTube. If you type in YouTube monopolar electret in my name, you'll pull up the monopolar electret. The Sony Corporation, they had a set of earphones and speakers. Sony back in 1976 had the Uni brand. It was a unipolar electret speakers and headphones.
Cool.
And then
they made 6 different variations of that model, and all of them are reported to be incredibly popular. They're quite expensive now and hard to find, and I'm noticing now that a lot of material scientists are buying them just to pull the monopolar electrets out of them.
Yeah. Well, anyhow, I contacted Professor The professor's name is Coeth, C-O-E-T-H. It's a hard name to memorize. He's at the University of Maryland, and he was talking about the intrinsic instability he's making in my US, whatever hell number that is, doesn't matter. I mentioned about radioelectrets, and he made a, he used the word, they used the word monopole or monopolar. And anyhow, this goes back maybe, maybe it's 5 years. I found the paper and his name after this stuff has been on Google all along, but I never envisioned in the YouTube that I made, I said, well, I never envisioned a monopolar electret. I thought it's nonsense. It wasn't until I started taking readings and I started looking at the way things were constructed. I'm saying, well, I have a monopolar electret here, and I'm going to search it out of curiosity, and because you usually get monopole magnets, never found, this and that. And I mentioned it in the YouTube runs, I think 29 minutes. The one on the electret shield with the tin cans, that runs 13 minutes.
Yeah,
if you have any trouble
got that one queued up, Ron, and what I'm doing is I'm not showing the whole thing. I'm just cutting to the chase, basically.
Oh yeah, fine, yeah, I've got no problem. I mean, I'm gonna finish up here. So if you wanna, like I said, when I saw that Sony made the monopolar electret back in, the only thing is I never really investigated it because I thought I had a discovery of monopolar electret. Then I realized Sony had it, and then Professor Coeth, C-O-E-T-H, University of Maryland, he made them. And then I started looking around, and the concept of homopolar, unipolar, monopolar electret, it's not new. It's just people don't know about it. And so there's so much crap to what I'm doing. And so in terms of, I'm giving myself a rest, mainly due to exposure and stuff. And I'll probably write different ratios to work out. And I might go into matrix work for a while. But so Rose was right. Rose was right. Because I've seen this in what Tim will like, also the other David who was on earlier with the Paris. When this is bizarre, with this electret here, I found out a lot of times I let my scale warm up for minimal half of an hour. Even though it's electronic and digital, there's something that I saw called weight sag, that when you take some readings and you let it sit for a while, the readings will not be stable. And so I get things warm. I run my test samples on it, make sure the my test, it's a piece of ceramic and it's not affected by humidity. And make sure I get like 5 readings to the point on that ceramic, and then I'll weigh it. And what I do is with my inversion, I started flipping and flipping and flipping. And what happens is, I've noticed this from even years ago on smaller effects, that when you start flipping them, after so many effects, you start to lose and I think it has to do with the internal motions of what goes on inside the material. Because when Tim was saying about persistence of the effects with Lifter, and Perez said the same thing when you shut the power off, but there's something.
And PNM says the same thing, and Eric Dollard said the same thing, and then it goes back through history, and it's been said again and again and again and again, all the way back to the 1890s.
Yeah, because I'm not sure if it's the benzene rings. With benzene rings, you have ring currents, and the ring currents could be somewhat I won't use the word gyroscopic, but it's probably the best representation of it. And you start messing with it, and because I had a situation just recently, I thought something went wrong with my scale, and I said, I know what's going on here, because the first thing you want to do is to say, the effect went away, it's not real, do something else. And I let it sit for a while, and I knew I exceeded its happiness point. And then it came back again. But it was just weird. I go, because my worriment is you make something, you get an effect, and then I've had this happen before. You can never, you shoot yourself. It's simply easier to get reincarnated. That's it. So Mike, if you want to describe, you want to do the short of the
Yeah,
clips.
I'm going to go ahead and share it.
Before that, just let me just interject one quick point. Ron, please, for the love of God, get a flow hood. I don't care if you have to go to Home Depot and buy a pan and a fan, but set up a flow hood, man. Please, please.
Rest assured, I am only trouble. Never mind. But
Hey, can you guys see that?
I want to save your mind because we need it.
Is that coming through? Can you see him? Hello.
Are you talking?
Yeah, we can see him.
Pound of 500 grams. And when he took it from one side of the scale to the other side of the scale, he accidentally flipped it over. And what happened is the steel plate was on the top, the dielectric was on the bottom, and the dielectric, here we go, 0 gram weight here. This is open air. And I'm going to try to get this on here. This will probably be a short YouTube. Already I'm into 5 minutes on it. So I was hoping to do a sample of 10. This is very repeatable. I've gotten as high as 0.04 hundredths of a gram differential. My goal was to get to 5 hundredths of the gram differential. This is sliding back towards the 2 to 3 gram range. And I want to see what I can film here. And this will be updated and taken down for better for everyone. So I'm going to have to go around back here so I can watch the scale. In terms of the calibration of the scale, this is what I use as my calibration. It's a ceramic coaster, and I'm going to put this on the scale. It's going to weigh about 100 grams. I'm going to tear it to 0. Then I'm going to start flipping and weighing this electret, and you're going to see, hopefully you'll see differential in the weights of it. I have no idea. This has been running good for 10 days, and now it's getting to the end of its life. And like I said, this will be upgraded. And so I'm going to put this on here, go around back so I can see the numbers, what is going on here. Oh, sorry, I got to count to 0. I'll be hitting 0 a lot, just seeing where this goes. And hopefully it will tend to show something. Okay, let's see here. I'm going to go around back. Breathing on the scale will change the weight significantly. What I'm talking about for hundredths of a gram, but we'll see. Like I said, this was getting close to demonstrating 100% gravity modification without any power, nothing, just pure internal electrostatics on benzene ring material. And I found it exciting. Whether anyone else does, I'm not quite sure. So I'm going to go around back here. Let's see what I can get here. Oh, I got. Yeah, let's put this. Let's see what's. Hopefully this is. Hopefully this will stay here. Okay, so far so good. Okay. I'm going to hit 0 this again. I'm going to start weighing this. I might take several samples. I'd like to run samples of 10 for t-tables for those who want to do the statistics on the probabilities of what the success is. So I'm going to go here. I won't see the screen anymore, and hopefully it'll. Okay, this weighs 0. But what I'm going to do is weigh the bottom. This is the bottom. The bottom should be heavier. And when I flip it over, the top should be lighter. Not by much. Okay, this is 8791. Okay, let's say should go back to 8. This is, I'm just checking. I'm just doing repeat checks on this. It might take a little while to go back to 81, 8791. I don't want to speed up the scale. Sometimes you have to. I may have to. This should take a. I'm going to start over again. See if I get 81, which is more real. Okay, it seems to be happy at 8790. Just now I'm going to flip this over and I'm going to see if it weighs less than 87. Will this weigh lower than 8790? I don't want to rush the scale. Okay, this is about what it runs. It runs about, okay, this is a 2 gram differential.
0.2 of a gram.
Yeah, let's do it again. Okay, this is 8791. It's on the margin between 8790. It's coming back to 90. Okay, I'm going to take this off, 0 it, and with this on top, I'm going to say this weighs less than 90. It's weighing about 2 grams different. I'm going to let it sit for a while. Okay, I'm going to weigh on the bottom again. It seems to want to weigh 8790. Let's see if it weighs 8790 again. Okay, let it sit there so I don't interfere with it. Okay, let's see if it weighs less than 8790. Does it weigh less than 8790? Okay, this is what it's running at. I'm going to do it again. Let's see if we get, okay, ticked off one. We've got 8790, which looks like a good weight. Going to turn this over, see if it's less than 8790. Okay, that should drop down to 88. I've been getting differentials of 3, some as high as 4. And that's about the end of the demonstration. No sense doing more samples than that. And let me see, I'm going to turn this off here. I'm going to turn this off.
So that's pretty cool, Ron. It's what's important. It's the amount isn't as important as the proof of concept in my mind. It shows the proof of concept.
Pardon?
I said the amount of weight change isn't really relevant to the proof of concept. The concept, the conceptual basis of it is you can show conceptually it works. That and if you can do 0.2 of a gram, that doesn't. There's no reason that it shouldn't be able to adjust cause significant weight loss with the proper. It should be able to be essentially weightless with the right configuration. Correct?
It's been years. The reason why I get up every day, I've seen similar, but the thing is, in terms of getting an effect that's persistent, these electrets, the main thing is people should go through, take a look at the not homopolar, monopole electret. There's some insight there. This is, the main thing is, also what's even larger, when I have a sealed cavity, I can lose 25%, and I know this cavity is sealed. On a sealed cavity, I can lose 25%, and I know there's a perfectly good seal in that cavity. And I have no explanation. I have no explanation why a sealed that.
When you say sealed, do you mean it's
in the earlier part? In the earlier part, when I had that flip over electret.
Okay, yeah.
That is sealed, like you would not believe.
Oh.
Okay, and I wouldn't say 20. I know at least 20% over. It might take a while, but all the lens, the cover on that lens, is from a CD, music disc, a CD-ROM, whatever. Right. And if there's any sublimation, that lens will fog. And so I know it's not sublimation. I know it's not getting out through the edges. I have no explanation. I don't really talk about it.
Inside the cavity besides the electret?
Well, it's in the early part.
Is it a vacuum in the cavity, or is it just?
Well, if you wait a second, I'll grab it. Hang on. Hold on.
So, yeah,
Okay, guys, sorry. Let me cut into Ron really quick. And I should apologize because I know Ron was in the middle of something, but let me see. Oops. Okay.
There he is.
Oh, Ron, let me wrong one. Oops.
That's good. Hey, more.
Nope, that's okay. No, sorry. Mark asked me to go to Brenda's camera. So Mark wants to do some more interviews. Some more presenters showed up.
Okay, well, that's all. So it's for Mike. It's all in. This is what the seal looks like.
Gotcha. Yeah,
Okay.
I was just curious if it was evacuated, if it was an evacuated chamber, or if it had.
It's epoxy, 5-minute epoxy or longer. I like better epoxy, but this is it's very good. It's perfect as you can get. So, okay. Bye, gang.
Oh, okay. Sorry about that. There. Okay, I'm gonna go to there. Spotlight for everyone. There's Mark.
Here we're back at the
okay, and we
poster
can hear you.
sessions here, and there's a couple more people who've shown up, and let's see if we can get some more information about it. So this is something we were very interested in, which is the wormholes. Gonzalo, how do you pronounce your last name? Munera. Can you give us a little presentation about what's going on? We're live here on the APEC conference.
Well, I was showing somebody my poster.
Oh, can you show us the poster?
Sure. And I'll share it to you in a minute.
Okay, we have like 200 people here watching live. So you can explain to them. You can hold the microphone.
You sure you have 100 people?
Maybe it's just one then.
Well, today we saw that people are hoping that we could get to Alpha Centauri in 100 years or so. So the idea of migration to the stars is something of many centuries, that kind of stuff. And when they get there, it's going to send a machine about this big, But there are others who think that, no, we could actually do it in a few decades if we put our minds to it. And there are two ways.
You mean a few decades of travel, or is that a few decades?
No, a few decades from now.
Oh, we could be there in a few decades.
Yes.
What would the travel time be like?
Oh, it would be about maybe 4 or 5 years.
Okay. That's almost light speed.
Yes, close to light speed. But some people thought we could do it even faster if we go faster than light. And then I talk about the faster than light travel proposals. And there are two main ones. One of them is what are called Wheeler wormholes. So Wheeler figured out that there was something called quantum foam, and then this quantum foam has fluctuations and all kinds of things, and it produces these wormholes. And if you could just grab one of those and expand them, maybe somebody else suggested, then you could send a ship through it, and just you have to be sure that the walls don't crush it, because this is extremely small things. You're talking about Planck length, so it's about as small as anything can get, and to make them huge, you have to expand them and so on. And there are some problems. No one has ever seen quantum foam. No one has ever seen a wormhole, and I don't think there is any chance that anyone would see one. They try to use something called the Casimir effect, but they completely misunderstand it. So
what is the Casimir effect?
The Casimir effect is this: if you have two metal plates, two thin metal plates, and you bring them within micrometers of each other, then I just leave them there. Actually, it's going to get even closer together. And the reason is this. He proposed that in 1948, Casimir, and then actually was shown in 1958. The reason is that space is full of virtual particles.
The quantum flux.
Yeah, and then inside too. But if you bring these two plates really close together, then particles with virtual particles with long wavelengths cannot exist because there's just not enough room for them, which means that the density outside of the place will be greater than the density inside the place. And since the density is greater, it will push the two of them together.
That's like micrometers, but how do we use that to get to Alpha Centauri?
There's absolutely no way to do any of that.
You see, so this is why I say it's a complete misunderstanding. And they say, oh, but it's negative energy inside. Only if we make an arbitrary relative assignment of value, saying, well, outside the vacuum has a value of 0, so inside it must be less than 0. That is negative, you know, because obviously it's less. But this is just a relative assignment. But the particles inside the microplates space, they are not peculiar in any way. They just have shorter wavelengths. So do many of the ones outside, except outside you also have the longer wavelength ones. So it's just a straightforward thing. There is no need for any of this stuff. Okay. And on top of that, you have time paradox. If you actually did get a wormhole and expanded it and send you ship through it, or went through it somehow, you could you would travel back in time. If you travel back in time, there's always the possibility that you could, for example, land on your infant grandfather, kill him, which make it impossible for you to be born, and then many years later get into a time machine and go back. And they have tried to fix these paradoxes in many ways, but there is just no way. Everything that they have tried is ad hoc and just wishful thinking. The paradoxes.
I mean, everything that you're talking about here is thinking. Nobody's actually built a time machine and tried to fix the problem themselves.
Of course not, and it's unlikely that anyone could.
So how do we make it to Alpha Centauri? Where is the solution part?
Well, let me give you just one more thing. Then there is the warp drive by Alcubierre. And Alcubierre, right here, he figured the following. He figured that if you had a spaceship and then you could expand the space-time behind it and contract it in front of it, you could accelerate this actually after a while faster than light.
Oh, very cool. How do we do that?
Pardon me?
How do we do that? How do we contract and expand?
That's the trick. This is consistent with general relativity. It allows you to do that. It's like a man who is being on a surfing board, and he's riding a wave, let's see, and relative to the wave, he's hardly moving at all, but relative to the beach, he's moving extremely fast. So that's the basic. So this bubble of space-time, and inside that bubble, everything works okay. Okay, but the problem is how to contract here and expand it, and he hasn't figured it out. It doesn't look like he's going to, and he's beginning to give up himself. So the way it's going right close to the speed of light, and you could do that with what is called a Whitmire catalytic nuclear ramjet. Okay, and it's what it does. It scoops up. It doesn't need any fuel. It scoops up ions, hydrogen ions, and that lots of those 1 per cubic millimeter out there, so or centimeter, and I'm getting power now. So
it's basically accelerating it and then pushing it out the back.
Right? It has each one of these, and it has a big scoop, electromagnetic scoop, and this electromagnetic scoop is that I pictured 3 of them here, but at any rate, it just scoops up all the ions that are outside and runs them through this nuclear accelerator,
a linear accelerator. Right?
Well, no, it's a catalytic nuclear ramjet. I don't know if you can see this, but this is the reaction. It starts one way and ends up exactly in the same place, plus 1 atom of helium, and also some some radiation that all that can be used to send it out. And then what are you moving here? Well, you're moving O'Neill space colony full of scientists. Why? Because if we do get to another planet, we don't want to just send it. I mean, to another solar system, we don't want to send just a little machine. We want to prepare it if we're going to have migration. That is, we have to have people turn those exoplanets into habitable planets. So only scientists can do that, and well, engineers and so on can do that sort of thing. So that's what we would do,
Okay.
And this white mirror ramjets can produce velocities very close to the speed of light, and on top of that, what do I have here? Yeah, they can generate. This is the energy as much as 10 to kilowatts, which is about 10,000 times the energy produced in today's world. So this can really have the power to get us to another star system in a matter of just a few light years. People, by the way, these space colonies of O'Neill are self-sufficient. You know, are huge and all that. That's why I have 3 of them. You know, take it over there. So we actually say if we build this in 40, 50 years, and we already know how to build the space colonies, O'Neill space colonies. And I think in principle we could also build the nuclear catalytic.
Very cool. What's your name again? Gonzalo Munevar.
Yeah.
Did I say that right? And where can people learn more about you?
Well, I'm writing a book about it, so they can read more about it. It's going to be called the Dimming of Starlight.
Okay.
And it's going to come out soon. In the program, there is a paragraph about me, so you can learn more about it.
And that's your email address up there?
Yeah.
Okay.
I actually gave it to somebody up here. Yeah.
Okay, Gonzalo, thank you very much. We really appreciate it.
Who are you doing this for?
This is APEC, the Alternative Propulsion Engineering Conference.
Oh.
And we're on it live right now. Thank you very much. You're now an APEC member. Okay, here.
That particular one operated between 2:30 and like 4:12.
Are you a presenter for this poster? Oh, Albert Jackson. Can you give us a short interview? Show us what's going on?
Okay.
We're on APEC, which is the Alternative Propulsion Engineering Conference. We're actually streaming live right now, and we have lots of viewers online and on YouTube as well. Can you just show us real quickly what's going on here? You can hold the microphone.
Oh. Yeah, this is
hold it close to your mouth. There's a lot of background noise.
Yeah, this is about the Interstellar Ramjet, which was
closer to your mouth. Yeah. Closer to your mouth.
Oh, okay. Which
that's good.
Was invented in 1960 by Robert Bussard, and the whole idea was to. Well, there was a problem in relativistic spaceflight in that if you carry your fuel with you, it turns out to be a totally unrealistic amount. And so after, this is an illustration of the problem is that further you want to go, the bigger the amount of mass you have to have for fuel. And so, well, these are 2 guys who were pioneer, Eugen Sanger and Les Shepard in relativistic spaceflight. And in 1960, the physicist at Los Alamos, Robert Bussard, conceived of the idea that you got your fuel from the interstellar medium and you just scooped up hydrogen and put it in a reactor and fused it.
And jammed it out the back. That's pretty much what we heard in another poster around the corner. Is this a similar device? We're scooping up hydrogen and shoving it out the back like a rocket.
Well, you have to fuse it first.
Yeah, he was fusing it into helium
in a reactor. And well, that was in 1960, and nobody did much about it until this young guy here, who is a senior at Caltech, MIT, wrote a paper in 1969 that, well, he mainly figured out how to generate a magnetic field that would scoop the hydrogen into the reactor. And so there's a lot of technical, The bottom line is that you have the ramjet going this way, and there's interstellar hydrogen, and you generate a magnetic field that's a scoop, and you scoop the hydrogen,
and put it into a reactor. And that's the basic story.
Okay. Where is this technology stand right now? When are we going to see this in practice?
Probably about 500 years.
That's right. If at all. Okay, where can people find you? Where can people find you if they want to learn more?
Well, I'm retired.
Okay, Albert Jackson. Where do you what are you associated with?
I worked for 45 years at the Johnson Space Center doing, I wasn't doing this.
You were doing rockets.
Well, I was an astronaut trainer in the 60s. And I did flight planning software, I did orbit debris, I did engineering simulation stuff.
Wow, you sound like a very interesting guy. Thank you very much for joining us here on APEC. We're going to continue on. I'll bring the laptop. Okay, so that was a similar concept to what we heard earlier. Let's see if there's any new presenters. Atomic beam space propulsion. Avery Davis. Okay. No. Let's move on. I don't think he's a presenter. He's not a presenter. He is? Are you one of the presenters here? No. Okay. Let's continue on and find some more of them. I think we got them all then.
Okay, well, Mark, that's great. That is great. Well, thank you, sir.
I think that's it, folks. We can shut this down now. This is the presentation room here at the Interstellar Research Group. And that's the laptop. Signing out, guys.
Okay, so we removed Spotlight. Let me see. Ron, you were oops. Let me see. Ron, you were saying, let me ask you to unmute. I'm sorry, I feel guilty about cutting you off. And then Michael's probably gone for dinner as well. Okay, well, we will go back to open discussion if anybody has anything, and if not, oh, there you are. Okay. Yeah, I'm sorry, I didn't mean to butt in. Mark pinged me on the phone, and he's like, I got more people. Let's wrap it up. So
I think it's all good. I think I actually think we're done. I know I'm about ready to wrap it up. So
I think I'm just about there too. Well, I think we had a really.
I think Ron's still online, but he's not there. He's off doing something. So
yeah.
So, but yeah, it was. I enjoyed myself very much. So.
Yeah, well, thank you for coming today. I was really nervous, and I mean, so our mailing list was at around 480 people, and those articles came out. It's at like 800 now, right? And so, I bumped up my Zoom account. There's Carl's back. I bumped up my Zoom account to reach 500 because the rule of thumb is that only about half of the people or less will show up. But it looks like in terms of today's conference, there's a little bit more folks than usual. But.
Yeah, in the beginning there was definitely a bigger crowd than usual.
Yeah, well, I don't think it helps that the articles were like DARPA and MIT physicists. They try and play it up and make it something like it. But I mean,
yeah, well, people have I don't know. It's kind of like they want to categorize, and it's not.
You can't have fear if you want to believe in science. You can't have fear. I mean, science is, there's no fear in that equation. So, it's either now or never.
Well, it's true. I have lots of anxiety though. Does that count?
But that's normal. Everybody.
I mean, listen, if the intention is really science, I mean, we're creating something like evolutionary, something that like, great minds are being challenged into. We need something now,
Well,
and,
I would agree with you. And, I think for me, because I'm 45 now, and I think one of the things for me that's more interesting, I mean, I'm not old, right? But I'm thinking more long term and thinking more about legacy. And one of the things that really excites me is to be able to capture the legacy of so many of these visionary thinkers, right? I mean,
I mean, this, like, whatever we're doing today and and times in the past, this propagates. So it's like a filtration system. If the universe understands it, the quantum universe, it continues. Whenever there's incorrect information, a roadblock will intercept it. That's just how the universe works. And so, today is one of those days where you really have like really, really bright people, like, they're above everything. It's more
it's a good point, and I think there have been moments, and I think we've probably all seen them. There have been moments in this conference too where, you can almost see the light bulb go off, and I think that's one of the exciting things about cross-pollinating with so many different backgrounds and just that diversity of thought and knowledge and experience is, there have been several times where you see a couple people talking and there's just that light bulb that goes off. You could see it in someone's eyes, and it's like, that's an idea, and they're going to take that and they're going to build on that. That's what you're talking about, Lulu. It's like that.
That's how, like, we transfer energy's information. I mean, this is how we're structured. We're sonic beings, so words define us. They propagate different sounds, vibrations. Our construct is that we're so I love it. I mean, it's beyond amazing. I'm really happy to be a part of this group, for real.
Well, thank you for and thank you for attending.
So I got to check out. I got to get ready for my quiz. I have a quiz in my construction energy management class. So,
what is this one you're taking or one that you're teaching?
No, I'm a lifelong.
Okay, class you're taking.
To the community college. I got my anthro degree in 2019, and I had 2 classes left to do my construction energy management degree, and I'm taking them this quarter. And so I like to learn. It's fun. It's a lot easier when you go back. It was really.
Yeah.
I was in undergraduate at UCSB, man. I struggled every day.
Because there's not as much pressure, right?
No pressure.
No pressure. Yeah.
I'm doing it for fun, not for a career move, right?
Yeah, and community colleges, by the way, is the best and cheapest way to entertain yourself if you can find a good community college, because you can spend $100. I don't know how much your credit is these days, but it is better than the History Channel. It's better than anything you'd watch online or do. Go to a community college, sign up for a class. It is the best gift you can give yourself. It really is.
I used to be a software developer, for basically I automated test equipment. So I take your oscilloscope and hook it up to my computer, and basically I got in trouble for letting the computer do my work. But that was like back in the 80s and the 90s. So back in 2013, my son was doing his undergraduate in computer science, and he was talking about this teacher he had who was kind of moody and stuff. And then I talked to him about it, and he was all upset. And I said, well, where did he work for before he worked at Cabrillo? And he says, oh, he worked for Apple. And I said, oh, is he kind of moody and difficult to deal with? And he goes, yeah. I go, oh, well, he worked for Steve Jobs, and Steve Jobs was really hard to work for. And he's probably suffering from PTSD right? And so he learned how to. He went back. He didn't give up, and I said, find out what he likes. Find out what he likes. And so then, like 3 months later, he's like, oh, he's the best teacher ever, right? And so I said, well, maybe I should take a class in computer science. It's only been 25 years, and so he had this class in writing apps on your cell phone. And so I took this class, and the first half was iOS for Apple,
Yeah.
and then the second one was Android, and basically it's Java is what they use. So
Android is mostly built on Java, and I hate Java. I'm raising my hand. Hate Java.
But basically, I learned how to do Java. Java and iOS are real simple compared to C++ or something like that, right? So I learned that, and then I aced the class. And what I did for my project was I hooked my cell phone using the audio cable up to my Geiger counter. Right? It's got an audio jack here, right? And so I wrote a little FFT function that would like make the little bar graphs and show counts per minute, stuff like that.
So the one Java has improved a lot, but if you were doing stuff like that, you might look at like Swift. There's a lot of next generation languages that have come out now.
When I finish my construction and energy management degree, that's what I'll probably do is look at some of those other more commonly used application programs, because I like to keep up to speed. That's why I like to learn. It's just really fun to learn stuff.
Yeah.
That's why I'm on here. Like I told Jeremiah and some of those guys, like I gave up on trying to understand quantum mechanics, and really that's why I'm here right now. Like I want to understand quantum mechanics, and I'm grasping that stuff right now. And it's
just getting your waves and particles mixing.
Well, no, what's happening is everything is becoming more tangible. All of these ideas are becoming more real, and I have mental ideas about how these things should be operating if I were to apply some type of quantized function to these things, and I should expect results. I don't need to know what is happening inside the box, but I should expect a quantized result, and I can understand the quantized result. I don't need to understand the box, but I can get a picture of things that's very concrete that way, and that's what I'm getting from this entire experience through APEC.
I mean, and then one of the things that's really, for me, that's been really intriguing, and it's not really APEC type stuff, but quantum computing, right? And I've been following that for a long time, but that's intriguing. And there are things that I wonder about, like somebody had proposed, again, I don't know. I don't think anyone has disproved it, but what they were saying is, your quantum spins, right, on the older style, that can either spin left or spin right, basically, and that's how they measure the bits. They set up the equation, measure their bits, and one of the scientists was saying something to the effect of, he said that it can do one measurement and do all of these calculations simultaneously. He said, but is it really doing one measurement, or is it doing one measurement across an infinite number of parallel universes? And so he said, if that's the case, quantum computers are basically a proof of many worlds theory.
Well, it's a superposition of states. And so is how many states can you superimpose together?
Yeah, but see, and his thought was, because supposedly it does one calculation, it arrives at the correct answer, and he was trying to. This was, I think I read this probably 15 years ago, so things may have changed since then. But he was saying is that a proof of many worlds? Is each one of those states, does each one of those states represent a parallel universe? If so, then in his view, that could be a proof of many worlds. I might not be expressing that correctly, but
it's true for electrons. I could say, you could say that is true for electrons because an electron has a spin of a half.
Why is Michael muted?
Which
Can you hear Michael?
Yeah.
No, Michael, I lost you. No, it's me.
Oh, okay. Can you hear me?
Oh, yeah, I think it's you, Carl. I think it's
okay.
There. Oh.
Okay, so you know, the electron has a spin of 1/2. So that means that to come back to the, if you spin it 720 degrees. So if you spin it 360 degrees, it's the opposite sign on the spin.
Yeah.
If you spin it 720 degrees, it goes back. It's like 0, right? It goes back to the same. So electron spin, but an electron, each electron is identical to every other electron. Okay, so in that example you could do it, but if you have a particle that has a spin of 1, then you just turn it once and it comes back to where it started. So it's that weird property of a spin of a half. And now I've been researching proton spin, because protons, they're postulated to have a spin of 1/2, like an electron. But but if you take the quarks, you have the 2/3 a spin, one quark, and 2/3 spin another quark, and a minus 1/3. And if you add those all up, you get a spin of 1. Now, what makes us, if you got a spin of half, though, you can't have 2 electrons in the same energy level, right? A Pauli exclusion principle, they call it. And so, but in a spin of 1, you can basically stack them up on top of each other. They can be in the same energy state. So I theorize that what's going on in the black hole, or is this collapsed matter, is the reason you get so much matter into such a small space is because you can stack all the protons on top of each other. You couldn't do that with electrons because the Pauli exclusion principle prevents you from having 2 electrons in the same energy state.
Okay.
You have, like your valence band electron, which is before it's excited, and then you have an excited state, which is called a conduction band electron. So, but you can only have it in you can't have 1 electron in the 2 electrons in the valence state.
Yeah.
Exclusion principle. So they're both the same electrons, okay, but they're all identical, but they're not like spin 1 particles where you can stack them up.
I see what you're saying. So,
just a thought. But I really should go. I gotta.
Okay.
Appreciate. I love this. I love this. This is my. My wife calls it my geek fest.
Well, yeah, I think I think that we probably wound down for the evening, so we'll probably call it a day. Unless, Carl, did you have anything else? Or
no? Listen, man, if Michael's hanging on just to talk to me, I feel like this is just a wonderful moment to thank you for Michael, and you as well, Tim. So
oh, absolutely. Well, you guys have a nice evening. It was good to see everybody here. It was good to see Lulu here again. I'm excited that we had so many folks here. So, okay, well, I will have a great evening.
Be well, everyone.
Thank everyone. Thank you.
Hey, where's the? Oh, the meeting was ended. I'm going to end the broadcast. Thank you guys for watching, and that was an epic 7-hour stream. Wow, I hope you guys learned as much as I did. That I got to go back and watch a couple parts because that was the most epic APEC I think we've had yet, man. It's definitely right up there, man. Definitely, if you missed any of the guests, go back and watch this. This was one for the record books, guys. Holy crap! Thank you so much.